টাইমিং দেখেছিস? বাপ বল বাপ। টাইমিং দেখেছিস? ভেঙে গেল। अच्छा आपके पास है आपके पास अभी कोऑर्डिनेशन नहीं थी, इसलिए मैं बोलूँगा अभी कुछ नहीं थी। अभी रेडी है तो लाइट वाइट कुछ कम कर दो। थोड़ा सा पीछे थोड़ा लाइट कम कर दो। ये लाइट कम करवा थोड़ा सा लाइट कम करो। দেখা যাবে স্ক্রিন ভালো করে দেখা যাবে থাকবে। ওখানে দেখা যাচ্ছে, এই তোর ওখানে দেখা যাচ্ছে প্রবলেম। बैठो बैठो। चलाना कैसे है देख लिया ना। हाँ चलो 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 चलो।
Very good morning to all of you. At the outset, I regret that the program has delayed due to some glitches. So I am very sorry for that. But let us move forward towards the program. अनेक संशयोच्छेदी परोक्षार्थस्य दर्शकम सर्वस्य लोचनम शास्त्रम यस्य नास्त्यंधम एव स means it blasts many doubts, foresees what is not obvious. Science is the eye of everyone. One who has not got it is like a blind. Suprabhat, Namaskar. NTPC Cell Power Company, NSPCL, the institution which is always aspiring for excellence in the new energy dynamics, welcomes all of you on this occasion of 8th Random Meet 2023. The trajectory of success which NSPCL has reached in its march towards excellence of more than 21 years is considerably illuminating for industries, especially when we are engulfing surge of big enterprise leading to insolvency. Whatever is achieved is because of coherence, consistency, and quest for excellence, which its manpower has imbued in itself. Of course, the rich experiential benefit of NTPC and SAIL as our promoters has paved its way, but what come of its teeth and substance is NSPCL culture. No industry, especially in the midst of rapidly fast technological dynamics, can achieve success or can consistently keep hold of market unless its technical potentials are given rethinking and re-engineering. The challenges ahead are strategized to win over, and cognizant of this aspect, this is the meet we have organized. The contemporaneously relevant theme of today's conference is improvement in reliability, efficiency, cost optimization, and future of thermal power plants. So, as a customary practice of anesthesia, we shall start this meal with anesthesial gift. I request all of you to please stand up for the anesthesial gift.
लक्ष्य हमारा खास है, देश को भी आस है, लक्ष्य हमारा खास है।
फौलादी साथ है, खुद पर विश्वास है, देश को भी आस है, लक्ष्य हमारा खास है। सृजन हो रोशनी का, वादा हम सभी का, ये इल्म है यकीन का, काफिला रोशनी का।
साथ लिए शक्ति का ध्वज लहरा, प्रकाश का धरा से अंबर तक आगाज है तरक्की का। लक्ष्य हमारा खास है, लक्ष्य हमारा खास है, लक्ष्य हमारा खास है।
In the city of industry, the city of inspiration of legendary Dr. Bidhan Chandra Rai, it is momentous occasion for anesthesia to aspire for holistic deliberations on best O&M practices. To formally begin the event, I request honorable dignitaries to light up the lamps. I request GMOS and commercial to kindly escort them to the lighting.
Thank you, sir. Thank you, everybody.
Thank you, sir. Now I request our GM DH Durgapur Commissioner Jha sir to welcome the dignitaries by presenting them plant and Shaukan Vastram. First of all, I request Shri Indrajit Basant sir, Director NIT Durgapur. Shri Arup Sarkar sir, Member Finance, DVC.
सामने ना
Shri Anup Kumar sir, EDCCS2.
सामनेটা সর পল্টু পল্টু পল্টু
Shri Subbaraj sir, ED LIC Plant. PK Sarkar sir, Director NSPCL and CPM LIC Plant. Shri SK Srivastava sir, Director NPTI. Shri SK Ghosh sir, AD Operation DVC. Shri V. Chattopadhyay sir, CEO LSPCL. Shri Sudhir Jha sir, Project Head Durgapur Steel Thermal Power Station, DVC. Sri Sushant Sani Sir, Project Head, Media, Rural Education,
Please come.
DVC.
Please come, sir. Sir,
Welcome,
please
sir.
come, sir.
Thank you, sir. I further request DO Jha sir
Sir, please, please.
to kindly accompany the dignitaries to the dais.
सर, इधर से जाकर हाथ लगा दीजिए।
ये सामने का शॉट तो थोड़ा
सॉरी
यूट्यूबे চলছে আরে ঠিক আছে লাইভ চলছে সব কিছু গাল দিচ্ছে সোনা তুলে দাও রেকর্ড চলছে তো এটা রেকর্ডিং চলছে তো
Thank you, sir, for gracing the occasion.
আমি একটু কম্পিউটার নিচ্ছি তুমি আমি কিছু নোট দেখো কথা বলছে সেটা একটু দেখো কিছু দেখো তার প্রদীপটা নিয়ে আসো
I would now request Sri Kameshwar Jha GM and Business Limited, Durgapur, to welcome the dignitaries to his welcome address because he is the key man who has strived hard to organize this meeting. Jha sir.
Most respected Professor Ajit Prasad sir, Director of NIT Durgapur, Sri R. Gulraj sir, ED Durgapur Steel Plant, Sri Anup Prakash sir, Member Finance, DVC, Anup Kumar, EDC CSO, SAIL, Sri Subraj sir, ED Ever Steel Plant, Sri P.K. Sarkar sir, Director NSPCM, Sri D. Chattopadhyay sir, CEO NSPCM, Sri Sanjay Kumar Ghosh, ED Operation DVC, Business Unit Heads of DVC Media, DVC Andal, NSPCM Bhilai, Raurkela, senior officers of SAIL, and my colleagues from NSPCL headquarters Delhi, distinguished power plant professionals, Sri S.K. Srivastava sir, Director FPDA, and distinguished participants. It is my proud privilege to welcome you to the 8th meet of one-day meet of NSPCL. Myself and my entire team of NSPCL Durgapur is thankful to NSPCL management for providing us the opportunity to host this prestigious event at Durgapur, and I also express my sincere thanks for your gracious presence. Sir, it is said, अपूर्व कोशोया विकते तम भाति बैतो बुद्धि माया की छाया माया की संचया. Repository of knowledge grows by sharing. To showcase their knowledge acquired through their experience in efficient, safe and reliable operation as well as innovative maintenance practices. We have some 18 papers to be presented today by eminent power plant professionals from Technobit, NTPC Sample, Jindal Power Limited, ISET, GE, Marathon Power, DVC, BPSCM, SAIL, ASP, NSPCL Bhilai, NSPCL Raurkela, and NSPCL Durgapur. Organizing such events is a inbuilt culture of NSPCL or sharing of knowledge and expertise so that entire industry gains by the experience of individual plants. I congratulate the participants for their sincere effort in preparation of the papers and wish them all the best in their learning pursuit. My sincere thanks to participating companies for their active participation. Once again, I welcome you all on a journey of growth through knowledge sharing. Wish you all a happy learning. Thank you.
Thank you, sir. The operational strength of any organization depends upon visionary leadership and its technical vision. And SPCL had good fortune to be headed by dynamic and outstanding technical professionals. Amongst others, our GMOs of GS and commercial is known for trade towards excellence and eye for best practices. I would now request GMOs and commercial Sri Dev sir for his address. Dev sir.
Good morning, everybody. Honorable Shri Indrajit Basa, Director NIT Durgapur, Shri Suparlal Sahib, ED Alloy Steel Plant, Shri Arup Sarkar, Member Finance DVC, Shri Anup Kumar, CC Associate, Shri PK Sarkar, our Director and CGM Services, Alloy Steel Plant, ED Operations and Chief Engineer of DVC, whosoever are present here, Shri Devashish Chattopadhyay, our own CEO, Shri Rajiv Srivastava, our CFO, our PVH from all the stations present here, and not the least, the participants from ISJEC, GE, NTPC, NSPCL, DDC, BPSCL, and all other companies. A very, very good morning to each one of you. I understand we are slightly late and we have to undertake 17 presentations. Still then, we'll try our level best and try to conclude the session within the scheduled time. It is my proud privilege that after 3 years of COVID, the last meet that we had was in 2019, and this is 2023, again we are meeting. The main reason being, we could not gather together due to COVID. Now at least the physical presence have again started, and I'm proud enough that we could arrange such a meet, O&M meet at NSPCL Durgapur. The first O&M meet of NSPCL was held on 18th January 2013 at PMI in Noida, with the theme striving for operational effectiveness and sustainability. Since then, we have put an effort to conduct the meet every year. However, I have already explained the last 3 years we could not arrange the meets. We started as a very small company in 2001 with a 314 megawatt capacity. We added 2 into 500 in July, became 814 megawatt, added another 1 into 250 megawatt in Rourkela this current calendar year, and 120 megawatt unit in Durgapur, and today we are a company of 1084 megawatt. Generally, being a small company, we used to limit ourselves to Delhi for arranging this type of meets. But later we found that if we go to the sites and arrange such meets, the participation from our own plant as well as sale increases, and if it is nearby, just here we have DPC, we have Python Power, so that the participation increases. If it is in Delhi, those participation reduces. Last time we had in July, where we had Chhattisgarh Electricity Board and other persons coming to attend. So we have decided to go on rotating the O&M meet from one side to other side of NSPCL and try to do our best so that we share the knowledge and gain knowledges as far as possible from this meet. I am honored that power professionals from Tata Power, Jindal Steel, Steel and Power, EasyJet, DBC, NTPC, GE Power, BPSL and Technobil are here to share their relevant experiences beyond the papers that will be presented by our own NSPCM colleagues. I am hopeful that the rich experience shall be of great help to us, and we shall certainly carry something out from this meet so that it comes to our requirement and we can use it as and when necessary. I thank Sri Indrajit Prasad, who even after his busy schedule has taken some time. I talked to him yesterday. He agreed to come. I am very much thankful to him, sir, and thank you very much for being here. I am thankful to Mr. Subbaraj also. Yesterday only I had spoken to him and I requested him to be here. Sir, thank you for your presence. We are really proud for you being here. Mr. Arup Sarkar is our own colleague, so he always tries to adjust to all possible ways NSPCM has. So I thank Arup Sarkar being here and participate in the book. I thank Mr. Anup Kumar, PDCCSO, who on my call always agreed, even in some other functions also, whenever I have requested him to attend the program, PDCCSO Mr. Anup Kumar has always accepted my invitation and had attended the meeting. I thank Mr. P.K. Sarkar, who has come from Bhilai Steel Plant and to attend the meet. And thank you, sir. Thank you very much. I thank Mr. Sanjay Ghosh, ED of EasyJet, BPSL, all other Technobuild, all others, those who are present here. I thank each one of you for coming here and to enlighten us today. The theme of this year's meet is improvement in reliability, efficiency, optimization and future of thermal power plants. We all, in today's day, think of renewable power, and somewhat we are skeptic what will happen to thermal power. I think we can discuss a lot today and come up with a solution what will happen to thermal power. I am pleased to intimate that we are at 1084 megawatt, but we have in our fleet around 314 megawatt which are running for last 30 years. So the challenge for us is to run those units because SAIL has to take power from us and SAIL is dependent on us. So to run this fleet is a challenge to us. So the team has been designed in such a fashion as to enable us to interact with you and find out ways so that we can run those fleets for another at least 10 years more. Safety is the highest priority for all industries. Management is putting all efforts and utilizing the present day technology to make the industry a safe one. We have representatives from Technobil who are rich in experiences of handling safety, and we will start the meet with the safety presentation. This meet is generally held for sharing of knowledge amongst different project leaders. It provides a platform for interaction of technical professionals for similar industry, to know each other and to exchange ideas relevant to individual industry. I hope that we, during this meet, interact with each other, know each other, so that we can communicate better, and whenever required, we come to each other's help. I would wish that this meet helps us in this regard also. I understand that top professionals present here are working hard in the present challenges scenario and adapting to different regulations and are implementing modifying systems to improve reliability, efficiency and safety. Their experiences from today's meet shall go a long way to help us. This meet shall form a media wherein we can interact with each other and try to share our experiences. Just for your knowledge, in financial year 22-23, the PLF of NSPCL is around 80%, and the availability is around 90%. Generally, we keep availability of around 90% for the last 5 years. I am very hopeful that during the deliberations and brainstorming sessions in this ONM meet, we would come up with the ideas to mitigate the existing challenges. With this, once again, I extend my warm welcome to all of you and hope that your valuable advice and guidance during the course of this meet shall help each one of you, us present here. I really thank each one of you who is present here, and especially thank all the participants who have come from different parts of the country to participate in the meet. Thank you, sir. Thank you everyone.
Thank you, sir. Respected members, we have as an industry a vision, a roadmap, a dream, a passion, and above all, an effective leadership. I now request Honorable CEO sir to deliver his keynote address of this meet, outlining the contours of days ahead for us. Honorable CEO sir.
Thank you, Gary. A very good morning to all. Most respected Sri Indri Kotak, Sri Arun Sarkar, Sri Anup Kumar sir, Sri B.K. Sarkar sir, Gora sir, Ghosh sir. Once again, good morning to everybody. First of all, I would like to take the honor of welcoming each one of you to this 8th Wenham meet of NSPC. We feel extremely proud to be hosting this meet today with you all. Before we start this meet, I would like to extend my sincere gratitude to all those who generously come forward in making this meet a huge success. It wouldn't have been possible without you all. I have seen here my colleagues from NTPC, my colleagues from NSPC, my colleagues from SAIL, and participants from DVC, HJ, and GE. I welcome all of you here. It gives me immense pleasure to say that your last year has been extremely successful for our company as we have commissioned 2 of the new units. One is a 1 into 250 megawatt Rockela unit, and the other is a small unit, that is a 20 megawatt ABC boiler in Durgapur. And we hope that Durgapur will be commissioned. The other unit of Durgapur 20 megawatt units will be commissioned before we meet in before the next meet. The theme of this year's Wenham meet is improvement in reliability, efficiency, cost optimization, future of thermal power plants. Basically, there is a paradigm shift in the power technology in the last few years, and to my mind, we can deliver it on the cost of power, the availability of power 24/7, and the environment. These 3 things are to be kept in mind before you go for any power generation kind of thing. Though NSPCL PP2 units are quite old, but in captive units of SAIL, the role of these units is very crucial for the uninterrupted steel production of the same. You have to be very much focused in maintaining the reliability of the captive units. On the other hand, efficiency and cost is also very important for controlling the power cost of steel production. Thus, I hope this learned and experienced gathering will certainly come up with many new ideas through interaction and sharing of the rich experience. It is very evident that thermal power plants are here to stay for a quite long time as the main source of power, even after addition of renewable energy. That's what I was saying, what we have to see the cost of power of thermal power plants, cost of power from the renewable kind of thing, and how we can make 24/7 power to everybody, and obviously the environment. Thus, it becomes our responsibility to run these units in an environmentally friendly way. To achieve this goal, all the thermal power plant fraternity should work hand in hand by sharing their best experience with each other. I am sure the journey ahead will be much more exciting and eventful. Wish you all the participants a very enriching and knowledge-sharing experience from this meet. And I think some takeaway from this meet will be there for everybody, so that we can enrich our life, we can do something for the power industry. Thank you. Thank you.
Thank you, sir, for encouraging words. NSPCL is a very unique organization, having overlapping of its promoter as well as customer relationship. As we are aware that same is our promoter as well as our prime customers. So this is our strength. We are privileged to have presence of Shri P.K. Sarkar sir, who holds a wide experience in industry. His views are bound to enrich our vision. This August gathering will be illuminated by his speech. So I request Sarkar sir to kindly deliver his address.
Good morning, one and all. Respected dignitaries on board, Professor and NIT Durgapur, Dr. Arup Sarkar, Member of Finance, DVC, Dr. Sri S. Sovara, PDS, Steel Plant, Sri Anup Kumar, EBC CSO, SAIL, Sri D. Chattopadhyay, CEO NSPCL, Sri S.K. Ghosh, PD Operation, DVC, Sri Arup Sarkar, Member Finance DVC, and participants from nation's prestigious power plant and allied services and senior officials, those who are running the power stations efficiently. And ladies and gentlemen, very good morning to all of you. It's my proud privilege to welcome you all in this learning meet. As it has already been mentioned by Tridi, our GM Modes, and especially the 50-50% joint venture company of two mature Navratna PSUs, SAIL and NTPC. It became live in March 2001. Since then, NSPCL has been running captive power units of Reliance Steel Plant, our Durgapur Steel Plant, and DSP seamlessly since inception. In addition to these above units, NSPCL has gradually augmented its capacity to 50 MW in Reliance Steel Plant, 220 MW in RSP, 20 MW in Durgapur, and another 20 MW is expected shortly at Durgapur. Over the years, NSPCL has diligently maintaining these units, achieving a level of reliability and efficiency which is at par with industry standards. NSPCL has been organizing O&M meet since 2012 on topics and issues those are relevant in running these thermal power plants efficiently. I am very happy that NSPCL has invited me and witnessed to this O&M meet. Today's meet is about improvement in reliability, efficiency, cost optimization and future of thermal power plants. This is the need of the hour. Thermal power plants globally is facing challenge. Its existence. The reason being very obvious, there is a judicious shift towards renewable sources and also a threat of depletion of natural reserves. As there is a strong shift to other sources like hydrogen fuel cells, solar, even then, still thermal power plant retains its relevance. And there is a need to create a huge energy requirement of our vibrant growing economy. Hence, I believe that this meet will open up and certainly shall provide platform to the power sector professionals from across domestic companies to share their best and innovative concepts to effectively operate these thermal power plants in order to meet our country's growing demand. I am sure the day-long brainstorming session will be the enabler to pan out best of output, which shall help in further improving the operational activities and make these efficient and worth of quality service. I wish you grand success once again. Good morning to everybody. Thank you.
Thank you, sir. We have the presence of ED Operation CSK Ghosh sir, DVC. DVC is unique in generation, distribution, transmission, dealing with all the matters. And sir will, through his address, illuminate this assembly of technical things. Sir.
Good morning, everybody. Most respected dignitaries present in the dais, the dignitaries present in front of me, and participants, the most valuable persons for today's deliberation. I think it is a most opportune moment for me to grace this occasion. Y&M practices is a very, very important area now at a time, because we are running the units and we are facing lots of challenges nowadays, especially as far as demand is concerned. So far, generation we are seeing that around 12% growth is there. So that's why sustainability is most vital area that we have to look into. And in DVC, we are seeing that if we maintain the generation continuously, then only actually we can fill up the demand. So here actually we have to concentrate more how to maintain sustainability. And another important area is the integration of power, that is thermal with the renewable, which is the need of the hour. Every day basis actually we are seeing, if we are doing the flexible operation of the units, optimization is very, very important area. How to maintain the efficiency of the equipments, that is the most vital area we have to look into. I think these aspects will be taken care of today's discussion, and all the participants, they will also give their valuable ideas how to optimize the generation, how to optimize the efficiency, how to optimize the Y&M cost. Because if we do not optimize all these areas, automatically this Y&M cost will not come down. But it is also an area where we have to look into. And another important aspect is fuel saving, how to save the fuel. Because in last year actually we have faced lots of problems in the fuel aspects, especially this supply of coal. And so many things actually we have done in the last year. We have procured imported coal. Some of the central sectors actually they have concentrated for this procurement of this imported coal. And parallelly actually we have to do this coal supply through RCR facilities. Those we have adopted. But by importing coal, this ECR has increased. So this time actually we have to see how to optimize, so that actually we can optimize this ECR also. So these are the areas I think in today's discussion this will be taken care of. And I hope this type of Y&M conference, if we go on organizing, then automatically everybody will be benefited. All the participants will be benefited, and all the power utilities and all the steel industries, they will also be benefited. I wish grand success of this program. Thank you.
Thank you, sir, for charting the different aspects of power plant operation, as well as whole from coal to ash and managing. We are hopeful that out of this conference we will certainly come to some solutions of the challenges facing. Availability of fuel, its management, its optimum use, and use of technology to suit its potential are some of the flag issues for NSPCL. We are facing coal crisis also at this time. So NSPCL as a generator, we are fortunate that these things are taken care by CCSO SAIL, and our extended family is our best guide on these aspects. I would now request worthy Executive Director CCSO Sales Shri Anup Kumar sir to take us to his views on our manifesto for the future. Shri Kumar sir.
Very warm good morning to all. Respected dignitaries sitting on the dais and off the dais, ladies and gentlemen coming from different organizations. The topic chosen today is a very pertinent topic, especially the part, the challenges before the fuel like coal-based boiler plants, whether it is sustainable in the long run or not. When the prevailing requirement of the country, we are talking about carbon neutral by 2070, then it's a big question how to go ahead, and if we not start today, maybe we are slightly late. We must have thought of before, but we have started and we are thinking on this. So we have to switch over from this power to the renewable power. This is the requirement. As far as today's scenario is concerned, and the journey for at least another 10 years, you can say down the line, coal will continue as a fuel for the power industry. But there is a big question or big challenge in the supply and demand of coal in the power sector. Presently, power sector has been divided into two parts, a grid power and a captive power plant. All forces are working towards supply of fuel to grid power makers, and we are deprived as a captive power plant units, especially the place where NSPCL is working with SAIL to generate power, which is of very high captive, or this is a very what you call essential power for the units. Even if we are taking or we are importing power from the power grid, none of a steel maker can slip comfortably when their power plants are not working at full swing. The reason is there are a lot of equipment out there which cannot even survive for a minute of power failure. So these essential units need to have some power in the unit so that at a crisis period that can be met. Of late we have seen that when the priority was given to the green power sectors, we were virtually left with no coal at all. In the last 10 months of this financial year, you will see, especially ACCL, who is supplying to Bhilai Steel Plant, MCL to Rourkela Steel Plant, virtually are working at the level of 15% and 23% respectively. So, to meet the requirement, we have now switched over from run-of-mines coal to washed power coal. Somehow we have been able to manage. As of now, the requirement for NSPCL are as a totality sale plant is around 4 lakh tons per month. And the new 2 units, what earlier speaker has already told, that Rourkela and Durgapur steel plant has come up with another new power plant. That requirement is also to the tune of around 1.7–1.8 million ton per annum. So adding together almost to the tune of around 6 to 7 million ton coal requirement is there to operate NSPCL unit of SAIL. How to cope up? That is a big challenge before us. So possibly we have to think how efficiently we can use this power, or how efficiently we can use our steam for making of power. I am not a power sector person, but normally as per latest technology what we are having at ISP, which is a gas-fired power plant, 4.3 to 4.5 ton of steam is required for production of 1 megawatt of power. But there are many inefficient turbines are there with us, STGs are there. So we need to augment those technologies, and we need to see that with less of steam, how we can generate more of power. This is one challenge before us. Another, whatever steam is left out, whatever energy is left out, can we use that energy into power? Like the technology what we are using today, or some places people are using, like TRTG and BPTG. So that also can be thought of in power sector or not. So that could be another way of thinking where we can use steam in a much efficient fashion than ever before. And more so, now NSPCL has also to venture some of the power generation methodology, which will be a sort of alternate power generation unit. Starting from solar to wind to any power generation for that matter. So that can also be thought of, and it can be introduced in the plant itself or in the vicinity of nearby plant units, so that it can facilitate our requirement in steel plant. One thing is for sure, that we cannot survive without captive power plants set up in our units. So we have to see that this plant remains healthy, and this plant can give sustainable and the requirement of the steel plant. So this is our expectation, and I am standing here because most of the people are from the power sector and most of us are consumer, but I am here as a supplier of say NSPCL. So I am the possibly one odd man out here, but to the extent possible, whatever is required, I am committed to the best of my ability, to the best of ability of CCSO team. We must provide the total requirement of boiler coal to the NSPCL unit. Thank you very much. Have a nice day.
Thank you, sir, for your reassuring words towards fuel security of the NSPCL. Wisdom, value of work, culture to nurture are some of the keys to effective operational strength of any organization. We are indeed blessed by the sterling presence of Sri Subbaraj sir, ED, Alloy Steel Plant. I'll have 20 years for his address. I will request Sri Subbaraj sir to address this gathering.
Good morning. Thank you for inviting me to this conference. Respected delegates from DBC, NIT Durgapur, BPCL, NSPCL, and SAIL. And a warm welcome to all the participants to our Durgapur Steel City on behalf of Durgapur Steel Plant and Alloy Steel Plant. I am heading the Alloy Steel Plant, which is a power intensive unit. We have around 2 electric arc furnaces and ladle furnaces. So the need for reducing our cost basically depends on our reducing cost of power. It constitutes around 20%. And put together with Durgapur Steel Plant, the position of NSPCL is critical to our operations. Some of you may be aware that apart from producing electricity, the steam which is produced at NSPCL also drives our blast furnaces. The turbo blowers provide wind to the blast furnaces. So any disruption in the production of steam will have catastrophic some consequences on the blast furnaces, because they take a lot of time to revive, maybe days together. So apart from reducing the cost, one more factor is reliability of this power plant, both NSPCL and BPCL to sale for any steel industry. So the focus and challenges which are there, like the technology being used, the reliability of the equipment, maintenance of the equipment. input for our power plants, the specific grade of coal at the right price. One more area we looked at is that the mixed gas, off gases from our furnaces and coke ovens which are there, wherever they are in excess, they should be used fully and in our power plants and with the maximum efficiency. So any technological intervention which will bring about improvement in use of these gases and reduce of thermal coal usage in our both our NSPCL, BPCL will be very important to reducing the cost and improve the reliability of the equipment. And others are like skilled manpower and introduction of Industry 4.0 practices, automation, especially in Industry 4.0 automation, this automation in these power plants, maybe which he was telling around some of them maybe 300 megawatt of the plant is quite old. We need to bring about these improvements which can give us the indication of the status of the equipment on a 24 hours, 24/7 basis. So these I think each of these issues we need a special workshop, because today's workshop maybe we may be concentrating only on a small portion of that, because there are other issues, environmental issues are there, then you have finances and other legal issues. All these issues are there that each may require a special workshop. So going forward, everybody, all of you know that thermal power is here to stay. Maybe 50% will be generating from our renewable energy, but thermal power plant which have been installed quite a long time back, they will be there for another maybe 20-30 years. So the need for keeping them up to date and seeing how they can increase the capacity utilization, the load factor in the power plants. So that's very important, especially to SAIL, because SAIL will be expanding, going ahead in ISCO and Durgapur also. So we should also look at the new technology coming in, and especially to talk of this combined cycle power plant, especially at Bhilai. That is also one area we can talk about how we can augment our power plants with the latest technology coming in. So I hope that all these issues, some of these issues maybe, are deliberated during the course of the day today, and we'll have a lively session and points noted down may be taken up for action in the subsequent year. Thank you very much.
Thank you, sir. The institutional ability to perform differently with different setups, with cost optimization and utmost economic prudence decisions are hallmark of leader as what matters most in today's competitive world. The proliferation of twist to excel is witnessed by our beloved Sri Arup Sarkar sir. We are fortunate to have his glaring presence in this assembly. I request Sri Arup Sarkar sir, Member Finance DVC, to address this assembly.
Thank you, Dilip. Dignitaries, most respected dignitaries on dais, off dais, friends, participants, company in the journey. It is really very joyful and proud moment for me for giving me a chance to come today. I was on a tour at the DVC area since first, and incidentally it just matched with the schedule of the ONM conference of NSPCL. Here everything is very own. SAIL, NSPCL, BPSCL, DVC. So we are all part of one family. And in greater sense, all those who are the power professionals of the country, they are the part of the great power parivar of the country. Durgapur is also very own because it is my learning ground for 11 years in NSPCL. The PLF for our ONM people took from 55 to 98.8 in 2008-9. We started the journey in 2003. All because of due to the operational excellence and strive for betterment. If you look at the world scenario, you might have come across the news that Greta Thunberg is back in the protest because of the revival of the collieries, revival of the power plant and the gas power plant. There are power cut in Europe also, street lights are off in some places and the power costs have gone up. But Europe is facing this problem mostly because of the lack of fuel security. because of the Ukraine war. The problem of Europe and India are totally different. The Europe is working on a static load in a fixed load pattern. The consumption is not going up. But here in India, there is already it has been told our ED operation, the growth in last 1 year is phenomenal. The earlier growth happens to be 6%, and last year it is 12%. In some places, like a state like Punjab, the domestic demand has grown up by 25%. Incidentally, last 7-8 years, we have not given attention towards thermal power, expecting that RE power will be sufficient to cater our demand, which were a bit stagnated at 6-7%. So the problem started up when the demands and the peak demand started increasing. It was during COVID something like 156, and last year it was 207 gigawatt, and this year it is expected to 35. This is putting whole operation into challenge. The PLF is going up because the power parivar is facing the challenge. The PLF in the country has gone up. PLF in NTPC has gone up phenomenally during last 2 years, and DVC has also gone up phenomenally. So the question also is regarding costing, whether the power should be at the cheaper rate, even if it is not available. The government has taken a decision, no. You have to produce the power at whatever cost it is. That's why imported coal is allowed, and the landed cost is 18,000 compared to 3,000, 3,500 in Indian coal, with 50%, 1.5 times efficiency in GCV. So these are the challenges we are facing. The more we discuss, the more we learn. It is like sharing the knowledge for our optimization and better excellence. To tell something about the DVC, I want to say one more point. There are power buoyancy in the demand in the country. This is largely because giving the free power also. Not there is huge industrial growth, but the growth is around 6.1 and 6.8. It is expected in 2023 and 24. In this pattern, the power demand should go up by 6%, but because 12% why it is coming? Because of the change in the lifestyle. The India inherently a gross savings nation, it has become a spending nation. Partially because of the inflation, or partially because our intention to buy more and more gadgets, so domestic loads are going up. So there will be buoyancy in the market in next 2, 3, 4 years. What DVC is doing? Just want to share one or two thoughts. Last few years, DVC was producing at 50 to 55% of PLF. But last 3 years, DVC has increased from 62% PLF to 68%, 69% last year. And this year, the current monthly PLF is 85% and expected to reach cumulative of 75% PLF during this year. There is intense pressure of demand from DISCOM. There is no surrendering. We are supplying 8 states, Bangladesh, and also we have a captive load within the valley area of 3,200 megawatt. One point I want to mention, other than one catastrophic rain, in October 2021, we have never ceded any of our consumers in the valley area. So this is the efficiency of the DVC, 99.87% is our system availability. And apart from this, we have 6 plants, 6 thermal plants, out of which 4 are, you will find always appearing in the top power producer list in the country. We have some problems with about the volume in the Chinese unit at Durgapur that is supplied by Shanghai Electrical. We lack knowledge there, but our engineering team headed by Mr. Sanjay Kumar Ghosh, the person on the dais, and he and RTPS team and entire DVC team, we have took up the overhauling of RTPS, and this has given immense result. So by which we are producing 6,000 plus megawatts since last few days on successful. It is a Chinese plant. There is not much support from the China. People could not come here, and the spares etc. are also there. Difficulties, COVID. Still now COVID restrictions are there, but DVC has successfully increased reduce the load up to 6,000 megawatt. In Mejia, the generation is also very good, but there are some reliability issues, it will be taken care of. Why the 6,000 is required, 6,000 plus, we have a 6,400 generation capacity because of the intense demand I have told. DVC is also planning, the government of India has given central power sector 26 gigawatt expansion plan. DVC has got 4 gigawatt. So DVC is planning to have all these things commissioned in 2027 and 28. Regarding this ONM confirmation, so what I want to say, DVC has also succeeded with the accelerated excellence towards ONM because these plans are very stable, and from this type of seminar will earn a lot of knowledge by discussing. DVC will also present a paper in this forum, and I wish all the best for this program. Thank you.
Thank you, sir, for putting the power sector in a short while summarizing the excellence journey of DVC at the same time. Thank you, sir. Ladies and gentlemen, NSPCL avails the pleasure of welcoming our chief guest, Professor Indrajit Basar, Director, NIT Durgapur. We are indebted and beholden for his consent to grace this occasion. We find in him an academician specialized in non-conventional machining, an institutional builder, a Mahamahokadhyay. Sir, I am particularly elated to state that NSPCL has a glorifying past and we endeavor to have a vibrant future in energy sector. We aspire for a learning curve imbued with technical niche to serve our stakeholders, the nation, in a better and hopefully the best way. I take this privilege for inviting you for your address. Person, sir.
Good morning. Good morning, the dignitaries of the dais. Good morning, the organizer. Good morning, the participants of this meet. I feel really proud and privileged to be invited as the chief guest in the meet by NTPC SAIL Power Company Limited for their 8th operation and maintenance meet in Durgapur. I really feel as an incipient person in this galaxy of the people of the power sectors. Now, this NSPCL incepted on 2001 to assure a continuous and quality power supply for 3 steel plants at Durgapur, Bhilai and Rourkela. And with its continuous growth, it is also augmenting its power capacity for the other sectors also. I think they are also supplying power to the grid. Now, the theme of today's meet is the future of thermal power plant. Okay, we have already heard about the competition, rather the ingression of the non-conventional power, renewable power. But truly speaking, the power density required in the steel sector, in that comparison, the non-conventional power is really infinite, and it will take time to come up with to match the demand. So our coal power plant, fossil fuel-based power plant have to stay and have to stay stably. Reliability is one factor. And the next factor, what comes is the optimization. Why optimization? This optimization, truly speaking, is a very dynamic one. Your input variable changes every day. Just the supply of the coal, the quality of the coal, transport cost, its preparation, its chemical characteristics. So optimization is not a one-time affair. It has to be revisited. Everywhere means every location at certain instances of time. Next comes the efficiency. With the increase of efficiency, we are decreasing the entropy, rather also we are decreasing the cost of power generation. So today we are meeting to discuss on all these things. Truly speaking, this operation and maintenance is a very dicey and tricky thing. You will never know what type of problem will come in front of you at any instant. Your intuition, your skill, your knowledge is to counter it. In this forum, in this meet, you have the opportunity to exchange not only the ideas, innovations, but also the experience of this maintenance and the operation. I hope at the end of the meet, you will be really get some new ideas for your location. It may not be new for the other location who is giving you this idea. For your location. And you may be, and you should be able to apply that one to improve the reliability and efficiency of your plant. Thank you very much.
Thank you, sir. We are indeed grateful to you for your address. This we have prepared a compendium of abstracts of the paper submitted in this 8th ONM meet. I will now request chief guest to release the compendium.
ঠিক আছে আমাকে বল আমি করছি তো
morning again. It's customary to have the vote of thanks. So, first of all, I would like to thank our chief guest, Sri Indrajit Vasak sir, to be present here. Then, I would like to thank, I won't take too much of time because we are always late, we are already late, so I will finish it as soon as possible. I thank Arup Sarkar, the member DPC. I thank Subharat sir, UDMI Steel Plant. I thank Anup Kumar sir, EDCCSO. I thank Sanjay Ghosh sir. I thank PK Sarkar sir. And I thank our CEO NSPCL, without whose intervention I think this O&M would not have been possible. I'll fail if I do not extend my grateful thanks to these fellows both from corporate center Delhi, because it's not so easy to arrange such a meet. To continuously be in touch with all the participants, all the fellow institutions, to be continuously in touch and then find out, because we had around 37 papers. Out of the 37, we had to take only 17. So it was also a difficult task. So I thank my colleagues of corporate center. The entire arrangement has been made by NSPCL Durgapur. All those fellows, Costa, Anuja, Dipshika, Parimal Sinha, the entire HR department, those who have made this O&M meet present here and which will continue together, I thank each one from the bottom of my heart. Next, I would like to thank all the BUH who has come all the way from the plants to be here, and the participants of the LSTC. Not but the least, my most and the gracious thank to all the participants outside NSPCL who have agreed to be a participant as well as a member to share their knowledges. Thank you very much, sir. Thank you. Thank you.
Thank you, sir. With this, we come to the closing of this inauguration session. We will break for tea for 15 minutes. Thereafter, we will reassemble in this conference hall for technical sessions. So I request everyone to go for that, sir.
Thank you everyone. Please, by the side, post office. सर, आप पहले बोले आएंगे, आप हमको धोखा दिया, आप हमको धोखा
কমে গেছে ওই ক্যামেরা এই ক্যামেরা চালিয়ে মিলেছে এই ক্যামেরাটা ফরম্যাট করলি না তোরা বলিস না তোদের না এটা খুব বাজে স্বভাব লাগিয়ে দিয়েছি শুরু করে সামনে যাই না তুমি নীলেশ ব্যাটারিটা খুলে চার্জে বসা এই তাহলে এখন অফ করে দিচ্ছি ठीक दोनों ये दोनों বলছি দেখ তো ওই ব্যাটারিটা আসে না ক্যামেরা স্পেস রাখবো তো জুম
आ जाएगा आदमी सब आ जाएगा तुम चालू करो
ये बजे ठीक को ना पूरा
माइक अच्छा
Welcome all once again. This will be first technical session. Total 7 numbers of paper will be presented in this session. First, I will outline the program, tentative program of this session. There will be time allotted for each paper will be of 15 minutes. After 12 minutes, ring will come so as to alert and conclude the presentation within the next 3 minutes. After 15 minutes, final bell will be there. And if I request the participants who wish to ask any questions related to the topic of presentation may note down in the notepad put before them. And later on, I will collect all those questions and will pass on to the session chairman. After the completion of all the papers of particular session, at the end of the session chairman will on their behalf may ask the questions to the paper presenter and will summarize the whole session at the end of the session. This will be the brief outline of the session. So we will first I will introduce the session chairman of the first session, Sri Kaushan Kishore sir, GM and DUH Raurkela will be the session chairman of the first session. Kaushan Kishore sir has vast experience of O&M of power plants. He has served in Raurkela as well as Durgapur in different capacities, and he is very competent technocrat and is very efficient in all the domains of power plant. So we will now start the papers. The first paper, because safety is of utmost concern nowadays, so this is related to safety. The topic of the paper is digitally accelerating health, safety and environment for O&M, safe practices for effective O&M. This paper is from the organization TechnoBuild. The paper will be presented by Sri Anup Ratan Mehti sir. He has vast experience of power sector. He is currently serving as Director Project Execution O&M. He has 40 plus years of experience in project execution, O&M of large power plants. He is ex-NTPC CGM Digital Initiative and served as head of plant for number of NTPC power projects. He will be assisted by Sri Priyanshu Upadhyay sir. He is Associate Manager Productivity Engineering and has 11 plus years of experience in executing projects for heavy industries. So I request Sri Mehti sir and Upadhyay sir to present their paper.
Thank you very much. Respected dignitaries,
There's so many advanced technologies are available, we have to take care of that. Real-time leading indicators, notifications, AIML and GIS infusion, predictive analytics, GIS access to information, lower costs and resources, voice to text, things are to be taken care of. Earlier, we have seen that DuPont says for any safety, you have to take a natural initiative, supervision. We have seen individual efforts. We understood that team efforts are also required, but that will take you from -1 to 0. To go beyond that, beyond 0, you have to take care of these things. That is ISO 45000, proactive management, action and assessment, collaborative compliance, effective engagement. Now, effective engagement of the middle management, top management, all the workers, all the executives. It has to be done by all of them. They have to understand their roles and nobody should escape their roles. That is how we can go towards +1 approach. These are just some rules to bring to your notice, to make you confident that for India government, there are so many rules which is definitely there and with which you can definitely implement, you can definitely get the help from rules and regulations to implement your safety. However, we have to take care that we have to include mental and social well-being of worker of each level of hierarchy. Leadership and worker participation model to ensure zero harm, that is the key to success. Now, may I request Mr. Upadhyay to go ahead with the presentation?
Thank you, Matthew sir, and good morning, everyone. So, this is a digital platform, a unified platform where we can collaborate, we can have the automation workflows, have precise work control, manage safety better, get real-time visibility, and it is simple, fast, and flexible. So, major pillars for PACE HSE or to maintain the safety in an organization is 4. The proactive management, the assessment, which are like job hazard assessments, the field assessments, the compliance, the audit checklist that is going to happen, and the engagement from top floor to shop floor. So what we have done, we have bring the digital block of digital containers which take care of each and every aspect. Whether it is HSE management, which is like containing all the policies, safety policies, assessments, compliance, and all the incident or near miss reported, the observations, the motivation, how we can motivate our team members, and then there is a control tower and safety product manager who manage and control all the safety parameters for a project or a plant. So we are like fully complied with the ISO 45001, and if you use such a system or digital tool or platform which can enable you to fulfill all the ISO 45001, it will help the organization to build better. So there is a great shift towards through PACE HSE. So we are here not to manage the hazards, we are here to eliminate the hazards. We need a digital unified platform where every team, every members can collaborate. The transition from normal way to digital way should be seamless. It should not be a painful transmission. We should always protect our people property and process. And the last is the leadership driven, where there is a strong framework and a proven method to manage the safety.
बहु देख क्या हुआ किस कहाँ कमा रहे हो इसमें? इधर नहीं आएगा इसको बुलाओ जितना लोड वो ले पा रहा है उससे ज्यादा लोड गरम हाँ इधर सामने लेके आ जाओ, उनको दिखाई नहीं देगा ना, वही परेशान, उनको नीचे करना पड़ेगा। তোমাদের এত পরেশানি কেন? হ্যাঁ, এত পরেশানি কেন? নাহলে দেখো একটা প্রজেক্টর থাকলে প্রজেক্টর লাগিয়ে দিয়ে দাও, ওকে চালাবে, নতুন করে হবে না, এত লোড দিচ্ছে না।
हाँ सर
এখানে লাগিয়ে দাও, বাস তারপরে এখানে একটা যে কোনো একটা এখানে নিয়ে চলে আসবে।
सुना 42 तो कॉल पर एसी का टेम्परेचर होएगा।
डायरेक्ट कर दे तो आधे घंटे
ठीक सर।
আচ্ছা আচ্ছা ওটা আনতেও তো সময় লাগবে, ওটাকে টেনে আনতে সময় লাগবে, কেবল আসবে না, কেবলগুলোকে আবার টানতে হবে না। আনছে আনছে
DPN को ऑफ कर,
ना ना
ऑफ करके रख,
उधर ही खड़ा रहना।
তোমরা একজন এখান থেকে যাবে না, ঠিক আছে? एक आदमी कहाँ गया आपका? तो एक आदमी को बोलो, एक आदमी यहाँ रहे। मैं आता हूँ। यहाँ रहो। ठीक नहीं है आप। डीसी बंद है। केबल हाई वोल्टेज वाला। भाई कपंदा कपंदा भाई सामने असुविधा नहीं साउंड ऑन होगे लाइट बंद होगे
वो कंसल्टेंट है वो ये है काम आपसे कराएगा वो आपकी की बात वो करेगा क्योंकि वो कंसल्टेंट है तो आप उसको सुनोगे ऑर्गेनाइज। हाँ ये भी बहुत बड़ा काम मैंने 90% है कि अच्छा एक अम्ब्रेला है
प्रोजेक्टर लेके आओ, प्रोजेक्टर रखो, प्रोजेक्टर रखो और ये
जा रहा है
हाँ प्रोजेक्टर स्क्रीन तो
कॉन्ट्रैक्ट को भी कनेक्टेड करना है जो कि पहले डिपार्टमेंट को करते थे अब उसको भी उसी अम्ब्रेला में ला के सजा के हम बोले कर लेना ठीक है। एक बार बोलता है कि मेरा कोर बिजनेस है, दूसरी बार बोलता है कि बड़ा प्रोडक्ट में कोर बिजनेस है, लेकिन दोनों अपनी प्लानिंग कर करनी है वो किसी को करना दो सब कुछ जाके आगे बढ़ गया पैसे लिखना तो कैसे लगा अभियान में डालोगे तो 6 करोड़ पानी में डालोगे तो थोड़ा ज़्यादा पड़ेगा बट पानी तो बेनिफिट होगा लैंड का रहती लैंड
प्रोजेक्टर का पीछे करो तो और पीछे
अगर कर ले हम खेल तुम क्या कर लिए हाँ क्या कर कुछ भी नहीं कर पड़ा अभी फिर ये वही हुआ था फिर कहानी अभी यही कर मैडम को एमजी अपने दो महीने बाद हरिद्वार जाके जयराम ओम नमः नमः शिवाय का रिटायरमेंट होने के बाद हरिद्वार में तो जाओगे ओम नमः शिवाय सर रिटायरमेंट के डायरेक्ट भी पूछता मैं पूछता ओम नमः शिवाय का बोलो अल्टीमेटली बोलना है आपको। अब जितना भी तेज कर रहा है कुछ भी बोल लो मैं नास्तिक हूँ फलाना दिखाना चला जाके बुढ़ापे में ओम नमः शिवाय बोलेगा कि नहीं बोलेगा? बोलेगा। आप बुढ़ापा के आप जब प्रॉब्लम में फंसता तो बोलते हो? हाँ बोलते हो ना। तो मैं ले आया तो थोड़ा सीधा कर दिया करेगा। बोलते न हो टेक्नोलॉजी नहीं हमको मालूम है मीडिया वर्क ऑफिस में वही वाला वीडियो और लगाने के महीना मेरे को ऐसा पढ़ाया वो कंपनी पूरा उसने मेरे को टूटा नहीं लिटरली माँ बहन करके बोला सोना जब तक 2 महीना कंटिन्यू में चालू करके नहीं सर शाम को करना मैं उसका चालू दिन में सुबह चालू करूँगा तो 72 घंटा कंटिन्यूस करना मेरा ये यहाँ कोई प्रोग्राम होता है तो मेरे को उस हिसाब से सोचना है ना। मैं बोला एक बार चालू होगा तो 72 घंटे के पहले बंद नहीं करना फिर मेरे को करके दिखा हाँ तो कहीं नहीं था 10 घंटे में खुश 12 घंटे में खुश मैंने कुछ मालूम या तू कान पकड़ के बोला 16 लाख रुपये तेरा मुँह देख के मैंने मैं ऑलरेडी लिख दिया हाँ ये कंटिन्यूसली 72 आवर चल रहा है विदाउट कॉपी करके प्रूव करके किया उसके बाद मैंने जाके और कर दिया सर माइक परमिशन नहीं तो वो चिंता मत करो मेरा वो कॉपी तो चलवा के बैठा दिया और मेरा भी एक आदमी को मेरी फोन बोला तू भी इसको करता है तब तो काम होगा लेकिन जो चीज़ सोनी देगा वो सभी 300 रुपये वो 100 में दूंगा हमारे यहाँ बहुत ऐसा मशहूर है सस्ता तुरंत ले लो सस्ता है तो अरे सस्ता है कि रिलायबिलिटी भी देखना क्या करता है चाइनीज आइटम सोर्सिंग करते हैं उसको सस्ता बना देते हैं बट रिलायबिलिटी में क्वेश्चन मार्क हाँ सोनी का वीडियो हुआ जो चीज़ में 100 में चले जाएगा 48 लाख का था मालूम नहीं और वो 16.5 लाख में दे दिया हमारा नहीं किसी के लिए सर रिलायबिलिटी को देखना बोर्ड वोर्ड चेंज किया होगा पावर बोर्ड चेंज किया हेलो थोड़ा ब्राइटनेस कम रखो ब्राइटनेस कम हाँ
लाइट जलाने चला जाएगा लाइट ऑन करो
ब्राइटनेस कम करने का ऑटोमेटिकली पावर रिक्वायरमेंट कम
Start. Okay, let's start. I hope I'm audible. Okay. So we were talking about shift through a digital platform. So we are here to eliminate the hazard, not manage the hazards. We are here to protect our people, property, and processes. So through a unified digital platform, we can bring and collaborate team from shop floor to top floor, from top management to workers, on a single platform. And leadership driven, where a desire from leaders to bring a strong proven work frame for safety is also required. So let's get by a new age technologies such as IoTs, the real-time geoinformations from drone and from RFIDs. So we collect all this information from all these technologies in a digital block, and from there we do the data visualization, we do the predictive analysis, and then a rapid response will come. So this will enhance the decision making in the real time for the management. So from real-time GIS, what we'll get on a geoplot plan, you will get in which area what permits are active, what assessment has been done, which area is on high risk or low risk. So if there is any high risk activities going on, there will be a red bubble coming up on the GIS map, and you can easily track and mitigate all the high risk activities or unsafe activities going on in that area. We can utilize the computer vision for safety, where the machine will evaluate right kind of PPEs are being taken care of, not whether the person is working in which area in confined space and is using all the proper PPEs or not. So let the machine do that work, and we'll get the real-time alerts and update, and we can monitor that in easy way. So we can implement IoTs on three types of things. First is on people. People, we can track the location, whether he is working in confined space or is doing the job underwater, and we can monitor its all body fundamentals. The second thing, we can utilize IoT on assets. Our assets are also very valuable, so we need to check whether all our assets have been preserved properly, at what location they are. Few assets can be mobilized from one plant to another plant, so we can track those assets. Third is the equipments or the machine or vehicles. So real time, whether our heavy vehicles are like moving motorable or non-motorable road. If they are moving in non-motorable roads, we can track those things. Now we are getting all the information from IoTs, from other new age technologies, from mobile apps and other things. We collect all this data, and the machine will learn and process and give the intelligence, where we can do predictive analysis. So how this predictive analysis will help us? So it gives a heat map that in this particular area there is a high risk activity going on. So if you see the dark red box is the high risk area where high risk activity is going on, and which are the fundamental things which are increasing the risk of that particular area. So if you know that this area is on where high risk activity is going on, we can immediately check all the safety assessment or safety parameters which is being taken care of. So if we have a digital control tower which can give us a 360-degree view, what is happening at which place, who is working on which area, what are the safety parameters is being taken care of, all those things if we get on real time in a single page or a single window, it will be very helpful to manage the safety aspects on the project or the plant. So we can have leading indicators, all the observations, assessments, lagging indicators, all the near miss and all, and prevention through prediction. So if we have a better prediction, we can prevent it before happening of any incident or near miss. So this was a study where we found that an observation like unsafe act or unsafe condition or any near miss which is being reported, it takes a lot of time to reach to the decision maker, and till the decision is finalized, the lagging becomes the leading, because till now a near miss would have happened or an incident would have happened. So if we get this leading information real time to the decision maker, that will save us from any near miss or any unsafe act or activity being happened. So one of the case study that we have done in a multi-billion oil and gas project, where workers were using handwritten forms. So we transformed this handwritten form through NLP technologies into digital input. So from digital input, we read, analyze, and give the analysis, which give us like this of report, which is like which activities are high risk, so we can easily work on those high risk activities. Again, an app is a very useful tool where you can connect to the workers directly to the digital platform. It will be helpful to get all the observation. One eye for every eye becomes multiple eyes. So that's why iPace is been introduced. So if we are going for +1 HSE methodology, we'll also mitigate the behaviors, the unaccepted behaviors that happens in the project or plant, whether it's attitude towards safety or blindly working on any unsafe conditions and others aspect. So what HSE Plus give us as a benefit is giving a global standardization and better engagement and geoinformatics, better visibilities, automatic identification of culture and process, reduce the cost and risk. In the recent deployment on one of the NTPC's Singrauli project, we have seen a lot of contribution from the people, where we have seen a cultural shift for obtaining and using a better safety culture. So around 400 user has been on using digital platform to bring the safety culture. So we have both the pillars, knowledge and skill, but there is a leadership bridge which support. So there is a desire required from leadership, a desire to bring all the workers, all the people safely home. And coming to this conference, I have seen there is a great leadership desire among the NSPCL team, and we are happy to present this HSE approach towards safety culture. Thank you, everyone.
Thank you, sir. We are sorry that is due to some technical glitch the program was interrupted. Now I will call Shri Ritesh Agrawal from NTPC. He is DGM Senpeep and he has done his MTech in Industrial Tribology from IIT Delhi. He is certified energy auditor. He will present his paper on the topic Enhancing Vindhyachal Stage 4 Common Cooling Tower Performance, a Journey Towards Excellence. Shri Agrawal.
A very warm good afternoon to all of you, sir. Now I will be presenting the Stage 4 Vindhyachal Common Cooling Tower Performance Journey. And now coming first to the introduction, then the cooling tower components, then the assessment of the performance improvement opportunities, and the action plan and challenges. Now first, what is a cooling tower? As we all know, cooling tower is basically a heat rejection device, and it rejects the waste heat to the atmosphere through the cooling of a water stream to lower its temperature. It is basically based on the evaporation principle, and latent heat during this evaporation process ultimately causes the cooling. Why is cooling tower so important for the power plant? First, it improves the condenser vacuum, it directly influences the heat rate, it promotes efficient water usage, prevents environment damage, and has a huge impact on the financial savings. Now, superior CT performance leads to lower CW inlet temperature, and which ultimately leads to a better condenser vacuum and a lower heat rate. So with the reduced coal firing, we are able to produce the same megawatt. And even 1 degree reduction in the CW inlet temperature leads to improvement of vacuum by around 4 mm mercury. And it's in heat rate terms, it is around 4.3 kilocalories per kilowatt hour. And financial implication is huge, around 37,000 rupees per day, if we take the example of a peat-head power station like Vindhyachal. So this much improvement by single degree reduction in the CW inlet temperature. Now just briefly I would like to introduce the cooling tower components. Now these are the major components. As you can see, there is a fan, then the drift eliminators at the top, then there are the nozzles for distribution of the water, breaking them into droplets, then the fill medium is there. So these are the basic design. Now these are the details. Louvers are there for guiding the air which is incoming the cooling tower fans, and also for reducing the water splashing. And different types of fill media are used, like V-bar, polypropylene grid, or PVC based films. Different types of fill media are there. Now if we take the study at Vindhyachal, in stage 5 different types of cooling towers are there at Vindhyachal. Some are fill type, like the stage 2 and 3. These are film fill type cooling towers. And if we take the example of stage 1 and 5, they are inverted V-bar cooling towers. And stage 4 NBCC make is counterflow cooling tower with rectangular splash bar type fills. So this is basically 50 by 50 mesh of PVC film is there. So it's a museum of power plant, we can say. All types of cooling towers are there. Total 19 cooling towers are there at Vindhyachal. Now the performance improvement opportunities. We have selected stage 4 cooling towers at Vindhyachal because they were suffering from a PG test shortfall of 4.9 degree since inception. So there was a huge gap for improvement. Now we have used the DMAC methodology, define, measure, analyze, improve and control. This methodology we have used for the improvement. We have identified the various issues which our common cooling tower was facing there. Then in the measure phase, we have measured the temperature shortfall. How much exactly is the temperature shortfall? Cell-wise air and water flow. This is the heartbeat of cooling tower. Cell-wise water flow and air flow, also known as the liquid to the gas ratio. It directly influences its performance. Then we have tried to analyze what are the root causes of various issues using fishbone analysis, which is a well-known technique. Then we have visited our counterparts like the Sasan Reliance Power Plant, how they are doing and how their cooling towers are performing better. And we also visited Ramagundam Power Plant and studied their best practices. Then in the improve phase, we did various small improvements. We were based on the Kaizen principle, like what all we can do with the available resources in-house, what we can do. Like we went for the reorientation of the drift eliminators, V-bar insertion, water balancing in all the cells, then the fan blade angle adjustment. There was some hot water pipes which were extruding in the hot water channel, and they were disturbing the uniform laminar flow of water. So we caused the trimming of those pipes so that the water flow in the hot water channels became more uniform and laminar flow was there. So this we did. So these major case studies I will be discussing in some more details. And then in the next phase, last phase control, we continuously monitor the high level of performance by better monitoring and improved practices. And we are going for online CT performance monitoring. Now this is just the fishbone diagram. What are the common regions of poor performance of CT? Maybe from the airflow side, if airflow is less, it may be due to higher fine tip clearance. Maybe there may be physical hindrance, algae on the fan blades, and so on. There may be numerous reasons. And if we go for the water distribution in the cells, it may be due to the choking of the nozzles due to mud or algae, or due to the fallen or broken nozzles, or the distribution pipes on which the nozzles are installed. Those distribution pipes may be having some leakages, or improper nozzle clamping, poor water quality from the chemistry side. It can cause the choking of the nozzles due to deposition of silica, chloride, silicates and all, or rainwater ingress in the open air channel. And one more important thing is balancing of all the cooling towers. Like if it is having 18 cells, the water flow and air flow, it should be balanced in the cooling tower. If somebody is more loaded, then that particular cell performance will deteriorate. So improper flow through the risers, this we also checked. And sometimes what happens is that when we give the permit during our operation, then what happens is we stop the fan, but the riser valve is kept open. So hot water from that particular cell is directly falling into the basin, cold basin. And the fan is not running. So it is not causing any cooling, only it is loading the cooling tower. And sometimes we find that 1 degree temperature increase is there by only one cell if we fail to close the riser valve. Just so it is a very easy operation method by closing the riser valve of that cell which is under permit. It has to be ensured. Now these are the challenges in front of Vindhyachal. It was geographically spread over a very vast area. The 19 towers were. It was closed. There was a close vicinity to ash silo. Coal mines were closed, so there was huge dust load is there. Ash loading is there. Vegetation growth, too much vegetation growth is there. Then under design of stage 4 cooling tower, there was a shortfall of 4.9 degrees since PG test. Now coming to the assessment of the cooling tower performance, these are the major parameters: WBT, DBT, dry bulb temperature, then the cold water and hot water temperature, exhaust air temperature, fan current and power, and finally the water and air flow rate. Measurement of these things we have carried out, and based on these we carried out the calculations for the critical factors like range, approach, effectiveness, L by G ratio, liquid is to gas ratio, and finally capability and temperature shortfall. This capability is the most accurate parameter to judge the performance of the cooling tower. It applies the correction for water flow, wet bulb temperature, range and fan power. All corrections are applied and it gives the most accurate result that where the shortfall is there. Now these were the initiatives which we took at Vindhyachal. Out of the 10 initiatives, we have selected few major. We replaced the old nozzle with wide spray angle nozzles. Initially there were blind areas. There were areas in between the nozzles, there were areas which were not getting wetted. There were dry areas, so it was not contributing to any cooling action. Those particular portion of the field was dry. So we replaced the old nozzle with wide spray angle nozzle, detail is there. Then the trimming of extruded hot water distribution pipes. First the water rises through the riser pipe, then in the channel there is a hot water distribution pipe. If those hot water distribution pipes are extruded, it is disturbing the flow. Details will be there. Then reorientation of the drift eliminators, water balancing, installation of mechanical stoppers, placement of V-bars, removal of unwanted material and sheds near the common cooling tower. We have covered our entire open air channel up to the condenser with nets, because what happens is vegetation and it grows very near the forebay, and that vegetation when it gets dry in the summer it falls in the channel itself, CW forebay channel, open air channel, and these go and get trapped in the nozzles. And then the double trash screen installation at cold basin outlet. And sometimes we find there were gaps in the maintenance door. Cooling tower cells for the maintenance door is there, through which we go and maintain the fan, but sometimes there is not a perfect sealing or there is some gaps, so at that time problem is there. So now coming to the details of these 5 case studies which we have selected. This is the airflow measurement. This we did in-house as per the CTI approved procedure. At four angles, like there is a circle of the top of cooling tower. At 40 points we have measured the actual airflow with the help of the anemometer, and we have determined the average velocity of the air. In this rod we tied the anemometer and we moved at 4 particular locations, 4 radius, and each location 10 points were taken. So total 40 readings, and we calculated the average of that reading multiplied by the cross-sectional area. So we get the volumetric flow rate, and then we also measured the wet bulb temperature, humidity, and found out the density. So mass flow rate also we calculated. So by this method, for each and every cell, 18 cells were there, it is a tedious job, it takes around 1 to 2 hours for single cell. And then like this, we plotted a graph of the design airflow was 402. So around 5% margin we took. Those cells which were below 380 kilogram per second, we selected those cells for blade angle adjustment, because sometimes due to the over-aging or due to prolonged use, even due to weather changes, like summer's density is different, winter density is different, so the airflow handled by the particular fan of the cooling tower, it changes, maybe due to deposition of algae or some dust material on the blade. So these cells we selected and went for the blade angle adjustment. So this is our journey. For cell A2, we took 2 steps, 12 degree to 14 degree, then 17 degree. And we increased the airflow by 17%. And simultaneously power also increased. And when our confidence increased, we directly for cell A1, we caused a 5 degree jump in the blade angle, 12 to 17 degree, and we were able to achieve around 9% airflow increase. So like this, the blade optimization journey, it's a continuous journey. And we try to achieve the maximum airflow, but within the power consumption of the fan motor, 55 kilowatt, we have to keep that range in mind. And we can see that 11A1 and 11A2, these 2 cells, you can see they have moved up towards the ladder gradually as we adjusted the blade angle. So this is the first case study. Then the modified nozzles we installed, and as discussed, it increased the contact time and wetted fill area. Earlier there were blind areas which were consequently wetted, and this wide spread with these new nozzles, it causes better cooling, and it resulted in smaller droplet size. Finer droplets is the key to better cooling tower performance. जितना fine drop बनेगा उतना अच्छा cooling tower हमारा cooling करेगा. So, and overlapping of water spread. So this is the modified nozzle. We can see that this second nozzle, larger one with spikes and all, it gives a better spread area of the water droplets. So this entire modification was done in house, and original nozzle was not giving that much. With a video it will become more clear. So this is initially these types of gaps were there between the nozzles. So finally a good overlap was achieved and dry areas was minimized. So this video will make it more clear. So this is the modified nozzle, and we can compare the flow with that side. It is a smaller spread and it is a much wider spread over the fills. So it gives a better cooling effect. Now the third case study was installation of mechanical stoppers. What we were observing was that during giving preventive maintenance, the operator, then the flow was getting disturbed. Means in some cell it was more, then it was less. So what we did, we measured all cells flow with ultrasonic flow meter, and accordingly we adjusted the riser valves. And mechanical nut bolt type stopper was installed so that the flow should not be changed. Flow should remain uniform during giving preventive maintenance and isolating the cells. It will become clear with a figure, and it will give guidance to the local area operator during isolation and normalization, so that water loading is uniform in all the cells. Earlier this was the situation, like around 2000 ton per hour was the water flow in each cell, and we have taken a margin of plus minus 10%. So these 3 cells were on the lower side and 2 cells at that extreme was on the upper side. So we went for an adjustment so that the limit should be within 10%. Perfect matching may not be possible, but within 10% should be the water balancing in all the cooling tower cells. Then the performance will be better. So we went for the stopper adjustment. Through this diagram we can see this mechanical stopper was installed, and during the isolation and normalization the flow was not getting disturbed. This is the ultrasonic flow meter through which we carried out the flow measurement in all the cells. Now the one more case study was reorientation of the drift eliminators. Drift eliminators are basically to reduce the water droplets lost from the cooling tower, but sometimes what happens is they also create a resistance to the air path. And we studied the orientation of all the 19 cooling towers at Vindhyachal. We tried to copy the stage 5 drift eliminator orientation. It was the best performing, so we tried to copy their orientation, and because the air handled by that individual fan was striking the partition wall, which was resulting in higher resistance. So we did a reorientation based on our stage 5 model, and this is the diagram. Like this we changed the orientation, and we again did this study of airflow measurement with the CTI approved procedure. At the 40 points we measured with the anemometer, and we found that the airflow rate has improved around 16%. Next was this extruding hot water distribution pipes. These pipes were extruding in the hot water channel. The water was through the riser pipes, water enter in this channel, and then through this distribution pipe it gets distributed in the nozzles. So this was disturbing the uniform laminar flow. So chopping was carried out, and the entire channel then the flow was more laminar. And then there were some temporary sheds that were blocking the airflow. They were removed. And further, we tried to introduce V-bars. We were having in-house in Vindhyachal. So we put on the fills, and this was used for better splashing and smaller droplet size. Like this, we can see the V-bars. They were introduced for smaller droplet size. In-house modification. Then there were trash screen was installed like this at cold basin outlet to stop the foreign material. Now finally the financial gains, it reduced the temperature shortfall from 4.9 to 3.3 degree, and heat rate improved by around 6.9 kilocalorie, around 59,000 per day, and annual it is around a 2 crore saving annually it is leading to. Now the future action plan. This optimization of blade angle is a continuous journey, and we are planning to sludge pump discharge to be installed in all cities and connect with the slurry pit. Then we will try to install energy efficient fan for more margin for blade angle increase, and online capability monitoring through online sensors. This we are working on at Vindhyachal. Now the conclusion, it's a very vital component, cooling tower, and sometimes it is neglected also. And it has a huge impact on its plant performance, heat rate, and coal consumption. So it needs constant monitoring. Thank you, sir. Thank you. Thank you, sir.
Thank you, sir, for such a nice presentation. I once again repeat that any question related to the presentations may be noted down in the notepad before the participants and may be handed over to Shri Faiz Ahmad. The third presentation of this session is from Jindal Power. The topic is optimization of oil consumption and cycle time in unit startup by adopting best operational practices. This presentation will be delivered by Shri Amit Kumar Pandey, who is DGM Operation and backed by experience of more than 16 years of Jindal Power Limited, Raigad, 2x250 and 4x600 megawatt. He will be supported by Shri Ravi Satyapal and Shri Sandeep Patel, who are managers at Raigad thermal plant. So I now invite Shri Pandey and his team.
Okay, thank you, Dilip. First of all, I will have thank you notes for the NSPCL to give us the opportunity to present our sort of the effort what we have put it to in the form of best practices, and I welcome all dignitary and a warm good afternoon to all of you. What we have did, being a power plant operation engineer, just put our effort how to minimize the specific fuel that is used, oil. We also call it as a secondary fuel because primary is the coal. So let me first tell me about our company that is called Jindal Power Limited. Basically, we are actually 4,300 megawatt installed capacity. In that 4 into 250 megawatt and 4 into 600 megawatt, it is located at Tamnar itself. All 8 units are of BHL make boilers, and the reason behind the concept why actually we have did this is the number of startups as you well know about the power sector, the flexibility, and for us like IPP having the capacity of this hue of 3400, and that in that we are only having the 25% of quantum as a PPA of LTA. Apart from that, we don't have the long-term PPA. So very difficult to run this extent of quantum unit to a longer extent. So this forces us to think about how we are going to mitigate this consumption of secondary fuel, because the number of startups are more. Even in the year it was ranges from 28 to 34, and if we come to the monthly 5 to 10 startup, you can say. So this forces us to think on the point of this consumption. So I'm having with my team Mr. Sandeep Patel and Ravi Satpal. Mr. Sandeep is having the experience of 4 into 50 megawatt. He is operation engineer, having 11 years of experience in this field. And Mr. Ravi Satpal is having the shift in charge of 4 into 600 megawatt. He is having 15 years of experience in this. So I will invite Sandeep to please carry on.
Thank you, Amit sir. Now, as we know, energy is a driver of economy, and the per capita consumption is indicator of it. The changing portfolio of the energy basket, that is from fossil fuels to renewable energy, has forced us to think about the options regarding fuel consumption, specific power consumption, and many more. So in this presentation, we have taken the topic of fuel consumption. How can we prove this key? We are doing the number of startups in a more conditions rather than normal. As the data suggests, in November 21, the total power installation capacity of India was 392 gigawatts, out of which 54% share is of thermal power plants, and near about 23% is of RES, which by the spending year, in October 22, the ratio has been changed to 50% share of coal energy or thermal power plant, and almost 4% rise in RE sources. So this is a clear indication that we have to look for other options, because the units are not running in the base load. And because units are not running in base load and there is a concern of flexibilization, the number of outages or restarts of the units has been depicted in the graph from financial year 2016. As you can see, the number of startups and outages are much higher for 400, 250 and 600. Now, as I say, the areas which we are focusing on for better operation practices are specific oil consumption reduction, modified practices, third one auxiliary power consumption, unit flexible operation, and the challenges we face due to these things. Now the practices we have taken into account for reducing specific oil consumptions are deaerator pegging, which is already a provision but was not in effective use before, but were taken in the account. Pegging with PRDS has definitely helped in raising the temperature of the feed water by 100 degrees Celsius. And how? By cyclic operation, filling and draining of water to the boilers. Second, CBD-EBD optimization by effectively modulating oil pressure during phase changes, that is phase transition, to control the drum water swelling, which is virtual. Third, convective heat transfer. We have taken a giant leap by this step by introducing coal feeders immediately after bypass charging to envisage the convective heat transfer method. And with this method has come some challenges. And challenges are the rise in furnace temperature abruptly. So how can we control? We have controlled it by strategic operation of higher elevation oil guns. Next, boiler heat value optimization. Boiler heat value optimization is also a modified form due to introduction of pulverizers. Pulverizers introductions has actually raised the furnace temperature by some uncontrolled extent. And at times we feel by just looking the furnace pressure modulations that the fuel is not burning in a right manner. So we have changed it again. We have taken it to the APH outlet temperature as 170 degrees Celsius and mill outlet temperature for cutting the feeder as 80 degrees Celsius. Boiler hot water flushing at low pressures has definitely helped us to control the CBD by much extension, because when we heat up the boiler, during light hours, when we heat up the boiler, CBD actually deteriorates or degrades the heat energy. So we are controlling this from hot water flushing. And for 600 megawatts, we have effectively used the SCAF, which is already there, and APRDS charging through station header for vacuum pulling, which is a parallel operation. By CA source, we have taken this graph that what is the recommended specific fuel consumption per startup. For low megawatt units like 200, 210 and 250, hot, warm and cold are described as 20 KL, 30 KL and 50 KL. For 500 and 660 megawatts, a higher consumption is there. What we got at 250 megawatt is oil consumption per cold startup. It is clearly seen as that in 2016 and 17 for cold startups 55 KL consumption was there, and by the end of 2022 we have taken it down to 32 KL, which is a significant reduction. Now it has been done. As we say, any optimization is not a one-time process. It has to be revisited every now and then. So how we have taken this? We have taken this in this manner that in financial year 2017 and 18, we have introduced coal feeder. What we saw is the specific fuel consumption has been reduced to 46 KL from 55 KL. In 18-19, CBD, EBD has contributed, and the auxiliary fuel consumption has been reduced to 38 KL from 46 KL. Then we have taken the effective use of deaerator packing and water flushing, and further it has been reduced to 33 KL or 32 KL. And by 22-23 we are again seeking some strategies to further reduce to our benchmarking oil consumption, that is 28 KL, to make it as average oil consumption. As BHEL operating curve suggests that from boiler light up to synchronization has to be 4 hours and 20 minutes time. And we managed to put it down from 6 hours 30 minutes to record 5 hours and 30 minutes. And by reducing this time, oil consumption has to be reduced. These are some milestone data that for hot startup, a cold startup, we have managed to reach total oil consumption up to 28 KL. But this is a minimum, not average. Averaging, in average we are at 32 KLs, but out of our best is 28 KL till now. For warm startup, and that is also warm startup is a temperature dependent. It is a shaft temperature dependent entity. So it may vary from 18 KL, 14 KL to 18 KL to 22, but average is 22 if our shaft temperature is around 200 degrees Celsius. For hot startup, we managed to reduce the oil consumption to 5.9 KL, and that is a record for us. Best achieved oil consumption data for 4 into 250 megawatt year on year. On year to 16-17, our best was 52 KL for cold startup, for warm 36, and for hot was 18. That was reduced to 28, 22, and 6 KL till 2023-22 year. And what approaches? What I'm saying is been summarized in this sheet. Approaches for SFC reduction. How we have done? By reducing startup time and by improving the operational strategies. By reducing startup time, we got admission. How we have done? By admitting the pre-warmed hot water to the boiler by charging pegging steam to deaerator. And secondly, maintaining the reheater and superheater temperature to facilitate and withdraw the oil guns from service as soon as possible. Secondly, improvement in operational practices. How we have done? By minimizing the steam losses from drain during startup, minimizing the heat losses due to CBD blowdown by allowing hot blowdown at low pressures, introducing pulverization in the firing system, pre-trial of drives for ensuring their reliability and breakdown, strategic planning and proper coordinating with the departments by maintaining sheets for mock light up and strategical timings, optimizing the oil pressure, increasing in reliability of oil guns to reduce the wastage of oil due to failed firing attempts, control of firing system to match the turbine criteria so as to reduce the startup time as soon as possible. Now may I invite Mr. Ravi Satyapal to carry on for 4 into 600 megawatt data. Ravi sir.
Thank you, Sandeep. I am fortunate enough to be here to present the data of oil consumption reduction and what practices we have adopted to such a great platform. Actually, we have done no magic. All the things were present, but it was just the matter of taking the things into the practices. It is just based on the concept of Kaizen. All the things were present, but they were not in the manner of standardization. You can see 600 megawatt has adopted the same practices as the 250. So I will not repeat those, but I will go through the journey how we have came to this. 2016-17 we were at the 90 KL for the cold startups, and in the year 2021-22 we came to the average oil consumption of 60 KL. We have reached to the minimum 56 KL now also. We have commissioned our first unit in year 2014. At that time we were at the 90 KL. We just introduced the same practices and it is being standardized and communicated and implemented to everyone. Because अगर हम चीज़ें कर तो दे रहे हैं, बट अगर सभी लोग उसको स्टैंडर्ड वे में नहीं अपना रहे हैं तो deviations होंगे. तो we have reduced the deviation and achieved this data. Introduction of coal feeder reduced our oil consumption from 90 KL to 82 KL. Introduction of optimization of CBD and EBD. Our oil consumption came to the 74 KL in year 2020. And after that, we have introduced deaerator pegging. Deaerator pegging brought down our oil consumption to 74 kl to 67 kl. With the further improvement, we came to 55 kl to 60 kl by optimization of blowdown. Also, introduction of hot water flushing helped us a lot. This is the standard data given by the OEM, but this is the 2 hour 50 minute light up to synchronization time, but till now we have achieved 4 hour 30 minutes minimum from light up to synchronization, and we have removed oil guns in 1 hour 30 minutes after the synchronization. We have introduced small nozzle for the oil consumption reduction. Earlier we were using per oil gun designed with 2.5 kl, but now we are using 1.5 kl per gun after the stabilization of firing. Also, we have done one improvement, that minimum coal feeder feed rate, that was 20 tons for the 600 megawatt and 12 tons for the 250 megawatt. At the time of startup, to ensure the proper firing of the fuel, especially coal, we have reduced 250 megawatt minimum coal feed rate to 8 tons and 600 megawatt to 12 tons. Even after that, we are monitoring the furnace conditions, and based on that we are using puffing method, starting and stopping the feeders as per the condition of the furnace. This is the data. Now we are at the 55 kl and the startup time is 5 hours 30 minutes. We have reduced it to 5 hours. And this is the warm startup. We came to the minimum 45 kl, and in the hot startup we achieved 10 kl. And time is 1 hour 20 minutes for the hot startup, and for the warm startup it is 4 hours 40 minutes. This is the graphical view. I already explained these things. You can have a view of this. This is the practices we adopted, already explained by Sandeep. We also improved upon the auxiliary power consumption in the startup. For that, we are using turbine driven BFP in place of MD BFP at the time of startup. Even second draft stream is being taken after 200 megawatt, and vacuum pulling, which we were doing earlier at the time of startup, now we are doing after the firing establishes and we are going to open the main steam stop valve, then we are in the full phase of vacuum. These are the area still we have to improve upon. Already we have achieved some benchmark in these areas also, but we have set our new standard for this. Auxiliary power, already we have reached average auxiliary power consumption from 5.5 to 5%, even minimum to 4.5% in the cold season. We have done some modifications for these also. Like we are using 5 CWs instead of 6 CW at the full load by introducing the concept of interconnection between 2 units. Means we are using 5 CWs for 2 units. In the cold season also we are going to up to the 4 CWs also. Flexible operation, it is the very obvious need of today's power scenario, especially for the thermal power plants. We are daily coming to the 55% and going up to the 100%. This is the content about the APC reduction in startup. which I have already explained. Total revival time also reduced by the introduction of all these things. And also we have set a practice that in every startup we are preparing a consolidated data, and after the startup we are having a discussions to every group of our operation, and they use these practices which were overlooked, not by the ignorance, just by not taking it into the standard practice. We have introduced one important thing also, that before the startup we used to have trials of all important drives which can hinder the process at the time of startup or at the time of loading also. Like we already take the trials of major drives, we take the gun sequence. If any problem is there, that is attended before startup already, if it is the planned startup. Thank you everyone.
Yeah, I had one question regarding flexible operation. What type of operational practices, additional operational practices you are following? Suppose actually we are reducing load up to 40% of the rated capacity. Up to 55% actually we can do. There is no such problem. But when actually it's coming to 40%, what type of coal you are using? That is one of the major areas. And what more operational practices you are following? Operational as well as the chemistry, water chemistry. What type of practices you are following? You please, if you have any such ideas, you can share.
You are very right, sir, about the thing is the 40%. I am not certain about the 40% because we have not achieved 40%, but yes, for 4 into 250 megawatt, we have achieved 51%. We have demonstrated for 2 hours of all of the our 4 units, and for 4 into 600 megawatt, we have reached near about 52 to 53%. But yes, challenges are there. We are also encountering the challenges, and more challenges from the fuel side. Yes, it's obvious that in boiler for 40%, I think turbine has no matter for that, but the component, yes, component is certainly having the stresses at this flexibility. But the more dynamic thing is there in the boiler, and for that is the combustion. And you know, for boiler, heart is flame. And for flame, it is a fuel, and fuel is coal, again, coal having certain quality. So what problem we are facing is a very true to the other also, that if different fuel source is there, so variation is very hard. And for us as a IPP, what challenges we are facing, we are having around 16 to 18 fuel sources every day. So very difficult to have a homogeneous mixture of the, and to conclude what sort of the GCV we are going to use to get 1 hour after that. So again, the difficult challenge is there for 40%, but as of now, for 51%, I am sure not an issue for that. Even 50% is achievable for us for this fuel. But for 40%, definitely we have to go for some burner modifications. For fuel, there should be a similar type of fuel should be there. There should be near about the design value. And then definitely we are going to get it. And moreover that for 40% of the flexibilization, we have to need of the R is that the efficiency. Because everyone is forcing for the 40%. We can go for the 40%. But what about the equipment? They are not designed, they are not meant for the 40%. So here in this area, we are losing the efficiency. So we have to look after efficient, we have to have reached for the 40%. But at the same time, we are also thinking about how to increase our efficiency. Even for 51%, we have tried to reduce the aux power by stopping one cycle of air cycle. ID fan, FD fan. We have not tried for the PA fan because at the lower load and the lesser airflow, we are having the problem with installation. Right. So for that, what we have seen is again a thing which I am going to tell you. For ID fan and FD fan, here power factor is one of the major thing for the motor, which is good enough to tell about. But prior to doing this trial, we don't know. We simply calculating the things VI cos phi, and this thing shows that it is the saving of the power. But while doing and taking the account of the power factor, we are surprised that no power saving was there. And apart from that, we are stopping the equipment twice in a day. Again, since this motor is having some higher capacity, it is very difficult for that to life of that extent of the motor. So we have to think over. So certainly by the practices we have come to know that this power factor play a good important role. Even we are going for the stopping of the BFP also. But think again, 4.5 megawatt BFP we are having. We are stopping it, we are starting it. So what sort of the thing is there on the motor component? We have to look at. And certainly regarding this flexibilization, our government is already taking the initiatives. Hopefully how they are compensating this thing, we have to look after in the future. Okay. Thank you, sir. Thank you.
Thank you.
And important, how much time you are doing this this flexible operation in a day?
For our case, what is today's scenario? We are getting the full schedule from morning 6 o'clock to 12 o'clock for 6 hours. In the evening, we are getting the schedule from 6 p.m. to 8 p.m. Thereafter, we are reaching 55%, we are going 100%. Twice in a day.
Okay, thank you.
Thank you. Thank you. Thank you.
We can discuss amongst ourselves also when we have to.
Yes. Thank you, Team Jindal Power, for such a apt presentation on relevant topic. Very cumulative journey towards optimization. With this, I move to the next presentation, paper 4. This is related, very relevant to the Durgapur, and special Durgapur for newly commissioned unit of 20 megawatt. This presentation is from ISJEC by Shri Arun Tiwari, who is specialized in designing of boilers. The topic of the presentation is efficient operation of ABFC boilers. Shri Tiwari. हेलो ठीक है किससे देंगे ना हेलो
सर नमस्कार। समय कम है इसलिए जल्दी से निपटाते हैं इसको 10-12 मिनट की प्रेजेंटेशन को। वेलकम टू ऑल पार्टिसिपेंट्स। द टॉपिक इज ऑफ कोर्स फॉर द मीट itself is efficient operation of boilers, and we from ISJEC have supplied one boiler here at Durgapur, AFBC boiler। तो कुछ उसके बारे में बात करेंगे और ऑफ कोर्स एक जनरल बॉयलर्स के भी बारे में बात करेंगे। हम लोग बहुत सारी बातें कर रहे हैं यहाँ पे, एफिशिएंट ऑपरेशन एंड ऑल। शुरुआत कहाँ से होती है? शुरुआत होती है वो कंट्रोल रूम में बैठे उस ऑपरेटर से, जिसको वो ड्यू नहीं मिलता है जितना ये बगल वाले को मिल जाता है जो प्लेन उड़ा रहा है। अगर हम ये रियलाइज़ करवा दें उस अपने बॉयलर में बैठे हुए पायलट को कि भाई आप भी ये बॉयलर जो फ्लाइट के पायलट है उससे कम नहीं हो, यकीन मानिएगा सारे जो आपके एफिशिएंट इम्प्रूवमेंट है, ये सारी छोटी छोटी चीज़ें हैं, इतनी बढ़िया तरीके से निकल के आएंगी, क्योंकि हमने कभी उनको बताया नहीं कि वो भी जो इक्विपमेंट चला रहे हैं, आप 250 मेगावाट 500 मेगावाट की बात कर रहे हैं हम लोग ना, इसके अंदर जो पोटेंशियल है एनर्जी का है, तो आज के डेट में सब कुछ इंस्ट्रूमेंट से सब कुछ कंट्रोल्ड है एवरीथिंग, बट कोई फॉरगेट तो कर नहीं सकता, उसके अंदर ये 500 मेगावाट की एनर्जी है। अगर अनकंट्रोल्ड वे में लिबरेट हो तो मैं तो ये जानता हूँ कि एक 500 मेगावाट अगर एक टाउन को लाइट दे सकता है और वो एनर्जी अगर निकल जाए अनकंट्रोल्ड वे में तो उस टाउन की लाइफ भी ले सकता है। तो आई थिंक वी मस्ट गिव फुल क्रेडिट टू द बॉयलर पायलट्स, ताकि आपका जो टॉपिक है इफिशिएंट ऑपरेशन वो अच्छी तरीके से सक्सेस हो। सारी चीज़ें यहाँ पे ऑल द थिंग्स विच वी आर टॉकिंग अबाउट सब कुछ इसी अर्थ से ही आई हुई हैं, सब एक दूसरे के आपस में इंटरलिंक चीज़ें हैं। जो जितना समझ गया इस चीज़ को ज़िंदगी में भी और बॉयलर के पावर प्लांट प्रोफेशनल ने भी, वो उतना अच्छा उसको समझ के और कैसे एफिशिएंटली ऑपरेट करेगा। वी ऑल नो दैट इट्स अर्थ वाटर फायर स्काई एयर, क्षितिजल पावन गगन समीरा। इसमें देखते बड़े अच्छी, आई मीन जस्ट थिंक फ्रॉम दैट प्रोस्पेक्टिव, इनमें से कुछ पेयर्स बड़े ही ज़बरदस्त तरीके से चलते हैं और यही बॉयलर पावर प्लांट की केमिस्ट्री भी है। असलियत में देखा जाए तो बॉयलर आइडियली दो दुश्मनों की लड़ाई भी है और दो प्रेमियों की कहानी भी है। दो दुश्मन जो ऊपर बने हुए हैं, आग और पानी, और नीचे जो दो दोस्त हैं या इपिक लव स्टोरी है। कोई बता सकता है क्या हो सकता है वो? कौन से दो ऐसे आउट ऑफ दिस 5 एलिमेंट्स जिनका आपस का प्रेम इतना बियॉन्ड आवर इमेजिनेशन है, जिसको हम लोग देखते रहते हैं? वो है हवा और पानी। ज़बरदस्त है, देखते थोड़ा सा और इसके बाद में हम आपको बताने की कोशिश करेंगे कैसे ये एफिशिएंसी में रोल प्ले करते हैं। पहले आ जाते हैं हम लोग जो सबसे खतरनाक हैं, एक दूसरे के दुश्मन, सारे बॉयलर के पावर प्लांट्स यानी डिज़ाइनर। आई कम फ्रॉम अ बॉयलर डिज़ाइन कंपनी, सो मुझे मालूम है कि क्या रोल रहता है डिज़ाइनर का। एक ज़बरदस्त रोल रहता है उनका कि ये जो दुश्मन हैं, दो दुश्मन हैं, ये आपस में तो एक साथ रह नहीं सकते, दोनों ख़त्म हो जाते अगर आपस में भिड़ जाएँ तो इन्होंने इनके बीच में एक दीवार डाल दी, विच इज़ नथिंग बट योर ट्यूब। तो एक साइड पे चल भाई तुम इधर रहो, मैं इधर रहता हूँ, और दोनों एक दूसरे को भिड़ने की कोशिश कर रहे हैं और बीच में पड़ गई बेचारी ट्यूब। इसी ट्यूब को बचाना ही बेसिकली बॉयलर की डिज़ाइन है। सच बताऊं कि जो अंदर पानी है वो अपने सारे इल इफेक्ट, जिसको हम लोग वाटर केमिस्ट्री के नाम पे जानते हैं, वो छोड़ रहे होते हैं। कोई करोजन कर रहा होता, कोई इरोजन कर रहा होता, कोई फाउलिंग स्केलिंग सब चालू रहता है। और ऑफकोर्स बाहर साइड से जो फायर है, स्लैगिंग, करोजन, इरोजन, फाउलिंग, ये सब भी चालू रहता है। और यकीन मानिए अब जो टाइम आने वाला है जिसमें कोल नहीं मिलने वाला है और सच की जो भी बात हो रही थी, बायोमास फ्यूल, ये स्लैगिंग, ये करोजन, ये सारी चीज़ें बायोमास के साथ में भी लिमिटेड है। इन्हीं सब को बचाना ही बेसिकली बॉयलर का डिज़ाइन है आइडियली। और यही फाइनली जब आपके पास बॉयलर के फॉर्म पे पहुंचता है तो एफिशिएंट ऑपरेशन भी इन्हीं सब चीज़ों को मैनेज करना ही रहता है। जो मैंने दूसरी केमिस्ट्री आपको बताई वो भी बड़ी ज़बरदस्त है। ये एक प्रेजेंटेशन होके गया है कूलिंग टावर की परफॉर्मेंस का, उसमें भी एक वर्ड आता होगा इफेक्टिव, उसमें रिलेटिव ह्यूमिडिटी क्या चल रही है ओवरऑल। वाटर इन एयर एंड एयर इन वाटर, ये दोनों चीज़ें हैं। मतलब ये तो अपने आप में एक साहित्य लिखा जा सकता है। इसमें पानी में हवा घुल सकती है, हवा में पानी घुल सकता है, दोनों चीज़ें हैं। और हमारी बॉयलर की वाटर केमिस्ट्री की बात करें, अगर मैं एयर इन वाटर से शुरू करूंगा, डिजॉल्व, ऑक्सीजन, करोजन, फिटिंग, ये सारी चीज़ें उसी की कहानी है। जितना घुसेंगे उतना आपको बहुत ही मज़ा आती चली जाएगी कि क्या क्या रिलेशन है इन दोनों के बीच में, अद्भुत प्रेम है। एट द सेम टाइम जो हवा है उसके अंदर जब पानी घुसता है कितना ले सकता है। एंड वेरी इंटरेस्टिंगली, पानी जब गर्म होता जाएगा तो उसके अंदर जो ऑक्सीजन है उसकी घुलनशीलता है, सॉल्युबिलिटी, वो कम होती चली जाएगी। एट द सेम टाइम हवा जब गर्म होती जाएगी तो ज़्यादा से ज़्यादा पानी लेता चला जाएगा। अच्छा टॉपिक है, कभी आप लोग फुर्सत में इसके ऊपर पढ़िएगा। तो यहाँ पे केवल बॉयलर से हमें रिलेशन रखना है, तो हमारे लिए ऊपर वाला केस जो है कूलिंग टावर परफॉर्मेंस में आता है, फ़ैन की परफॉर्मेंस में आता है, बॉयलर के अंदर जो हम डिज़ाइन करते हैं उसमें एयर में कितनी मॉइस्चर आ रहा है, वो सारी चीज़ें आती हैं। और एयर इन वाटर हमारा वाटर केमिस्ट्री से लिंक्ड हो जाता है। सारी चीज़ें चल रही है। मैं इसमें अभी कोई डिस्कशन और कुछ नहीं चाहता हूँ, क्योंकि ये रियली टॉपिक्स अभी बहुत सारे आएंगे। जितना हम बेस से पकड़ने की कोशिश करेंगे उतना ही आपको ज़्यादा समझ में आएगा कि व्हाट इज़ बेस एफिशिएंट ऑपरेशन। फ्यूल की बात करें, हमको यही जानना है, ये बहुत इंपॉर्टेंट टॉपिक हो रहा है आज के डेट में। फ्यूल को जितना अंडरस्टैंड कर पाएंगे, थोड़ा सा टॉपिक अभी आएगा उसको मैं कवर करूँगा, जिसके अंदर क्या ऑक्सीजन, क्या कार्बन, क्या वोलेटाइल मैटर, एंड मोस्ट इंपॉर्टेंट उसकी ऐश का नेचर क्या है, ऐश की क्वांटिटी कितनी है, वो हैंडल करना इज़ द रियल चैलेंज फॉर डिज़ाइनर एज वेल एज फॉर द यूज़र ऑल्सो। एक बॉयलर एक पर्टिकुलर फ्यूल, मतलब हर तरीके के फ्यूल के लिए तो बॉयलर डिज़ाइन नहीं हो सकता, ये बिल्कुल क्लियर है। तो एक पर्टिकुलर रेंज के लिए बॉयलर डिज़ाइन किए जाते हैं और आई एम श्योर कि उस रेंज से थोड़ा बहुत तो एकोमोडेट कर सकते हैं, बट अगर कोई बहुत ज़्यादा चेंज आता है तो बॉयलर may not be capable of handling all those things. We must understand that also. वाटर में क्या है, कुछ फंडामेंटल्स हैं, कुछ स्टील के केमिस्ट्री है, आयरन, कार्बन, क्रोमियम, एलॉयज, वो सारी चीज़ें समझ लेंगे। और हवा के बारे में यही बेसिकली बॉयलर की कहानी है ओवरऑल, चाहे वो AFBC बॉयलर हो, चाहे PC हो, चाहे कोल हो, 8-10 तरीके के जो बॉयलर्स हैं उन्हीं सब के ऊपर है ये। हमने जो दुर्गापुर में बॉयलर दिया है वो 88 टन का बॉयलर है और हाई प्रेशर बॉयलर है। देयर वाज लॉट ऑफ टॉक कि क्या हमें इस AFBC बॉयलर की ज़रूरत थी। बहुत ही ब्रॉडर सेंस में देखें तो सबको मालूम है किसी फ्यूल को जलाने के लिए TTT की ज़रूरत है, टाइम टेम्परेचर टर्बुलेंस। एंड आउट ऑफ ऑल टेक्नोलॉजीज़ ये जो हमारा AFBC बॉयलर है और एक इसका अपग्रेडेड CFBC बॉयलर, ये दोनों इस टाइम टेम्परेचर टर्बुलेंस और फ्यूल फ्लेक्सिबिलिटी एट द सेम टाइम पोल्यूशन कंट्रोल नॉर्म को गवर्न करते हैं। तो ये बॉयलर सेलेक्ट किए गए होंगे। अब उसके ऊपर ये क्यों किया गया उसके ऊपर तो बहस करने से कोई बात नहीं है। नाउ वी हैव टू थिंक कैसे इसको चलाना है, क्या इसकी लिमिटेशन है और क्या क्या चीज़ें हमको देनी पड़ेंगी। कुछ चीज़ें जो अभी हम लोग को शायद एज अ टेक्निकल पर्सन्स बहुत सारी चीज़ें हम लोग को केवल जो डिज़ाइनर ने बताया होता उस तरह से चलती रहती, तो हमको कुछ चीज़ें अपनी थंब रूल फॉर्मूला से भी चलना चाहिए। जैसे आइडियली मैं पहले ये स्लाइड दिखा दूँ पहले आपको कि कोई भी बॉयलर में डिफरेंट काइंड ऑफ पार्ट्स लगे होते हैं, उसके अंदर क्या मेटल टेम्परेचर चलते हैं, क्या मेटलर्जी यूज़ की जाती है, वो ज़्यादा ज़रूरी है सबको जानना। तो उसको एक सिंप्लीफाइड वे में मैंने समझाने की कोशिश ये किया है कि अगर आप ये 3-4 थंब रूल फॉर्मूला जो भी बॉयलर से रिलेटेड है, आदमी है ना भी हो तो भी जाने हैं वो, कि अगर मुझे किस प्रेशर का बॉयलर है उसके अगेंस्ट क्या सैचुरेशन टेम्परेचर चल रहा है, इस फॉर्मूले से डबल स्क्वायर रूट ऑफ ड्रम प्रेशर इंटू 100 करके निकाल लीजिए। उसके बाद में अगर ट्यूब का किसी भी टाइप के इवोपोरेटर्स जिसमें स्टीम बन रही है उसका मेटल टेम्परेचर निकालने का फॉर्मूला है कि आप सैचुरेशन टेम्परेचर में 26 ऐड कर दीजिए, अब ऑटोमेटिकली जो हमारी बॉइलिंग टेम्परेचर वाले कंपोनेंट होते हैं उसका निकल आता है। एक और थंब रूल फॉर्मूला है कि मटेरियल का एक्सपेंशन 1 मिलीमीटर पर मीटर पर 100 डिग्री सेंटीग्रेड। Many more thumb rule formulas are there, but I am just sharing here just for the knowledge of all कि ये 3-4 thumb rule formula से we can do miracle during operation। इस वाले में एक थंब रूल फॉर्मूला और दिया हुआ है, डिफरेंट काइंड ऑफ मटेरियल्स जो होते हैं बॉयलर में या पार्ट्स होते हैं उनके मेटल टेम्परेचर्स क्या चल रहे होंगे। तो आप देखेंगे इकोनोमाइजर जैसी चीज़ का थंब रूल फॉर्मूला है कि आपको फीड वाटर का अगर वाटर टेम्परेचर मालूम है जस्ट एट 13, ऑल द बॉइलिंग जहाँ पे लेटेंट हीट ऐड होती है वहाँ पे आप 26 ऐड कीजिए, लाइक योर फर्नेस वाटर वॉल ट्यूब, इवोपोरेटेड ट्यूब्स। ऑल द कन्वेक्टिव सुपर हीटर्स स्टीम टेम्परेचर प्लस 39, रेडिएंट प्लस 52, बेड कॉयल जैसे हमारे यहाँ इस बॉयलर में बेड सुपर हीटर उसमें प्लस 65 ऐड करके हम उन मटेरियल्स का मेटल टेम्परेचर निकाल सकते हैं। और इसी तरह से एक और थंब रूल टेबल दी हुई है कि अगर आपको मेटल टेम्परेचर मालूम हो गए तो आप किस मेटल के लिए कौन सा मटेरियल यूज़ करना है। एक बॉयलर्स में हार्डली 5-6 डिफरेंट काइंड के मटेरियल यूज़ होते हैं। कार्बन स्टील 427 डिग्री सेंटीग्रेड तक के लिए यूज़ होता है एज पर ASME IBR। उसके बाद में अगर मेटल टेम्परेचर ज़्यादा जा रहा है तो वी कैन यूज़ T11 ग्रेड विच इज़ हैविंग 1.25 क्रोम हाफ मॉली, देन T22 580 डिग्री का अगर मेटल टेम्परेचर जा रहा है देन से बियॉन्ड जा रहा है देन वी गो फॉर अ T91 मटेरियल एंड देन ऑफ कोर्स there are various grade of stainless steel. We must know efficient operation में ये भी आता है कि अगर आपका कोई ट्यूब सपोज प्रेशर पार्ट फेल हुआ तो you must know कि इसको किस मटेरियल से रिप्लेस करना है। There have been many incidences across the globe जहाँ पे लगना चाहिए था मटेरियल में एलॉय स्टील और लग गया कार्बन स्टील। उन्होंने क्रॉस चेक नहीं किया, कुछ नहीं देखा, उन्होंने सोचा ट्यूब ही तो है लगा देते हैं। वो भी एक इंपॉर्टेंट पार्ट रहता है इसका चेक करने का। रही बात फ्लूडाइजेशन की, तो फ्लूडाइजेशन जो है AFBC बॉयलर मेरे ख्याल से NSPCL में ही AFBC बॉयलर है। मैनी ऑफ यू मे बी ऑपरेटिंग विद PF बॉयलर्स। तो AFBC बॉयलर आइडियली केम फ्रॉम द वर्ड फ्लूइड, और फ्लूइड की जितनी भी प्रॉपर्टीज़ हैं वो सब जब ये बॉयलर अपना 800-900 डिग्री सेंटीग्रेड पे पहुंचता है इट स्टार्ट्स बिहेविंग लाइक दैट। फ्लूइड के अंदर जो प्रॉपर्टीज़ है It maintains a horizontal level. एक AFBC boiler अगर चल रहा है, 5 compartment है, if they are fully operating, they are maintaining the same bed level. Denser material sink, अगर फ्यूल के अंदर पत्थर आ रहा है, लोहा आ रहा है, शेल्स आ रहा है, तो वो नीचे बैठने ही वाले हैं. It sinks. Horizontal level, high level से low level flow. एक ड्रेन आप खोल देंगे, पूरा का पूरा जो अंदर का कहानी ये सब ड्रेन हो जाएगा, बिकॉज एक्टिंग लाइक एज अ फ्लूइड. Can be drained, can attain any shape, head is proportional to the height, vessel connected with the shape. So these are the properties basically adopted in that. So ability to flow, the best part, beautiful part of fluidized bed boiler is because you can fire here, I mean lower quality of coal if designed. Again the word is very clear, you can design a boiler where even the boiler coal property is not good, then you can also design. Another important part of the fluidized bed boiler is because here is another special part which is called as bed evaporator coil, which is submerged into the bed. I will say around 25 to 30% of the total steam generation of the boiler is done from the bed coil. So that becomes a very, very essential part of the whole circuit. A simple schematic of the ABC boiler just for understanding to all others who may not have seen that boiler. Here is the bed coils. Those are fully, I mean, U-type shaped furnace water wall. There can be two types. One which is evaporating, another is from the superheating type. And all four sides you have a normal, like any other boiler, you have a 4 walls. You can have radiant superheater, you can have convective superheater, and then the rest of the circuit remains same. Fuel feeding system is again can be two types. One we call it as a overbed, another is from the underbed. These boilers are underbed, as I was mentioning. From the bunker it comes from the drag chain feeder, finally through a mixing nozzle from where air and coal gets mixed. It's come from the bottom of the wind box, wind box from where the air is coming, and these are the top points, coal nozzles through which coal is coming. A typical arrangement of the fuel feed system of AFBC boiler underbed feeding. Another type of boiler, I'm not going to cover this. This is a typical view of your AFBC boiler. We are talking about the coal is coming from these yellow lines. All these are the air nozzles from where air is coming. Everything is fluidizing. And these are the bed coils which are submerged into the bed from where, because it's a conduction, convection, radiation, all type of heat transfer takes place. 25 to 30% of the steam generation takes place from these coils. Top view of the bed coils. Advantage is it can get very high heat transfer, but the negative point is because it's submerged into the bed where a lot of sand blasting is taking place. Erosion potential is quite high in these bed coils, so we provide studs over there, and then refractory is also covered so as to increase the length, increase the life of the pressure part. This is the top view, how the domain of individual bed coils comes into the picture. Bed coils, how the coal is spreading across the bed, how a lot of research have been done for this spreading and minimizing the erosion potential and increasing the life of the pressure parts. All such things have been done. Coming back to the another very important aspect, efficient operation. You just talk about the boiler has been designed for a particular efficiency. Say for this different defined quality of coal, it's say suppose 80%. I'm just saying. So if you talk in the total sense, it's a matter of hardly 1% change in efficiency that you must all know. Okay, how much, addition operation or operation team can do. It's always a matter of 1% change in efficiency. Like as a thumb rule, if the back-end temperature is increasing by 20 degrees, the gases going to the chimney or to the pollution control equipment has increased by 20 degrees, you are going to lose roughly 1% of efficiency. That's how your soot blowing and everything comes into the picture. Even water chemistry also comes into the picture to maintain this close to 20 degrees. Then comes the efficient operation point of view, how you are maintaining the excess air. It's always said that for every increase of 25% of excess air, you are going to lose 1% efficiency in form of the dry flue gas loss which is going to the chimney. So you must also know that optimum air has to be maintained, or I will say optimum oxygen percentage has to be maintained for operating near to the design efficiency. The point which is not directly in hand of control of operator is the fuel, hydrogen in the fuel. That also says that if hydrogen percent in the coal is increasing by 0.4%, you are going to lose 1% efficiency. For every 3.5% increase in moisture, again 1% efficiency. So if you just see everything, it's hardly few things which are in hand of boiler operation team, that is back end temperature somehow, or even excess air. These moisture and hydrogen comes inherent from the fuel, right from the source, and your moisture can be controlled if you have a good shade and all those things. We must keep this, and of course all the operating team must ensure that everything evolves along with this. Similarly, from the water chemistry point of view, quickly just going through, we don't talk about a lot of water chemistry, but we must understand that in boiler water power plant we are maintaining all the pH in particular range, because it has been established that if water pH is in this range from 8 to 11, the water is least corrosive to the steel. So this is how this curve is maintained, and you will always find that your feed water and boiler water is always maintained between 8 to 11.5. This is basically fundamental from this only. This is a typical water chemistry, at least for what ISJEC is representing to their boilers. I'm just talking about the two aspects, just touching. Here, to maintain your pH, we are boosting one pH booster, which we call it as a morphine or cyclohexylamine. And at the deaerator, we recommend to dose hydrazine, or there are 3-4 more chemicals, DEHA, carbohydrazide. What I just wanted to talk about is, whenever these chemicals comes and finally it reaches the water comes to the drum, because we need to maintain the pH of the steam also. So we have dosed here pH booster in form of morphine, which has a tendency to go along with the steam. So when it comes to the drum, that morphine goes along with the steam, so that your pH of steam is maintained. And for maintaining the boiler water pH, we are recommending to dose your HP dosing, which we call as a TSP, trisodium phosphate, for this. This is how the water chemistry of this is done. Deaerator is a very, very essential part. Why I'm just touching few topics, because this is playing a key role in the boiler efficient O&M. M में बहुत सारी चीज़ें आती है, कोई भी इक्विपमेंट खराब होता है, फेल होता है, उसके पीछे के रीजंस. You must all know the deaerator principle. At the same time, this has to be a part of your inspection checks to always ensure that your deaerator is functional. As has been saying that it's little difficult to measure oxygen, and we are feeding hydrazine as a neutralizing of oxygen. तो हम लोग इसको ऐसे कहते हैं कि आप ऑलवेज हाइड्रोजीन का ppm 6 to 8 ppm मेंटेन करें in the feed water. So it's always treated that hydrazine and oxygen, they are just like another big enemy, that is सांप and नेवला. Okay, तो दोनों आपस में लड़ते हैं when we dose, and at the end if we find that in the feed water outlet, if you have 6 to 8 ppm, that means it has killed all the oxygen, just for the understanding purpose. So this is also equally important. Then comes to the few aspects of the AFBC, which is essential. I have listed few parameters, what is responsible for that. I'm not going to discuss all such things in detail here, but you all know, if there is an issue of the boiler is load nahi le raha hai, then there could be a fuel quality. At NSPCL, I would like to specify here, NSPCL boiler, which is supplied by ISJEC, AFBC boiler is designed for a certain quality of coal, certain GCV of coal, certain ash percentage of coal. And the coal which is being used has large deviation in terms of GCV, in terms of ash. So there are a lot of restrictions is coming. Right? Okay, so we are just quickly passing on this. These are the small parameters. Cause analysis. If that is happening, what is happening that? I'm not going to cover that. I'm just going to finish this quickly. You can have this. Everything is written in the O&M manual also. I just want to cover at the end. High unburned carbon, how this is happening, excess erosion of bed cover. Yeah, before this, last, so that you can be happy. As I started, the treasure is closing with the same phenomena. Boiler operation is a serious profession. If you may have seen in Indigo flight के केबिन में, पायलट के केबिन के बाहर लिखा रहता था, flying is a serious profession. Please remove all your worries before entering into the cabin. Boiler operation too is equally serious profession. And the boiler pilot who is going to sit on that desk has to keep all these worries for that. And most importantly, this is your boiler. I'm just asking about, this is a boiler. This is a pilot's 5 indries representing. Those has to be kept always active because boiler में बहुत सारी dynamics चलती रहती हैं. उसको acknowledge करना, उसके according action लेना. That is what is I call is the efficient operation. Thank you very much. चलिए भैया.
Thank you, sir, for such a nice presentation on the topic which is very relevant to our Durgapur station. We have representation from OEM also in this O&M meet. We have Shri Madhusudan Kulkarni and Shri Amit Agrawal from GE. Shri Madhusudan Kulkarni has experience of more than 25 years in the field of power plant metallurgy. He is basically metallurgical engineer from MS University Vadodara. He is also a faculty member giving lectures in various universities on metallurgical topic. He is associated with GE and he will be presenting his paper on the topic rotor weld restoration for large steam turbine rotors. Sir, please.
Good afternoon. First of all, good afternoon to honorable dignitaries and distinguished guests here, distinguished participants. I would first of all like to thank the NSPGCL team for inviting us and giving us an opportunity to share this session with you all. And I'm also joined by Amit Agarwal, who is the head of our service sales. We talked a lot about the flexible operations, and flexible operations take a toll on the steam turbine rotors. It was a very interesting presentation on boilers, and now we are entering into the next area. After what the steam generates, it comes to the steam turbines. The basic problem here is when you do the flexible operations, it takes a toll on the rotating equipment. That's the most dynamic equipment as far as the power station is concerned. Rotors rotating at, something like 3000 RPM and sometimes higher speeds. Like for example, a boiler feed pump turbine could operate something at around 6000 RPM. So what happens? These stresses increase on flexible operations. You're operating at a lower load, let's say we are talking of 55%. So the water chemistry changes happens, and if not controlled, like rightly said in the earlier presentation, a 500 megawatt which is generating several power for several homes can become a bomb. So the rotor, if it cracks and if something fails, especially the low pressure rotor, is a huge catastrophe can happen. It can blow up the entire turbine floor. So this particular case study is of such a rotor where we have tried to salvage the rotor by welding it. after the cracks have generated. So in a typically 500 megawatt rotor, it's a 3-cylinder turbine with a high pressure rotor, an intermediate pressure rotor and an low pressure rotor. The most stressed and the most heaviest part being the low pressure rotor, which you can see on the screen. So a particular section of this rotor, which we call it as the blade attachment areas, now the blades have been removed in this particular case. It's a regular practice to remove these freestanding blades and check it during each overhaul. And once we have done the DPT or the magnetic particle inspection, we can see such kind of cracks on that attachment area. Now these cracks, how dangerous they are. I mean, as a power plant professional, somebody could say just grind it off, or why can't we locally weld it? But it's serious because it's a very high stressed area. So if you try to weld it up, it will create a heat affected zone which is much weaker than that particular rotor forging. So you can't do a local welding. Likewise, if we machine it off, then the blade attachment part becomes weak, so the blade can anytime fly off if you try to contour it or do something, remove that top steeple. So then what next? Unfortunately, these forgings are all single piece, like they are monoblock forgings. It's an 80-ton forging what we are seeing over here, which has undergone 200 starts, roughly about 1,45,000 hours. And now the question comes that, okay, it has cracked, now what next to do? So obviously the OEM said that nothing doing, we can't allow this dangerous things to fly off, and they rejected this piece of rotor. And that's where GE came in, and we have a technology of building up rotors instead of monoblock. We make smaller forgings and weld it together. We call it as built up rotors or weld on rotors. So that technology was extended to say that, hey, why can't we machine this off and only weld a portion of it, and then restore this back. So that's the challenge what was taken up in this scenario. This is figuratively showing how big the rotor is. Like I said, 85 tons. The inlet temperature is 300 degrees with a inlet pressure 7.57 ATA. This is the original material specification. Again, the rotor specifications don't vary much, whether they are Chinese, whether they are BHEL, whether they are GE. They have a certain range of specifications. And that's it's a 2x6 double flow. So the steam comes in the mid portion and then expands on double flow. There are 6 stages in that. And we were faced with the challenge of cracks on the 4th stage. Right, so this is our workshop located near Ahmedabad. It's a facility in Sanand, and this is where it came for inspection. The first step what we do when we get such a case is, of course, the root cause analysis. We need to understand how that rotor has damaged, and once we know the root cause, then we'll be possibly able to build up what kind of procedure we need to salvage it. So the root cause itself is a big activity because you need to have access of the crack, first of all. So how to extract that crack? It takes up in the lathe part of that particular steeple area, like what you can see here. And then this parted off thing is then wire cut to extract the crack so that you are not going to sabotage that area which carries the proof. And then of course there is another complicated part which comes is, we'll need to machine this later on, so you need to capture accurately the dimensions of this, because the blades which will get fitted into this one will be the old blades to a new steeple. So that is the 3D model has to be built of that with the crack configuration match. So the red line shows actually how the crack has progressed into the steeple. Okay, and then we go on to a typical, a kind of a root cause, or let's say a failure analysis which goes by an elimination theory. Okay, is the rotor material bad, or is the water chemistry bad, or for example, are the stresses too high, or were there frequency issues, off-grid grid frequencies taking a toll on the rotor, flexible operations, for example. So it all starts with a stress analysis. What you can see here, a stress profile is drawn out. And then the fracture analysis, which includes the fractography, chemical analysis, and then EDAX and things like that. And also a dimensional analysis, because assembly can also play a major role in, if the clearances are not proper or something like that, can also result into a failure. Now, what can be seen in this particular case study is that, you can see the microstructure here, which shows a lot of crack branching. In metallurgy, they call it as in intergranular cracking. And that intergranular cracking plus the stress, which is very high on this thing, then boils down to particularly two reasons. Either it's a corrosion fatigue or it's a stress corrosion cracking. So that part forms as an input to our repair procedure. The next is a very detailed process of how this is repaired. I'll go into the detail as we go ahead, but basically what we do is we kind of, you can see we cut off that steeple. Of course, we inspect the rest part of the rotor. Then there is a particular important part is where to place the weld. As I said, the heat affected zone should not come in a highly stressed area. So you need to cut off significant portion of that particular rotor based on the stress analysis. So we locate that HAZ in a certain area where the stresses are slightly lower. This is a column and boom machine. So we used a kind of a submerged arc facility, submerged arc welding facility in our shop to rebuild, because it's a very high volume deposit. So you need productivity on that. Plus, the defect level has to be equivalent to the forging defect level. That's the other requirement. Then you require to get the properties by a heat treatment. So it requires a kind of a stress relief. You cannot put the entire, big mass into the furnace, because the rest of the areas will get, the properties of the rest of the areas will reduce. So that's the heat treatment, which you can see over here. Of course, customers demand, okay, what will be my defect level? So there is a phased array ultrasonic testing which goes into assuring the customer, saying that my weld deposit is perfectly clean. Then we go in for the steeple machining. So if you see the weld block here, it is just a rectangular block, and that kind of steeples you need to machine, which requires a special milling facility, which we have in our shop. And then finally followed by the blade assembly. So two processes which are also important in this is, you can see on the top corner here is a robotic short pinning. Now this short pinning, what does it do is it improves your fatigue resistance. So since we have welded that block, we also need to improve the fatigue resistance of the weld. And that's why we short pin that. And the robotics is because you can see the steeple shape itself is very complicated. So it needs to follow that particular path. And then of course the blades assembly, you can see the rotor after the assembly process at site. And the other challenge is, we need to maintain the same flow path as what it was earlier. So we do also support the site installation. So you can see the site installation there. Okay, so what are the challenges here? People could feel, okay, it's a rotational welding facility and then you just nicely weld it and that's it. So there are few challenges which need lots of preparation, lots of work on this, is how should we handle the rotor? Our colleagues were talking of safe operation in the first presentation. Safety is utmost. And it's a heavy piece of equipment which is going to get flipped around, maybe it will get vertical or it will undergo a hot process. So safety is utmost important, handling is most important. So we need to remove some of the blades which will become a hindrance to all this. So that's the first thing. And customers would not like to purchase new blades, they need to retain the old blades. So again, you need to take care of these old blades, fitment, and guarantee that fitment. So that's the first challenge. The second challenge is, this weld buildup is typically about, if you talk of the thickness, it's about, or let's say the diameter wise, it's about like 800 mm. and width-wise it is 300 mm. So it's like a 1.2, 1.3 ton deposit. Now something goes wrong. You cannot inspect it midway because it's all going to be hot. You need to maintain a preheat temperature, etc. So you can't inspect it layer by layer or something like that. Once you finish the weld, then you proof machine it, and then only you will be able to inspect it. And if there is a defect, you need to cut off the entire weld. Again, a small local repair would not be permitted. So the most important thing is the discipline of the welders and whether they have understood the entire process. There is a semi-mechanization on that so that you don't get any defect at all. It's like the highest quality for the first time. So that needs to be maintained. That's the other challenge. Then the heat treatment. Now the heat treatment has two challenges. It goes to temperatures beyond the processing temperature of the old metal, old forging. So somebody could ask saying that, are those properties going to drop? So it needs a certain gradient to be maintained. That's the first thing. Second thing is rotors distort. So if something has operated for 1,45,000 and you just heat it up to 600, 700, which is beyond the steam temperature what it is subjected to, you will get a runout, maybe. The rotor sags, it bends. You may get a coupling distortion somewhere else. So this distortion factor has to be controlled by controlling this gradient. And that's where another stress analysis is required to predict the temperatures, measure them, and then control it later on so that the rotor should not distort. Likewise, every time, whether you weld it or whether we stress relieve it, it needs to be always rotated. So it's a dynamic process. You rotate and measure, which requires this piece of equipment. The other thing, now this particular example is of a 500 megawatt BHL Kavayu design. So it's not GE design. Then what's the challenge is, how do I get this geometry, first of all? How do I get what was the original intent of the designer? So what are the clearances, for example, on this, or how should I maintain this radiality and things like that. So there are various parameters on the design which need to be maintained. So that first of all, the very first thing what we do on the rotors is reverse engineering, which is basically the data capture. And then comes the improvement part, because we don't want to reproduce it copy to copy. We will use the GE principles to either improve the metallurgy or improve the fitment characteristics, like I said, or improve the fatigue resistance, for example, short peening, coating, etc. So that needs to be added upon this one. The advantage of this re-engineering process is the technology is design agnostic. So tomorrow I want to apply it on Shanghai Electric or maybe Dongfang or maybe Toshiba machines. It's easy for me to adopt this practice and then reclaim those rotors as well. So that's the kind of process we would follow. Now the other thing is guarantee, because this is a much talked about subject. Okay, you're going to weld such a risky welding, and then the OEM has already rejected the rotor. So how do you say you're going to restore it? Because probably we are the only ones in this country who are doing it. So then that becomes a botheration for the customer. Will you guarantee me like a new rotor or something? So what we do is we have a calculation saying that if my weld defect is as tiny as 2 mm, because that's my acceptance level on the welded part, only a 2 mm equivalent reflector size. Uska matlab hota hai ki any size which is there, but that defect I will not allow it is beyond 2 mm. I have to cut across that weld and then rebuild it. But this 2 mm defect on the most critical area of the rotor, how many cycles it is going to withstand given your own conditions. So the power plant is going to give me saying that, like they had presented, saying that these many cold starts I'm going to use, these many hot starts I'm going to use. So how is your weld going to perform to those starts, right? So that I need to simulate it, that how is my 2 mm defect going to grow further. And then that cycle output I will take, and then I will say, okay, this will be my life of the rotor. So that's how this is guaranteed. Of course, needless to say, it's the same output and you are running it at rated parameters, whatever you were running earlier your rotor. So this is our experience. We have about, in India itself, we have welded more than about 23 plus rotors, including, something like 660, 500 large steam turbine rotors. Apart from the smaller ones, when I say large, this technology is also applicable to the smaller ones, but the mix and match, has to be calculated techno-economically. So there would be a break-even where, certain size of the rotors it is very fruitful, and a certain size of very, very small rotors it might not seem to be that attractive, wherever you can get the forging very fast. So what advantage does it offer? Basically, it offers low cost, of course. We are talking of cost effectiveness. It kind of, you can say, an optimization. It optimizes your asset. You don't have to throw away this particular rotor. It offers you a decreased delivery time, so you don't have to wait a long time for a new rotor, right? And it is design agnostic. So if any utility is kind of this design, Toshiba, Shanghai, Kawayu design, etc., we would be able to accommodate that and do it. Plus, it's a sure shot thing. We do the high-speed balancing in the balancing spin pit, so it is already proven at 3000 RPM, right? So this is it could save a lot, and a one-stop solution. We have everything in one roof. So that's the thing. Thank you. Amit, you would like to add something? Just 5 minutes.
So probably, apart from the repair, see, if we go in for the repair, if we are getting a new one, so probably there is again the repeatability of the same defect, right? First of all, they should not have failed. If it has failed, there are some inherent defects, and unless and until that RCA is carried out, right, those cannot be addressed. And whatever we have seen, so none of the OEMs, right, they really go to that level to figure out what has caused that failure. What they do is they do a superficial analysis and they define that it is beyond repair, you reject it, right? So first of all, somebody, if they say we have to introduce those modifications, they have to study it, right? But at our case, so because we are doing those RCAs, so we are very, very clear on that. We can guarantee that those type of failures will not reoccur where we are doing the repair. See, maybe there are two flows. On one flow I have repaired, the other flow might still face a challenge, right? And yes, we can give a recommendation that if that also needs to be eliminated, what are the things needs to be addressed?
So we have
confidentiality purpose, probably we will not be able to share the link, right? But you can say, I can say we have worked on nuclear turbines, right? Yes. Which are basically operating in saturated zones, right? We have worked, you talk about a megawatt, starting from 30 megawatt till 660 megawatt, right? We have worked on all the ranges. So we can definitely share a couple of
yeah, I mean, on a broad way, design-wise, we have worked on Kawayu, we have worked on DEC, we have worked on SEC. That's the design, and of course our own equipment, because nuclear equipment is all our own. And they face a certain issue on saturated steam, so that also we have worked on. And megawatt-wise, if you want to know, it's like even from 10 megawatt onwards to 660 megawatt. NTPC also.
So not only the rotors, but casings also, right?
Yeah.
So we have rectified the casings also, say typically 500 megawatt casings and all those things, which were
rejected,
right? Not only on Kawayu, but on DEC, correct? Because see, now this power sector is really stressed, right? Steam power sector. So we cannot afford to have more of inventory, right? We don't have that leverage what we used to have 5 years back. So we are cognizant of that, and that's where we are trying to say that give us an opportunity, definitely we will not let you down. Okay.
Thank you.
One thing, actually, what is your suggestion? Such type of repetitive problem, actually, if we face, in that case, what is your suggestion? After 2 years, actually, we have to open the turbine, you have to see.
Okay, so this, for the case study, what I already gave 500 megawatt, because, sometimes customers have given us multiple orders once they have given one order. But in certain cases where it's the first time, they want to see it like, in our case, we don't say that you open the turbine after 2 years and inspect it. The old guideline which is given by the OEM, as per the OEM guideline, for example, you are taking a COH after 5 years of time, you can re-inspect it after that 5 years. But there are certain, like NTPC, for example, they may say that, okay, I'm going to inspect after 2.5 years because I'm going to take such and such shutdown, and I don't believe maybe the weld, we need to inspect it. So we have done those inspections also. Like we inspect it after, but if you ask GE suggestion, we don't suggest any intermediate inspection. A normal inspection which you do, which you were following earlier in your regime, the same thing would be applicable.
And these failures predominantly are because of the freestanding blade vibrations. Right?
Yes.
So we are addressing it. And we can guarantee you that because of that it will not fail, because see, you have addressed the blade. So it will move to root. Correct? So we can guarantee you that that blade will not fail because of vibration. And also we can share a protection diagram which will help you to operate your unit and define that after how many hours of operation you need to really go for an inspection.
Yeah.
Okay, chalo. Thank you.
Thank you, sir.
Thank you, sir, for taking us to the tour of whole process. Sir, there is a slight change in the program. This will be the last paper of this session. Thereafter, we will break for lunch. And this paper will be given by DVC, by Shri Rajiv Ranjan Sinha and Shri Abhishek Kumar. Shri Rajiv Ranjan Sinha is Superintendent Engineer, Electrical Construction, and he has experience of more than 15 years across various functions in power sector. He is presently monitoring and ensuring all construction related work of FGD. And Shri Abhishek Kumar, he has worked in operation department, construction department, and conditioning, monitoring and maintenance planning cell. At present, he is working as executive engineer in DVC BTPS. So the topic of the presentation will be utilization of advanced NDT techniques in boiler inspection for improving reliability of thermal power stations. So I invite the presenters. No, kar.
Thank you. As Tiwari Sahab said, Kshitijal Pavak, Gagan Samira, we can call our power plants in this name also, because we are dealing with Kshitijal Pavak, Gagan and Samira. Now, I am Rajiv Ranjan Sinha from the Damodar Valley Corporation. I am here with my co-author, Mr. Abhishek Kumar. So we are going to present you the case study about the new development in the field of NDT, non-destructive tests. First of all, as we are all in a power sector, we know it's a responsibility what that sector put us on us, that it should be reliable. We should ensure the availability of the power around the clock, and with that process, we should be in a position of earning, means we should earn some profit with that power plant. So as you can see from the last 1 decade, the per capita consumption has significantly increased. It has increased to approximately 30%, and all the generation has also increased to approximately 35%. You can see that from this graph that we all need that to quality power, and we have to ensure the availability of all the power plants. So here we can see that from all the installed capacity of India, approximately more than 50% of the total capacity is coal-based, and we are using that coal-based thermal power stations for the base load at least. And now, we are talking about the forced outage in a thermal power plant. So you can see from this graph that more than 50% of the forced outage came from the boiler section, and some 30% came from the TG section, and rest from the generator side. So we are mainly concerned about the boiler section. So here is the presentation regarding all the 500 megawatt boiler, all the working from the water cycle, water flow. You can see that how the water flows inside. It is the total cycle which we have presented here. And the most important thing in a boiler is its boiler tubes. These are the flows, and from there it goes to superheater, and after that it goes to the turbine. As per the CA report, for the year 2017 and 18, approximately 1,500 outage were there, and the nature were all the faults, approximately 800 faults were from water wall tube leakage, some 100 regarding superheater tube leakages. The equivalent was a reheater tube leakage, and some 180 times it was economizer tube leakage. After that, you can see the furnace trouble was very minimum. And then, after that, we again analyze the problem. So location-wise we analyzed, and we can conclude that and after that BTL analysis done by. So approximately 39% were happened in a superheater zone, approximately 28% happened in a water wall, and 11% happened in economizer, and other locations were contributable to 22%. And the defect where you can see the welding defect was approximately, it was the most important thing, it was around 39%. Erosion was responsible for 33%, overheating was responsible for 22%, and the rest was 6%. There were three methods. There were three issues like the creep. We can see the analogy of a 100-watt bulb, and through that analogy we can understand the process of creep failure. The first initial deformation is very rapid from initial point to A point. It is the initial deformation which can return back to A. And from A to B, which is primary creep region, it is for a very short duration. But from B to C, you can see that it is of linear type, and it takes lots of time. And from C to D, when it enters into the tertiary creep region, after that it goes to fracture point. And the second was scale deformation. We use water and the wall, the separator, like Tiwari Saab said, we have to separate the fire and the water. So we separate it through a wall, that is tube. And due to that separation and due to the heating of water, scale formation observed on the tubes, and through that heat transmission hampers, and the scale causes the fuel consumption to increase by approximately 18%. A stress will arise in the steel as a result of the insulating effect of the scale. And it is the picture, so the deformation happened due to the scaling. And after that, second is the lack of fusion. When we weld, we have seen that three types of weld defects, like lack of fusion at the root of the weld, like here. Second one is the lack of the side wall fusion, and the third one is the lack of interturn fusion. We see a lack of side wall fusion. It happens, it is responsible for mainly 50% of that defect. So now the question is how to prevent forced outage due to boiler problems. At present, we are doing some NDT techniques. The current practices are radiography, dye penetration test, and the third one is ultrasonic scan. But it has some drawbacks. Like in radiography, it contains a significant radiation health hazard for the workers, so for that we have to evacuate all the workers from that working area. And after completion of that radiography, we have to wait for 3 to 4 hours or sometimes 5 to 6 hours for the result. And the second one is ultrasonic inspection. It is also time consuming and requires tube cleaning of the bare metals. Only wall loss in tubes could be accessed. And the third one is dye penetration test. It also has some drawback and the time consuming because preparation before testing, it can be a very costly affair. It is necessary to pre-clean the material since contamination can make some defects, and only surface defects could be accessed. And after that, I request Mr. Abhishek to talk about the advanced NDT inspection of the boilers.
Good morning, sir. Coming to the next part, the advanced NDT techniques. Now, these are some of the advanced NDT techniques. The first one is phased array ultrasonic testing. Like some person from GE explained about the phased array ultrasonic technique, this has been employed in our boilers for testing the weld defects. Now, this is nothing but an array of ultrasonic scans what goes through the welds, and it's when the ultrasonic rays returns, it tells us about the weld defects. Now, this is a case study of our 500 megawatt boiler in which we have detected many weld defects which were one of the reasons of the catastrophic failure of the boilers, and we have decreased it significantly. Here, the lower portion, what can be seen here, that the defects are shown, and there is a root portion, and from which we can see what the defect type is. We can detect lack of fusion, lack of penetration, sidewall fusion from this. And currently we have done in our 500 megawatt boiler around 3,400 joints, and we have detected and also eliminated the cause of the future upcoming boiler tube leakages by detecting the weld defects in time. Now, the second one is the oxide scale measurement of the boiler. Now, the problem what we faced in our boilers is the high temperatures and the creep failure of the boilers. So for the superheated tubes, we did the oxide scale measurement. By the oxide scale measurement, we can know the remaining life of the tubes, means what is the remaining residual life remained. If it is within the limits, of the next overhauling or the upcoming repair of the boilers, then we leave it. Otherwise, if the remaining life is very low, by knowing the oxide scale, we replace it there, ultimately resulting in and saving the boiler tube leakages. Now, this is a sample calculation. Larsen-Miller equation is there. This is, we got around 450 microns of oxide scale, and from that, we calculated the remaining life. It is around 3.85 years, and we took steps by removing the bends of the tubes, and ultimately what we did is eliminating upcoming boiler tube failure. And this was the boilers, one of the case study of the oxide scale measurement, the reheater tubes. Some about 6 to 7 bends, we found its oxide scale more than 400 mm, and we replaced it at time during the overhauling of our boilers. The second is the baroscopic investigation. Now, this is a classic case study in our boiler. Once we had a reheated tube leakage, and the reheated tube leakage occurred again after 7 days. Now, the thing is that at the same place, we are having the same tube leakage, and the repair was going again and again. So, it was decided to go for baroscopic investigation, like cutting the nipple of the tubes, a boiler header, and inserting a camera to see whether any foreign material is there or not. And this practice is not only was done on that time, but also during the over of the boilers, checking all the headers for in case of any foreign materials, because if any foreign material is there, it will cause in the overheating of the tubes and ultimately resulting in the failure of the boilers. And if we don't know the exact cause, we cannot eliminate the future causes. So this videoscope, boroscope, this was the material found inside the boiler tubes. We eliminated another boiler tube leakages. Now, after this was the 3 techniques what we implemented this time. Now, after this, we also propose to implement more advanced NDT techniques. Now, the first one is remote field testing. This is a technique like what we do that during the boilers inspection. Also, in the second pass, we have to cut the headers and lift it. Now, with this, we can insert a tube by cutting one portion without lifting. Through the ultrasonic scan, we can also know the nature wall deposition of the tubes. We can also know about the erosion effects, the corrosion, internal corrosion by this remote field testing. This is also an UT testing of the boilers. The third one is the VRT scan. We all know that water wall tube leakages are a big challenge, and above the height of the boilers are a lot of matter, and to see the throughout of the water wall is a very big task for us. And to check that, we need a lot of scaffolding, and only UT is done. Means only thickness measurement is done. But this is an advanced NDT techniques, and this is being followed in many of the boilers, not in our country but outside. What we have got, the VRT scan machine can analyze the boiler tubes and can tell us about internal erosion, corrosion, and also in UT, what we get only the measurement of the thickness. Here we can get the robotic wall crawler can tell us the internal inspection of the boilers also can also be done. The second one, the last one is the drone inspection of the boiler. In the short time of the overhaul, we cannot erect a lot of scaffolding to see what the condition of the boiler is. But through these drones, in a short time of overhaul also, we can go inside the boiler to the roofs and see, at least externally inspect the tubes to plan by next shutdown what we can do. This gives us an exposure time for planning. The last one is what is the need of this? Mist cracks and defects and erosion leads to failure of tubes and ultimately result in boiler tube leakages. The use of NDT techniques like pot, oxide scale measurement and boroscope along with VRT scan and drones minimizes tube failures, and ultimately we will have reduction in boiler outages and reliable power. And with these efforts, we can tell for our 500 megawatt unit, we have reduced by God's grace boiler tube leakages, which was a big problem for us, to minimum this year. Thank you from our side. We have one video to show. Drone inspection, sir. DVC, PTPS, PPT, हाँ इसमें ड्रोन इंस्पेक्शन ये कोई Oh, this is a sample of plane नहीं होगा चल छोड़ दीजिए नहीं तो नहीं जा रहा उसमें वहाँ नहीं वहाँ प्ले नहीं हुआ अच्छा उसको प्रेजेंटेशन बंद करना पड़ेगा रुकिए ये ना हाँ अब चलेगा आया हाँ ये Here I have got a sample video of drone inspection, and this is a drone which inserts in the boiler through any of the openings. This we can see clearly what the tubes are. Means we can closely go to the tubes and inspect if any deposition is there, if any misalignment has happened, if any scale formation is there, shoots have deposited or not in a particular area, if shielding has damage. We can go to close to the burners. This is the water valve of the boiler. This is the drone inspection of the boilers, what is being carried out, a sample video for any of the close inspection. What we cannot do because we have to erect a lot of scaffolding, we can see it online by sitting outside the boiler, even in hot temperatures also. This is the inspection of the refractory of the boilers, what is the condition of the refractory, so that we can take timely action in the next shutdown of the overall. This is the inspection of the burners of the boiler. Thank you, sir. Thank you from our side.
Yeah, एक सेकंड.
Thank you, sir.
Sir. Want to speak?
Sir? Now I request Kaushal Kishore sir to summarize the whole session, and if any questions are there, they may hand over to Shri Faiz Ahmad. Sir.
It's a good afternoon all. All the 6 papers were very useful for everybody, I can say. For a specific reason, only rotor repair is not applicable to all. Wherever they are facing this type of problem, this is the one solution where we can save our time, where we can save our money also. So starting from paper 1, where this safety aspect was discussed, and this was the capturing that data's unsafe practices, unsafe acts, unsafe conditions, then number of incidences, then is analyzing those data, and what is the remedial measures, remedial actions has to be taken, that was discussed. So we all are very good in capturing data, and we limit ourselves to that one only. So analysis part we are missing. So everybody is requested to go for analysis and find out the solution of those things. So that was the discussed here. If we see that paper 2, NTPC cooling tower Vindhyachal stage 4 cooling tower performance improvement, it's there is a question in for this session, in how many stations this modification in cooling towers has been done. In fact, this is a regular practice. This is directly, this cooling tower performance is directly related to our condenser vacuum. And if you are not able to maintain with designed CW flow and designed number of CT fan operation, then we have to go for this type of checks and analysis, and it's a regular one. So we should not limit to either Vindhyachal, it is applicable to everybody. And when we go for the third paper, which is Jindal, then this optimization of oil consumption, that's a very big challenge. Means you have to reduce your force outage, and you have to reduce your startup and synchronization time whenever there is outage, planned outage or force outage. So basically we should reduce the force outage where that oil consumption, majority of oil consumption goes. So that is the many points they have discussed. We can go through those points, and then AFBC boiler, of course, Durgapur is in a stabilizing period. They have not come up to the full load on continuous basis. Coal may be the reason, and I can say there may be some other associated reason also. We should not see only the coal. Then a rotor repair, of course, Vilai is having a problem. They have taken out one LP rotor where there is a crack, and they are consulting BHEL and maybe GE for this repair of that crack portion. And last, this paper 6, where this NDT method application for prevention of boiler tube failure. Of course, RFT, of course, VRT scan we are already doing. That is the corrosion mapping. It's more or less it's a corrosion mapping. Of course, it has started around 10-12 years back only. It was the manual. Now it has come to robotic to do it very fast. Then drone for boiler inspection, of course, I don't know how many stations are doing, but this is also a good thing. So all the papers were very good, and all the presenters were in time, more or less. So I thank all the presenters. There are some questions. First question is there from Ritesh Agarwal. This is the same. In how many stations this modification in cooling towers shall have been performed? I think I have already addressed it, and if you want to add something, please, Agarwal ji, please add.
Should I come this?
Yeah. बोलिए.
Sir, actually this problem we are facing in numerous stations, sir, and modification, this actually cost benefit analysis we also carried out. Like some of the modifications do not involve so much cost. Like if we are going for modified nozzles, we are completely changing the nozzles, so it's a cost intensive is there. So we study that मतलब अभी किस तरह का फिल का डिस्ट्रीब्यूशन है, अभी पानी का डिस्ट्रीब्यूशन किस तरह का है, उसमें क्या ज़्यादा अगर ब्लाइंड एरिया बन रहा है तो हम मॉडिफाइड नोजल जा रहे हैं. सीपत वगैरह में हमने इस तरह का मॉडिफिकेशन किया, विंध्याचल में भी किया है. और ये जो बाकी के सर जो चीज़ें हैं, जैसे कि ब्लेड एंगल का एडजस्टमेंट है, इट डजेंट रिक्वायर मच इन्वेस्टमेंट, इट इज़ ए कंटिन्यूस जर्नी. मीन्स इसमें जैसे कि सर ये है कि समर और विंटर में एयर का डेंसिटी भी चेंज होता है, प्लस क्या है ड्यू टू प्रोलॉन्ग यूज़ या ब्लेड टिप का क्लियरेंस चेंज हो गया या ब्लेड में कुछ एल्गी और ये ऐश वगैरह डिपॉजिट हुआ, उसके चलते भी जो एयर फ्लो हैंडलिंग चेंज हो रहा है. तो ब्लेड एंगल का एडजस्टमेंट इज़ अगेन अ कंटिन्यूस प्रोसेस एंड इट इज़ नॉट वेरी कॉस्ट इंटेंसिव. And second thing is water flow balancing. It is also not cost intensive. So some of the modifications or activities which are not cost that much cost demanding, so we are doing on continuous basis in most of our plants. But certain modification like changing to wide spread angle nozzle, it is a cost intensive. So we do a cost benefit study also, and where there is a major shortfall, we are going for changing, like in the Achal, the stage 4, all the 3 towers we are changing. Sipat also we are going for. So, and we have got improvement of around 1 degree, sir.
One more question, Agarwal ji. Reorientation of drift eliminators in CT. A question is from Tapan Nandi. And what do you want to ask?
सर इसमें क्या था सर, हमारे यहाँ क्योंकि 19 कूलिंग टावर्स हैं विंध्याचल में. आई वॉज वर्किंग एट विंध्याचल प्रायर टू वर्किंग एट सैनपीप रायपुर. सो इसमें क्या था सर, 19 कूलिंग टावर्स हैं. तो स्टेज हमने अपना इंटरनली स्टडी किया, जो ड्रिफ्ट एलिमिनेटर रहता है फिल्स के ऊपर में रखा रहता है सर, उसका जो मतलब एयर क्या है ना, उसको ग्लाइड करते हुए निकलती है. तो जो एयर को मिनिमम रेजिस्टेंस मिलना चाहिए, तो हमने अपने सारे कूलिंग टावर्स को स्टडी किया कि किस तरह का ओरिएंटेशन है ड्रिफ्ट एलिमिनेटर्स का बाकी स्टेजेस में. स्टेज 5 जो हमारा सबसे अच्छा परफॉर्म कर रहा था, उसके ड्रिफ्ट एलिमिनेटर्स को हमने स्टडी किया. क्या उस ओरिएंटेशन को अगर हम अपने यहाँ स्टेज 4 में मतलब इफ़ यू ट्राई टू कॉपी टू द एक्सटेंट पॉसिबल, तो उसमें हमने पाया कि ड्रिफ्ट एलिमिनेटर को चेंज करने से एयर फ्लो को जो रेजिस्टेंस है वो थोड़ा मिनिमाइज हुआ और उससे वेलोसिटी इंप्रूवमेंट हमको मिला है. ठीक है सर, ये एक हमारा अपना इन हाउस था, चूँकि इतने ज़्यादा कूलिंग टावर थे तो ऊपर से हमने स्टडी करके उसको देखा. और इसमें सर क्या है कि मेन पर्पज ऑफ ड्रिफ्ट एलिमिनेटर इज़ टू स्टॉप द मॉइस्चर ड्रॉपलेट्स गोइंग टू द एटमॉस्फेयर. बट साइड बाय साइड उसमें क्या होता है, कभी कभी ड्रिफ्ट एलिमिनेटर में एक तो बहुत सारा कचरा वगैरह जमा हो जाता है, उससे भी रेजिस्टेंस बढ़ता है. या फिर अगर उसका ओरिएंटेशन ऐसा होना चाहिए कि जो हवा है वो जस्ट ग्लाइड करते हुए निकले, मतलब अगर कोई पार्टीशन वॉल को हिट कर रही है या इस टाइप का चीज़ हो रहा है, तो उससे भी आपका जो है मतलब वो अल्टीमेटली L/G रेशियो को इफेक्ट करेगा सर आपके. तो ये चीज़ एक था सर.
Next is one from pot DVC group. Pot application is possible in every type of boiler, every zone. There is a limitation in pot. It is a thickness, whether it is a 180-degree pot or 360-degree pot. I hope so. This is your question. What is the limitation?
Actually, what I have seen in the Cobra scanner is there in the pot machine. The Cobra scanner consists of a lot of phased particles. It is possible if there is a space 180 degree, means about 360 degree, the probe can travel. Okay, but if there is no access, then still we can take out the probes from the scanner and we can do, but it will be time consuming. We can do by location wise 1 or 2 points. I have seen that, done that also, and that 360 degree, if there is clearance also, then it is okay. That has been done at our power station, but we have to take the scanner out, means the particles of the scanner out, and we have to do that, means point by point we have to do. That is also possible.
What is the thickness limitation?
Thickness limitations are in the boiler, every tubes can be done. Perhaps in the most thin tube is economizer. The economizer was done.
Are you sure?
Yeah, sir. we cannot, but only the scanner needs to be changed, what I know. And the test probe, the setting is done on a test probe.
Okay. Then there a question is there from Jindal Power. They have done optimized that startup time. So with these all optimization, number of boiler tubes leakage after this strategy. He is asking whether the boiler tube leakage has increased or it has no effect on boiler tube leakage.
Sir, as far as the BTL concern, regarding this startup with of boiler, we don't have the much outcome about the this oil consumption reduction till now.
Then another is that turbine TSC margin. When we go fast, where TSC margin after synchronization, how much time from synchronization to full load? Has it increased from synchronization to full load?
No, actually regarding TSC margin, we are taking up the things very well, and we are always try to put it in within the range. No deviation was there as far concern of the TSC margin.
Then there is a question written with pencil, how to make a decouple to get engaged, especially to workers who does not understand the technical terminology. Name is not written. Maybe I request the gentleman, please, can you repeat your question?
Sir, I have given that question. It is from the first presentation who have given for the safety.
Yeah.
I want to know that the technical terminology the workers actually does not going to understand. So how to implement in the field? Because we have seen the many terminologies in the presentation.
Okay. So actually, worker can fill the form in their own language. So if they are like we are using in ExxonMobil, so the observation form they fill is in Spanish. So we convert that Spanish language, handwritten language, into the English, digital English words, and from there we take the output. The second thing what we do is voice to text. So there is a bot who will speak in your language and will ask if there is any observation or any unsafe act is going on. So you can reply in your native language in Hindi, and it will record that observation and bring it to the system for analytics. So language is not a barrier. In whichever language the user is, we can convert into.
Sorry, sir, my question is not about the language. How to get them involved? That is the matter.
Okay. Okay. So there is a field level hazard assessment. Whenever a team who is going to perform any job in the field. So for example, in the morning my team has to do the job. So they need to fill a form that is called field level hazard assessment. So that is a set defined of form for every type of job. There is what is the hazard, what is the control mitigation, it is all pre-filled. He has to check all those things, upload the site pictures, the tools or safety PPs, what is doing. And then there is a safety pledge, location, everything, geolocation is being mapped. So that field level hazard assessment has to be engaged with the workers. The second thing is the observation. Observation, any user or any workers in the field, they can observe that some unsafe act or condition is happened. So they can report it through their mobile app or through forms and all. So that is where we involve the workers or low-level peoples.
There is a last question from G. After the rotor repair is done, there is the analysis of rotor condition in running machine of any plant. Was it done?
Sir, this question is also from my side.
Yes, that is from your side, and it is from G. Sorry, for G.
Yeah, so we did it. If you want more details, we can have a discussion separately, right? So we repaired the rotor. There was a concern from the customer that whether it will work. So they wanted a mandatory inspection after 2 years of operation. So in fact, that inspection was done after 3 years, right? And after even 5 years, everything was found intact.
Okay, thank you. These were the all questions from participant. Anybody is having further any clarification during lunch time? They can talk, they can discuss. Thank you all. Okay.
Yes. Just a minute, sir. Yes. Thank you, sir. Now I will request Kaushal Kishore sir to kindly facilitate the paper presenters by presenting them shawl. I will call Shri Anup Ratan Mehti sir and Shri Priyanshu Upadhyay sir. Shri Ritesh Agrawal. Next, Shri Amit Kumar Pandey, Shri Ravi Satyapal, and Shri Sandeep Patel. Next, Shri Madhusudan Kulkarni and Shri Amit Agrawal. Next, Shri Rajiv Ranjan Sinha and Shri Abhishek Kumar. श्री अरुण तिवारी. नहीं मिस हो गया सर. So now I request CEO sir to felicitate Shri Kaushal Kishore sir. With this,
we will disperse. We are late by how much time? We are late by 1 hour 10 minutes. Okay, so there has to be some shrinkage. So let us try lunchtime to shrink as far as possible. Okay, it's 2:15. We will meet around 2:50. 2:50. Okay. ठीक है सर. दीजिए भाई, थोड़ा तो मेरे हाथ में भी रहना है सर, आपके हाथ में दे देना।
Good afternoon, everyone. First of all, our presentation was just before lunch, and I was very much tenser about that. But now I am more tensed after lunch. So, as Mohit Agadi said, environment is no one's property to destroy. It is everyone's responsibility to protect. With this quote, I, MS Karthik, DGM Operation, along with my colleague K. Srinivas, Senior Manager, Boiler Maintenance, we welcome you all to our topic, DNOx modification and NSPCL Bhilai's experience. As per the prevailing environmental norms, it is mandatory that we have to limit our NOx emissions below 450 milligrams per normal meter cube for all the units which were commissioned between 2004 and 2016. So before diving into the topic, let us actually know what NOx emissions are. NOx emissions basically comprise of mainly three components. The first one being nitric oxide, nitrogen dioxide, and nitrous oxide, out of which nitric oxide is the major contributor, amounting up to 90 to 95%. And there are many factors which actually influence NOx emissions, out of which the flame temperature, where actually combustion is taking place, the second one being amount of nitrogen in the fuel, the third one being the excess air which is given for combustion, and the fourth one is combustion, the actual temperature of combustion air. There are many available technologies to reduce NOx emissions, out of which they can be categorized mainly into two methods. The first one being the combustion control method, in which we actually vary some parameters in the combustion process itself. The second method is the post-combustion method. The complete combustion is taking place. Thereafter, we are injecting some chemicals or using some catalyst to actually reduce the NOx emissions. Now, my colleague will actually explain you what we have done at NSPCL Bhilai in order to reduce the NOx emissions. Over to Srinivas.
Thank you, sir. Here at NSPCL Bhilai, we implemented SOFA DNOx system. In this particular SOFA DNOx system, we are creating a reductive DNOx zone inside the boiler. This mechanism of consumption consists of the following steps: incomplete consumption of fuel to generate hydrocarbons with less air condition at main burner combustion zone, NOx reduction chemical reaction at reducing atmosphere at reductive DNOx zone, and finally the combustion completion at complete combustion zone with additional air. At NSPCL Bhilai, installation of SOFA dampers as separate compartment above upper and lower overfire air damper was carried out. SOFA duct tapped from the existing secondary air to wind box portion, and installation of new oil coal burners as well as oil burners were installed, and each SOFA has got 4 number of air nozzles. Pneumatic operation for SOFA dampers and manual tilting arrangement was also provided for the upper air nozzle. Local marking of damper position from 0 to 100% as well as plus or minus 30 degrees tilt position was also provided. This is the typical layout of SOFA DNOx system. Here in this particular layout, you can see that the total duct has been classified into 2 numbers. One is the advanced lift-up ducting, which is represented in the pink color, and the other is the duct lift-up during the shutdown period. At NSPCL Bhilai, on the left-hand side of the boiler, the complete 100% ducting was lifted prior to the shutdown itself. Coming to the right side, the advanced lift-up ducting was carried out as per schedule, and the remaining portion was carried out during the shutdown period, as there was a fouling constraint of seal air fan ducting with the SOFA structure, support structure. These are the SOFA guaranteed parameters. The first one is 40 to 100% TMCR load with 20% excess air. The total NOx at the ID fan outlet shall not exceed 400 mg per nm cube at 6% oxygen content in the flue gas on dry gas basis. And second one is the unburned carbon variation shall be limited to only 0.08%. And the third one is the superheater and reheater spray shall not be more than 10 tons per hour and 5 tons per hour respectively before and after the modification. Our SOFA NOx combustion modification in Lot 2, NTPC awarded for so many units such as Bangaigaon, Unchar Thermal Power Plant, Kanti, Nabinagar, and NSPCL Bhilai, and the final one is NSPCL Rourkela. In these units, the first Bangaigaon unit modification was taken place. In the first unit, actual execution was very much delayed as the pre-shutdown lifting clearance was not given. In the rest of the units, it is more or less as per schedule, just like Nabinagar. The overall shutdown period was for 45 days, whereas in case of Bhilai, it was only 35 days. In Unit 1, there was a delay of 3 days in NSPCL Bhilai. In case of Unit 2 actual execution, it was well before the L2 schedule. That is, we completed the work within 31 days itself. And this is best among various NTPC stations. These are the activity milestones. You can see that Unit 1 has got 38 days and in Unit 2 it is only 31 days against the schedule period of 35 days. So we will be discussing what are all the factors that has led a 3 days delay in case of Unit 1 and what necessary learnings and necessary corrective actions lead us to complete the total work within a period of 31 days in case of Unit 2. There are 3 main issues during Unit 1 DeNOx modification system. The first one is the coal burner tip issue. As per conventional method, the coal burners pre-assembly was carried out, the tilt checking was done and ensured plus or minus 30 degrees and all the coal burners were fitted into the boiler, they were positioned. When we were checking the actual tilt through the tilt mechanism, it was observed that the boiler coal burner tips were fouling with the boiler side panel tubes. Actually, the side panel tubes were covered with the shields, so the clearances got very much minimized and these were fouling. In order to overcome this particular issue, all the 28 coal burners were dismantled, they were grinded 5 to 6 mm and they were reassembled. This was one of the main reasons which led us for the 3 days delay. And the second one is coal bin was dislodged from the burner isolation gate due to poor workmanship. And the third one is the insulation work started only after the completion of the duct erection and the work was carried out for a longer duration even of the unit synchronization. From these learnings, following things have been maintained such as mobilization of skilled manpower along with TNP prior to the shutdown itself, completion of pre-shutdown, duct fabrication and lifting before commencement of overhauling, coal nozzle tips were grinded prior to the shutdown itself, and in case of Unit 2, we ensured that during pre-assembly that the tilt mechanism was plus or minus 32. We have taken additional 2 degree tilt, we ensured it, and after this, we placed each only 4 number of coal burner nozzles in the boiler. We ensured the tilt mechanism was free. Later after, we have installed remaining all the coal burners. And we also ensured that the skilled manpower for the coal pipe work and ensuring the quality of the work. And insulation work was carried out in parallel to the duct erection work. Apart from these various zones are also emphasized, such as listing of critical work zones and manpower, TNP mobilization for the shutdown work, listing of critical pre-shutdown, post-shutdown and shutdown period works, and identification of falling constraints in the unit and relocating or rerouting wherever possible. Small things such as cable rerouting, instrument tower or service airline rerouting, building receptacle relocation, whichever was possible were carried out in the pre-shutdown period itself. Setting of daily targets for each critical activity and assessments of roadblocks and timely corrective action for achieving the targets, and it was done on daily basis. And coordinating with the other agencies for timely completion of the hydro test, ADT and light up activities. And we all believe in safety first is safety always. We emphasized on creating awareness in the workers by safety talked out to the workers on daily basis at the work premises itself, safety awareness by displaying the posters at the working site, and creating a safe workplace by providing the platforms and hard barricading. And these are the few pics where I can show
small fouling constraints were identified, they were noted, and corrective actions were taken before the shutdown itself. In this picture, you can see that the burner has corner panel has been cut down for the placing of the sofa panel. In the second pic, the sofa panel has been positioned, and whereas in the third pic, it is the sofa panel after completion of the welding work. I will share few more overhauling work specs. You can see that the duct lifting is in progress, and it is after the completion of the cladding work. The operational aspects shall be discussed by Karthik sir. Thank you.
Thank you. If timely erection of DINOX modification is one aspect, then the other aspect is proper commissioning and operation of DINOX system. The reason because is this particular any boiler is designed for a particular range of coal for particular parameters only. But nowadays the new environmental or the present CRC guidelines are mandating 1% ramp, 2% ramp, and now they are going for 3% ramp also. And with this fast loading and unloading of units, it is very much useful, and it is very much mandatory that the flame of the boiler should be very much stable. So that's why when we came to know that DINOX modification is to be taken place at our unit, we first of all inquired that in which units the same vendor has implemented DINOX modification. And we gathered data from those stations, and we found that in one of the stations prior to DINOX modification, the minimum airflow set point was kept at 550 tons per hour. Actually, the full load air is somewhere around 800 to 850 tons per hour, but they were keeping at 550 tons per hour at technical minimum. Then and they were getting a windbox DP of 55 to 60 mm of water column with a minimal SADC opening. Then they went for DINOX modification, and later on they found that at the same airflow the flame was very much unstable, and finally they incurred 3 flame failure trippings of their unit. Now just imagine the total package of DINOX modification is around 12 crores, and nowadays each and every tripping will cost around 60 lakhs. So if I incurred 3 flame failure trippings, then 10 to 15% of the cost is wasted. So, and this was in another unit where post DINOX modification, the variation in superheater and reheater temperatures were very much high. So based on this data, an action plan was adopted at NSPCL Bhilai that windbox DP and SADC opening would be the guiding factors post DINOX modification. And moreover, the commissioning procedure will decide how effectively DINOX modification will be going on. That's why we decided that we will thoroughly check the sofa dampers and sofa tilt, just because in other units where DINOX was implemented, they were not getting sufficient windbox DP. And the third thing is that during fan trail post overhauling, we would be taking data at simulating actual airflows with all the fans in service. Now, as far as commissioning procedure is concerned, this was the observations which were observed during our commissioning procedure. There was huge gap between sofa damper flaps, which will actually lead to less windbox DP. This was later rectified by us by proper observation, and there were very minimal gaps between the flaps. Similarly, this was the tilt problem, that upper nozzle was stuck up at higher plus 30 degrees only, which was later on rectified by us. This was the data which was gathered by us during fan trial, and as we can see that at a full load airflow of 800 tons, we were comfortably getting 175 mm of water column wind DP with approximately 48% auxiliary damper opening. And similarly, we took the data at technical minimum also at various combinations with 4 mils in service, 3 mils in service. So we were very much assured that we will not be incurring any tripping. And after synchronization, initially we kept sofa damper at 0% opening, and later on we slowly increased that to 50% at full load. Now, I can proudly say that with DINOX modification, we are achieving approximately 1 to 2% ramp, and the flame is very much stable, and we are getting windbox DP also, and we are fastly loading our units and fastly reducing the loads also. This is the actual screen of sofa master command, which we have implemented at NSPCL Bhilai, and the final readings post DINOX modification was before Linux modification, we were maintaining around 550 mg per normal meter cube and 535. That got reduced to 220 and 240. So that's all from NSPCL Bhilai. Thank you.
Oh, one parameter I think important here also, that
Yes,
is reheat metal temperature. There is reduction in reheat metal temperature after denox. This part whether you have checked?
Yes, sir. Sir, one thing is that reheater temperatures are maintaining low just because that sofa tilt, if we maintain around 0 degrees, then we were experiencing that problem. That's why the sofa tilt, right now we are keeping it at minus 30 degrees. With minus 30 degrees, we are able to get rated temperature, sir.
I'm not talking about this reheat steam temperature, reheat metal temperature.
That also we are not exceeding, sir.
There actually some reduction is there after
Yes, sir.
incorporation
Metal
of
temperature is also
denox.
reduced. Yes, sir.
Thank you, Karthik sir and Konga. Our next presentation is from Jindal Power team, which we have seen in the first session. Shri Amit Pandey and Shri Sandeep Patel. They will present on the topic biomass pellet utilization, which is very relevant topic as on today, and a paradigm shift. So I request Shri Amit Pandey and Shri Sandeep Patel to come and present their paper. चलो दिखाओ एक मिनट से
Good afternoon. Thank you once again, NSPCL, for giving me the platform to share the latest burning issue, I can say, in power plant, especially in thermal sector. Those who are acquainted with the subject biomass pellet utilization is the speaking story of utilization. But truly the fact is that compliance is there to follow, but again, beyond the compliance we have to think to really make it successful. It's not about the utilization, but it's all about the enhancing the capacity what we have untapped yet. So this is a subject I am very proudful to tell you that I am dealing with it since last 1 year. And before that I was not knowing much about the things, but yes, now after a year of experience I can say I have gone through from the word this pellet, how it is and what it is, and in biomass how this pellet is actually connected, because earlier when we used to talk about the biomass, the natural thing is the biomass gas, something like that, but this is totally different. It is not that, but it is the thing. Biomass, it is the residual agriculture waste which is not in use, and that created a havoc condition in the NCR region. If you was about the parali, this word you are I think hearing last in 4 or 5 years many times in the news channels. So this is the thing which is going to cope up the thing of parali. What is the ill effect of parali burning? That we call it stubble. So this is the subject going to deal with that. Fortunately, government is very keen to take this subject in all over region of the country, but nowadays the severity of the problem is very high in the NCR region, definitely. So government is taking too much of the provisioning there. But apart from that, other regions are not unaffected. The thing was also spread there. Farmers started the burning of the stubble left after the crop harvesting, and that is the main cause again going to pollute the air. So this is our sort of the effort going to deal about the how we have did the trial of the co-firing in our plant and getting the experience from the co-firing, and now we have shifted to the pellet production. So we have taken the step, and I am glad to state you this. The Jindal Power is first in the country thermal power producer who is going to furnish you the production of the pellet first. I am firmly believe. Unfortunately, due to the circumstances, we are unable to produce yet. But it was the period was in the January last we have to produce the pellet, right? So we have taken the initiative to set up the plant of 4 TPH, that is 96 TPD in all capacity. So the presentation going to deal about the overview of the company. I have already stated you about the biomass pellet, how it is and what it is, handling storage for the co-firing, modification what we have done. If anybody gone through the model SOPs, some of the pointers there. Next, the test firing of 5% blend of the pellet, and thereafter the shifting from the pellet procurement to production, and thereafter the challenges and perspective what we are having in this thing, and the last is the conclusion. So again, starting from the overview, I have already stated you we are the first IPP 4 into 250 megawatt, the first IPP in the country, and I can say you in 2007 it was the turnaround for the power sector, especially for the private producer. We have shown the path how we can succeed in this. Thereafter, in the phase 2, we have added 4 into 600 megawatt, again BHL unit, making it 3400 megawatt. Again, we are the 5th largest IPP in the country at the single location. So, not taking too much time. So, why biomass pellet need? So, I have already stated you, this is all about the residual agriculture waste, what we are going to utilize, which is yet now not utilized in that much manner. And mainly basically farmers are taking the method for the polluting the environment. Rather, that is not good. So that is the case of the stubble burning, as you will aware the things. And then a potential is huge. You can see the data, the potential is huge. And now this potential is come with the reduction of your usage of the coal, which in turn reduce the emission of the CO2 definitely, and it will be going to be beneficial for us to depend on reliable only not on the coal, but this is also part we can see, right? And so what is this pelletization? So pelletization is simply densification of the loose material. You know, if you see the stubble or you can say the paddy straw, this is very loose in the nature. So it is very difficult to transport it. So because it is the density, it is not densified, so it is for transporting take too much of the spaces, volume, and cost is very much embedded in this. So for this purpose, for reducing the density of this one, we require this densification of the things. So after the pelletization, the density is coming around 650 kg per meter cube, you can say. The co-firing again with our conventional fuel as a coal, we are using 5% of the blend of this pellet for the trial purpose, because you know the effect of this residual agriculture waste is very aspect of the clinkering, falling, slagging, etc., which is important because these are having the other constants of the alkali, alumina, which is mostly responsible for the slagging and falling. Is another subject which nowadays we are with the subbituminous coal itself we are facing the problem, and by adding this blend, definitely it is going to create one huge challenge for us. So I'm going to share you our experience, how we have did this. So prior to doing the coal firing, this blend firing, we have did some preparedness as the guideline provided by the MOP and the Mission Directorate, Samarth. So in that it is very clear that what sort of the things have to done. This what did in the plant NTPC Dadri. They have demonstrated this one, and by help of that effort we have continued. So this is all about the handling and storage of the pellet, because the biomass pellet what we are actually handling is the one of the crucial parameter is of that it having the VM content of very high. It is 66%, 60 above percent of the VM. Normally coal having the what coal used to have we have firing is the range of 20 to 28%. Right. So this is a big challenge. We cannot use same method of milling and pulverizer for this stubble. This is altogether different thing. And apart from that, blending with the coal, it doesn't mean it won't going to affect you. Definitely it will, because the VM is very high. So we have to take care of its nature. It might caught fire inside the mill. It might caught fire inside your coal pipe and in between, which is very dangerous to any of the equipment and the plant. So these are some sort of the handling and storage thing we have arranged. Now we have blended with the 500 ton of coal with 5% of the this pellet, that is the 25 ton approximately it will, and we have keep in the blended place in the coal yard so that it should not be blended with the other coal. Right. We make this a sort of the arrangement. With the help of this we have start using the coal firing. So prior to the coal firing, the important thing is that we have to make it through the mill. The mill which is earlier handling the coal only, which is having the inlet temperature of 270 to 280, 90 degrees Celsius. Again, with this say pellet, it is very difficult to handle because it is having the volatility above 200 degrees Celsius temperature. So we have to restrain it so that it should not volatile. So we have to restrain about the temperature. So these are some of the modifications we have did as per the MOP guideline for just checking how it is actually working. So we have provided the protection so that in case of any of the temperature abstract range, it will be automatically cut off the fuel, it will cut out the mill, so that it won't go into parameter beyond which is not acceptable. Right. The one more important point is that mill inerting system. Already all providers are having this system, but normally in the coal usage we don't require this system. Very rarely. I was in my 16 years of experience of my career, never encountered this such of the problem. But it doesn't mean that it will not come. It might be. So we have to have prepared. So we have made ready this mill inerting system in line, and thereafter we start the co-firing. The co-firing experience is very, I think from my experience, it is very well. No such abrupt change we have found in the parameters apart from the increase in flue gas temperature for some extent. But that also not lead to the extent of the falling and slagging. Never. For 5% blend, I am confident no such as issue we have encountered. We have taken all the initiatives to overcome it from that, but fortunately we did not. And I am with the result I can say, assure you that we can go even in fact 10%, which is our next target, and thereafter 15%, and we'll see as per the result and the outcome going to be lead forward. Right. So this is all about the temperature what actually we are having in the different zone. You can see here. So no other significant changes there in the other parameters. Right. As far as the energy efficiency is concerned, yes. One point is there where we have limited our milling capacity, because the mill capacity we should not go beyond the temperature what we have seen there. So it restricts the milling performance to the extent of 60%. We cannot go beyond that. Else the temperature what we are getting is not going to get there. Right. So this is the one thing where we have to look after, how we are going to mitigate. So we have tried with the one bunker of the blending of the this pellet. We can go for the individual bunker, for the separate bunker, for the separate thing of all thing, sort of the thing we can do. And we can even increase the temperature as per our experience. This is what we have did as per the guideline. We have not taken further trial thereafter. Right. So this was the thing what we have. So this was the thing which we have actually encouraged by to do further. So while doing the things of the pellet procurement, I came to notice that this procurement is very tedious. And the cost, if I'm saying, again, a big challenge to deal with. If I'm telling you the cost of this pellet per ton, and if we compare to the mega cal, it is very high, in the range of the 2 rupees per mega cal to the extent of the 4 rupees, which is very, in comparison with the coal what we are actually firing, is very high. It's just, you can say, 4 times or 5 times. But again, costly affair to do. So much of the private player, and in fact the other power producer, seeing the cost sum game, they are reluctant to use this thing, because nobody used to have escalation of the price and sort of the production cost, right? So what is the main thought which pushes us to do this? The only thought process is that the densification process. Another is the transportation process. You know, this transportation cost is itself very high. If I am breaking this to a smaller content, you can say the conversion cost is about, say, 30%. But the material cost is about, say, 20%. Then I can say 50% is the transportation cost. Huge cost is there. So just imagine if you are procuring the things from 50 kilometers, from 100 kilometers, this is going to give the burden of additional cost to you. The higher the distance of the traveling of that pallet, it will going to add transportation cost to your pallet, landed cost. So this is the thing where we have to look after. Now, second thing is there is the electricity. You are well aware that the electricity cost is nowadays is too high for say the end users. So again, pellet plant also need electricity. Whoever so is producing the pellet plant is having the much cost of this electricity. I'm saying it a type of burden for them, and which usually not actually motivating others to come into this business. So being a power producer, we are having our own electricity, and we are having the area nearby the villages where we can procure this raw material. So we have added benefit of transportation, electricity. Now the conversion cost, again having the bigger the portion is of the electricity, and rest of the thing is there only. So the thing is that we can reduce it down to 2 to 4 mega cal to, I can say, 1 to 1.2 rupees per mega cal. Just you can slash down half to the price. Just. So for that we have taken the initiative. We have already ordered 4 TPS power plant, which I think within 2 months we are going to complete that project. Unfortunately, it was delayed by 2 months. Earlier it should have to complete it by the end of the January. Then I can be much better to show the things what we have actually, how we are doing the things. But here it's all about the thinking process. Is from we should not bother about this only procurement, but we should go ahead for the production, which is more beneficial. And you know, as far as you can see the data, what sort of a requirement we are having. Very difficult to get this challenge. Very difficult. We don't have the raw material itself. And being a single entity of 3400 megawatt, we don't have. Then what about the others? How they? Policy is there. We have to ready for the compliance. But where is the raw material? From where it come? And even if you are procuring for the market, you are not going to get the enough supplier. You are going to supplier of 20 ton per day, 50 ton per day, not more than that. So for this requirement of 2800 ton, how to mitigate this? We are the power producer. We are not the pellet producer. But for some extent, we have to do this business to encourage others to have the hand-on experience how this actually happens. So by this little effort, we can certainly say that we can minimize this gap of supply and what is actually we require, right? So these are the basically positive outcome if we are going to shift from the procurement to production. These are the outcome what we are going to reap from the this project, right? So things are there. We have to look forward the things again. The sustainability of this mission is only there once the power producer have to think about the pellet production. That's my takeaway and experience in last 1 year. Because saying and telling that we have to do this and that, and by doing that and that, it won't work much more. We have to take one step forward ahead of the thing what actually now in the market, and thereby doing this little effort, we can complete this one. So this all about the things is there. Thank you. Thank you. Sorry, yes.
Thank you, sir, for sharing your experiences towards biomass pellet utilization. Next paper is from BPSCL, Bokaro Power Supply Company Limited. The paper will be presented by Shri P.K. Gupta and Shri Vikas Kumar. Shri P.K. Gupta is at present DGM boiler operation, and Shri Vikas Kumar presently working as manager in boiler maintenance department. The topic is O&M challenges in modification of BF gas firing system, unit number 9 of BPSCL. Sir.
बढ़ाने कौन सा बढ़ाने का ये ना ठीक ओके ओके
Good afternoon to all. Respected judge of this session, dignitaries, participants. First of all, I welcome on behalf of my organization BPSCL, that is Bokaro Power Supply Company Limited. Let me introduce myself. I am P.K. Gupta, looking the boiler operation. I have come with my colleague Mr. Vikas Kumar, who is looking the boiler maintenance. Today our topic is O&M challenges in modification of the BF gas firing system in Unit 9 of our plant. Let me say about brief of my plant. BPSCL is joint venture between the SAIL and DBC. Both have the 50% equity holding. The main objective of our plant to supply the process system and the power to the Bokaro steel plant. We supply the power as per annual target, and the rest power is imported by the DBC. We supply the process system as per different pressure and temperature as per their requirement. We supply at 100 ATA and 540 degrees centigrade to run their turbo blowers, and 39 ATA is 440 degrees centigrade to run their turbo compressor, and also the coke oven byproduct plant, and 8 to 12 ATA process system at 240 degrees centigrade to run their process system as SMS, hot strip mill, etc. We also meet the demand of the category 1 load of the BSL, that is the oxygen plant, blast furnace, water management, coke oven. We also supply the sodium carbonate water to the BSL. We supply the 300 ton per hour to the RMP and the SMS 1 and 2 of BSL. We have an aggregate installed capacity to generate 338 megawatt of power and 2180 ton of steam. We have also some other initiatives regarding the solar power generation. We have installed the 100 kilowatt peak at our plant premises and also the 2 megawatt piece in the different location on the non-residential buildings. And regarding the ash utilization, we have owned our brick manufacturing plant. We are also supplying the cement to the different industry. As recently we are giving to the Dalmia. And we are also using the ash in the high-wage, low-lying area quarry to fill the quarries. Regarding CSR activity, we have done a lot of work in this one. We have done a MOU with the Pramal Swast and we are sending the medical mobile van to the neighboring villages to provide them medical aid. We also help to the student of the Asalata Biklang in Bokaro. And regarding the best safety practice, our daily morning meeting starts with the safety talk. Our ORT, MPC always discuss the safety issues. We do the training program, skit, Roko Toko, lockout, and recently we have celebrated the road safety awareness program. Regarding our capacity of the boiler, sir, we have categorized our plant in the 3 category, TPP, CPP and Unit 9. Regarding TPP, we have the 5 boiler, each of the 220 ton per hour, all have crossed the 45 years. And we use the coal, blast furnace and coke oven gas. All are the Russian make. Now the boiler 1 is not in service since 2016. In CPP, we have the 3 boilers, all have the 260 ton per hour. And they have also crossed approximately 35 years. Here we use the coal, all have the Polish boilers. And Unit 9 we have the 1 boiler that is 8 years old, having the capacity of the 300 ton TPH. We have the coal fire boiler, but we have also have the facility to take the BF gas. Regarding the capacity of the turbine, TP has the 3 turbine, 2 have the condensing type turbine, having the 55 megawatt capacity, and 1 is the 12 megawatt back pressure turbine capacity. In CPP we have the 3 turbines, all have the 60 megawatt capacity, all are the condensing type. In boiler 9 we have the 1 turbine, 36 back pressure turbine. So we are facing the ORM challenge. There is a mild explosion occurred on the 9th September 2021. Here some gas pipeline leading to burner 2 got burst. Few compensator damage and support hangers of the gas line damage, or somewhere the damper also the control damper is partially damaged. So we accept the challenges and modify the firing system so that such incident will not occur in the future. Now the next presentation will take up by the colleague Mr. Vikas Kumar to tell you further what happened in detail. Thank you. Please.
Thank you, sir. So we are here with a case study of our own plant. Although there are generalized terms in, we will be focusing more on gas lines since the accident occurred in gas line. And I will be more specific and stick to our own plant, and I will discuss with what setup we have in our own plant. Now, the accident happened in gas line of boiler 9. That is, boiler 9 was commissioned in 2014 by Alstom Power India Limited, and boiler 9 is a tangential firing boiler. It can run on coal, that is on 100% load, or we have another option of running that boiler with 70% load on coal and 30% on blast furnace gas. It has capacity of 82,000 normal meter cube per hour of blast furnace gas. This is the actual setup of boiler 9. Now looking forward to the blast furnace gas system. You can see there are 2 lines merging to form a single header. The first one was the LD gas header and BF gas line. I would like to point out here that in Russian boilers and in all other boilers, we had experience of taking BF gas in our boiler, but we had no prior experience of taking LD gas in any of our boiler, and this is very new system for us. Now this header is heading towards BPSCL, and this header is going to our older Russian model boilers, and this header is heading towards boiler 9. Through this setup, this gas line is entering in boiler 9. This is the line diagram for gas line for boiler 9. Now, chronology of BF gas system in boiler 9. In order to understand what might be the reason for accident, I am trying to illustrate what was the chronology. Boiler 9 commissioned in 2014, and due to unavailability of BF gas and LD gas for that boiler, we couldn't take that gas in 2014, and as a result, we took that in 2020. It is to be noted that in December 2020, we took BF gas, but on insistence of SAIL, we started taking LD gas in phased manner, starting from 5,000 meter cube per hour. But in spite of being new to this, we took this step. And extreme caution was exercised for this system because LD gas was more poisonous and excessively explosive. The carbon monoxide content is high, and no previous exposure for us for that. In July 2021, we took LD gas, and in September 2021, the accident happened, and this is the actual picture of that accident. This is the actual picture of corner 2 of the boiler, where the pipe ruptured, leading to the burner of corner 2. It is to be noted that although the picture might be frightening, but since the elevation of this pipeline is at 29 meter height, so no worker is available at that level. Although this happened in night time, so no life and health threat for any worker happened. But for us, this was a very challenge for us, because all the protection measures were there in boiler, all the system were working healthy, and all the working operator shift in charge was cautious for the LD system. In spite of that, it happened. Some other pictures for that accident: the support structure, the support beam for that system got bent downward. The compensator got damaged. Although the accident didn't took place here, but the shock generated from that affected the compensator. The drain pipe was also damaged. Now, it was a challenge for us, and brainstorming started within all the stakeholders, operation, maintenance, and energy management department of Bokaro Steel Limited. We all consulted what may be the root cause for this accident. Although we were not 100% sure, because all the protection measures, bleeder system, purging lines for that pipe were working fine. So the possible remedies were suggested from all those stakeholders, and some of these were introducing steam purging points at each burner. I will show in visual pictures what we are talking about. For the time being, we will know the introduced nitrogen purging point at each burner, introduce pressure gauge and RTD at each burner line, and enlarging U-seal filling line and drain line to face any emergency situation. I will show in picture what we are talking about. Now, to modify any gas line system of our boiler, there are some challenges which we faced. What are those challenges? If we shut down boiler 9, since a captive power plant of BSL, boiler 9 is having largest capacity. To keep that boiler in shutdown or idle phase is itself a challenge. There is import limit in Bokaro Steel plant from DVC. Once boiler 9 gets shut down, the import limit from DVC increases, and hence the other challenges for maintenance purpose was limited accessibility of gas lines in the existing boiler and limited approach for earth movers to do that job. Also, from commercial point of view, the taking time for tender and spot tender also takes time, and for short duration it was very difficult. Now look at the picture. Here I would like to tell what is the pre-existing system. All the red color valves indicates the burner stop valve and gas isolating valve, and green valves indicates the bleeder system. And the white color lines indicates the BF gas system, and the pink color line shows the 8 to 12 ATA purging steam system. Now in this system we would like to know, I would like to emphasize that all the gas purging lines are there. All the gas purging lines are there in only header system. There is no purging in burner system. Once the gas line gets cut off due to low pressure or any mishap, once gas line cut off, the burner system gets shut off in auto mode, and bleeder, that is those valves in green, opens up to release that residual gas in atmosphere. But there is no purging line. So it may be possible that once the bleeder gets open, the atmospheric air may ingress in the system and air pocket may be created that may cause explosion in that system. Also, the tightness and sealing of the burner valve is not ensured because there is no inspection door for that. So any back pressure from furnace side can also reach there, and there is no inspection door for us. So to carry out the modification, that is laying out new purging line and new nitrogen purging line and 8 to 12 atta purging line to keep the boiler in minimum idle condition and shutdown times, to reduce the shutdown time. We planned for pre-layout of the steam line and nitrogen purging line, so that in shutdown time we have to only connect that line to the header, and we all carry in that manner. This chart shows the actual work done in time wise. This is the job sequence, what we carry in limited time of 6 days. This is the modification we done. The actual line is the header, and we took out 4 purging lines. 8 to 12. This header belongs to 8 to 12 atta line, and we carry out, take out 4 purging lines, and we introduce that in burner. These are the valves belonging to each burner. This is burner isolating valve, and this is gas isolating valve. And in between the two, we introduced nitrogen purging line and 8 to 12 atta steam purging line. And in between, you could easily see the bleeder lines. So in any idle condition, the purging should be open, and this purging ensures that there is no residual gas in this system. Earlier, this line was missing. Also, there is no window to check, inspection door to check whether the bleeder valves are holding or not. For that purpose, we cut out pocket to see actual condition, to analyze the root cause, whether the valve was holding or not. We could have easily taken out the valve and inspect, but in actual condition, what is happening, we wanted to see. We introduce another bypass line. This is slight modification in existing system. Apart from the manufacturer and designers, there is only one automatic valve for 8 to 12 atta charging. We introduced another bypass valve in case of any emergency. Suppose this automatic pneumatic valve do not operate, then manual valve comes into picture. And this is the modified system in which the black color line shows the nitrogen purging line. Since nitrogen is inert gas, we took that line also, and this line shows the 8 to 12 atta purging lines. In every burner line, we introduced that purging system since we realized that purging is the only solution for this problem. And accordingly, SOP for taking gas line and isolating gas line was modified. It is to be noted that explosion took place only at the time of charging, so we focused in to design our SOP for charging purpose. At last, we charge again. We charge the BF gas and LD gas in our system, and from last 1 year and 4 months, we are taking LD gas in our boiler successfully, and taking that gas has greatly reduced our input cost. Generating boiler with 30% load on LD gas, that was all in initial manner was wasting in atmosphere through flare-up systems. Now we are using that gas for generating and taking 90 TPH from that gas, and it has become very successful in our boiler. Thank you.
Thank you, sir, for sharing your experiences. Next paper is from an special Durgapur on reliable, safe and sustainable operation of AFBC boiler. This will be presented by Shri B. Arvind, who is DGM commissioning, and Shri Vinay Pathak, who is also DGM commissioning here. And Shri B. Arvind has experience of mechanical erection department, turbine maintenance, boiler maintenance, and Shri Vinay Pathak is backed by experience in operation department and boiler maintenance. Here he is working as DGM commissioning. So I request Arvind sir and Pathak sir to present their paper.
मैं करता हूँ, मैं क्लोज करूँ।
अच्छा ठीक, इसको निकालना पड़ेगा।
ठीक है, छोड़ दो, रहने दो।
अच्छा ठीक है।
Sir, our presentation is on reliable, safe and sustainable operation of ABC boiler. We have installed 2 units of 20 megawatts for catering captive load requirement of DSP. For these units, we have installed 88 TPH AFBC boilers of exact make. As these units are designed for captive load requirement, reliability and sustainability of operation of these units is very much important. But during initial commissioning and now also we are facing few problems which are affecting the reliability of operation of these units. Mr. Vinay Patak will explain the problems and root cause analysis also.
थैंक यू अरविंद। नमस्कार। AFBC बॉयलर NSPCL में ये पहला बॉयलर है और इसको इजेक ने सप्लाई किया है। ये अंडर बेड फ्यूल फीड टाइप का बॉयलर है। ये हाई सीवी के लिए डिज़ाइन किया गया है ये बॉयलर। इसका कैलोरिफिक वैल्यू है 56550। सो इसकी रिलायबिलिटी सस्टेनेबिलिटी डिपेंड करती है दिस टाइप ऑफ फ्यूल की अवेलेबिलिटी कितनी है। ओके ये AFBC बेड का कंस्ट्रक्शन है। इसमें विंड बॉक्स रहता है। विंड बॉक्स डिवाइडेड इन डिफरेंट कंपार्टमेंट। उसके ऊपर DP प्लेट रहता है। DP प्लेट के ऊपर एयर नोजल्स एंड कोल्ड नोजल्स रहती है जो कि कम्प्लीटली बेड मटेरियल से फिल रहता है। कॉन्सेप्ट ये है कि जब हाई वेलोसिटी का एयर नोजल्स के थ्रू पास होती है तो उसमें बबलिंग क्रिएट होता है। देन कंप्लीट बेड में टर्बुलेंस क्रिएट होता है और all particles behave like a flute. This is the basic concept. Display black. क्यों नहीं हुआ? क्यों नहीं हो रहा? वीडियो डिस्प्ले हो रहा है। सॉरी। ओके। ये वीडियो बट
चलेगा नहीं, उसको एग्जिट कर दीजिए पीपीटी मोड से तब चलेगा। ठीक है, बता रहा हूँ उसको पीपीटी मोड से एग्जिट कर दो। हाँ अब चलेगा। इसमें लगता है
जैसा कि ये वीडियो में दिख रहा है ये बोथ ऑयल गन सर्विस में है। कंपार्टमेंट 1 है। कोल्ड लाइटअप है। इनिशियल बेड टेम्परेचर अराउंड 250 to 300 विद सपोर्ट ऑफ ऑयल गन मेंटेन करते हैं बिफोर द चारकोल फीडिंग। नेक्स्ट क्यों नहीं हो रहा? This is the fluidization of hot condition. Charcoal is already feeded. When temperature will come around 500 to 600 degree, then coal feeding will start. इस तरह से सिर्फ फर्स्ट कंपार्टमेंट अभी है। देन आफ्टर मिक्सिंग सेकेंड कंपार्टमेंट, थर्ड कंपार्टमेंट एंड सो ऑन, सो डैट कंप्लीट बॉयलर जो है 2 to 3 आवर्स के अंदर फिर कंप्लीट बॉयलर लाइट अप हो जाता है। बट स्मूथ ऑपरेशन के लिए AFBC में बेड का परफॉर्मेंस इम्पोर्टेंस है और उसके कंबस्शन के लिए कुछ क्रिटिकल पैरामीटर्स है जैसे कि बल्क डेंसिटी ऑफ द कोल। यदि कोल की बल्क डेंसिटी कम है तो फ्लूइडाइजेशन अच्छा है जैसे कि हमारा डिजाइन 0.77 है। यदि बल्क डेंसिटी हाई है तो फ्लूइडाइजेशन पुअर होगा। सेकेंड FD एयर प्रेशर। FD एयर प्रेशर सफिशिएंट फैन में मार्जिन होना चाहिए सो डैट फ्लूइडाइजेशन बेटर होगा। प्रॉपर फ्लूइडाइजेशन के लिए हाई वेलोसिटी की रिक्वायरमेंट होती है। वो ओनली पॉसिबल तभी है जब प्रेशर सफिशिएंट हो। थर्ड है फाइंस इन कोल। यदि कोल में फाइंस डिजाइन से ज़्यादा है तो अनबर्न ज़्यादा होगा और सेकेंडरी बर्नर के भी चांसेस है। मॉइस्चर इन कोल। यदि कोल में मॉइस्चर ज़्यादा है तो कोल ट्रांसपोर्ट लाइन चोक होगी और बेड टेम्परेचर प्रॉपर मेंटेन नहीं होगा। We are facing a few problems since commissioning and also in operation, जैसे कि improper fluidization of bed due to bulk density of the coal। यहाँ पे NSPCL दुर्गापुर में डिफरेंट सोर्स से कोल आता है जिसकी बल्क डेंसिटी 1.0 से 1.3 रहती है ड्यू टू प्रेजेंस ऑफ स्टोन इन कोल। ये हेवी स्टोन्स बेड के बॉटम में सेटल होते हैं और धीरे धीरे बेड हाइट को इंक्रीज करते हैं। आफ्टर सम टाइम्स फ्लूइडाइजेशन प्रॉपर नहीं होता, फ्लूइडाइजेशन प्रॉपर नहीं होने के चलते कंबस्शन प्रॉपर नहीं होगा और कोल का प्रॉपर बर्निंग नहीं होगा। सो आफ्टर सम टाइम्स क्लिंकर विल फॉर्म। सेकेंड, हेवी बेड ड्रेन रिक्वायरमेंट विथ लो जीसीबी कोल। लो जीसीबी में एस परसेंटेज ज़्यादा रहता है और स्टोन भी ज़्यादा रहता है। ये दोनों फैक्टर बेड हाइट को बढ़ाते हैं। बेड हाइट ज़्यादा रहेगा तो फ्लूइडाइजेशन नहीं होगा। सो बेड को हेल्दी रखने के लिए सेम टाइम में कंटिन्यूअस ड्रेनिंग और हीट मास को कंटेन करने के लिए चार्जिंग की भी ज़रूरत होगी। अभी हमारे यहाँ कोई मैकेनाइज्ड सिस्टम नहीं है, मैनुअली हैंडल कर रहे हैं, तो आफ्टर 3 to 4 डेज बेड ड्रेन जो है कम्प्लीटली चोक हो जाते हैं और बॉटम एरिया क्लीन नहीं होने की वजह से बॉयलर को बंद करना पड़ता है। थर्ड है चोकिंग ऑफ कोल फीड लाइंस ड्यू टू फाइंस। यहाँ जो भी कोल NSPCL दुर्गापुर में आता है उसमें ऑलरेडी 15 to 20% फाइंस रहता है। आफ्टर क्रशिंग CHP फाइंस जो है 40 से 45% तक चला जाता है। और जो उसमें मॉइस्चर हो बेसिकली इन मानसून सीजन तो ट्रांसपोर्ट लाइन चोक होती है और कोल जो है फर्नेस में नहीं जा पाता, सो बेड टेम्परेचर मेंटेन नहीं होता। सो ये बॉयलर हम लोग के लिए नया था, तो हम लोग अदर्स प्लांट में क्या वो उनकी बेस्ट प्रैक्टिसेस क्या है ये देखने के लिए वहाँ विजिट किए, उनसे बात किए। तो हमारा ये ऑब्जर्वेशन था कि वो स्टोन पिकिंग करके बल्क डेंसिटी को मैनेज कर रहे हैं और बल्क डेंसिटी कोल का 0.8 to 0.9 मेंटेन कर रहे हैं। They have a big coal set and storing sufficient coal for catering surface moisture, basically helps in monsoon season। वो कोल को ड्राई भी करते हैं एज पर रिक्वायरमेंट। वो अदर फ्यूल्स भी लाइक डोला चार, राइस हस्क, वो लोग जैसे उनके पास जो भी बाई प्रोडक्ट है वो उसमें मिक्स करते हैं। डोला चार बेसिकली किलन का बाई प्रोडक्ट है जिसका जीसीबी अराउंड 2000 से 2500 रहता है और बल्क डेंसिटी भी 0.85 रहता है। तो अदर्स जो मेन ABC बॉयलर जो है जिनके पास है वो ज़्यादातर ये फ्यूल को यूज करते हैं और बेड ड्रेन को वो मैनुअली कर रहे हैं बाय एंगेजिंग मोर मैन पावर। This is the coal shed where I visited. Same coal shed also required in NSPCL Durgapur to cater surface moisture in monsoon. ये जिस प्लांट पे हम लोग विजिट किए थे वहाँ ये मैनुअली स्टोन पिकिंग कर रहे हैं, बट उनके यहाँ मैनेजेबल है कि वो 70% चार यूज़ करते हैं, 30% कोल यूज़ करते हैं। हमारे यहाँ कोल कंजम्पशन ज़्यादा है, अराउंड 400 टन पर डे, तो इम्प्रैक्टिकेबल है, ऐसा मैनुअली पॉसिबल नहीं है। फर्दर रूट कॉज एनालिसिस के लिए हमने जो 1 महीने का कोल का सैंपल था जो बॉयलर में फीड किए थे उसका डाटा लिए और ये ऑब्जर्वेशन हमारा था कि जब 3000 जीसीबी का कोल और जिसका बल्क डेंसिटी 1.2 से ऊपर थी वो बॉयलर में फीड हुआ था, तो इनिशियली विथ हेल्प ऑफ चारकोल कोल जला बट लॉन्ग टाइम सस्टेन नहीं किया था और ओनली आफ्टर 2 to 3 आवर्स बॉयलर नीड टू स्टॉप। फर्नेस इंस्पेक्शन किए थे, बिग सेल एंड स्टोन्स, पूरा बेड कंप्लीटली फील्ड था और फिर बंकर को खाली करना पड़ा। बॉयलर को क्लीनिंग करने के बाद अगेन 4000 का कोल लिए जिसका जीसीबी 1.1 से 1.2 था। इनिशियली 8 to 10 आवर्स कोई प्रॉब्लम नहीं था, फ्लूइडाइजेशन नॉर्मल था, बट आफ्टर 2 to 3 डेज बेड हाइट जो है वो अनकंट्रोल्ड इंक्रीज, बेड हाइट इतना ज़्यादा कि उसको कंट्रोल नहीं कर पा रहे थे। बेड ड्रेन्स हमारे पूरे चोक हो गए जाते हैं और बेड टेम्परेचर नॉट मेंटेन हो रहा था, तो बॉयलर को बंद करना पड़ा। आफ्टर क्लीनिंग फर्नेस फिर अगेन हमने 4500 से 5000 GCV का कोल लिया, जिसकी बल्क डेंसिटी नियर अबाउट 1 थी। मोर देन 15 डेज हमारा बॉयलर स्मूथली चला, मिनिमम ड्रेनिंग मिनिमम चार्जिंग के साथ। कंक्लूजन फिर ये हमने फाइनली निकाला कि यदि 1 से कम बल्क डेंसिटी है तो बॉयलर का स्मूथ ऑपरेशन रहता है। यदि बल्क डेंसिटी 1.1 से 1.2 के बीच में है तो मोर ड्रेनिंग और चार्जिंग की रिक्वायरमेंट होती है, जो कि अभी मैनेजेबल नहीं है। और यदि 1.2 से ज़्यादा बल्क डेंसिटी है तो टेम्परेचर सस्टेन नहीं करता। फ्लूइडाइजेशन को कॉन्सेप्ट को ग्राफिक्स के जरिए समझते हैं। जब हेवी डेंसिटी का कोल रहता है उसमें जो स्टोन है वो नीचे बॉटल में एयर नोजल के राउंड में सेटल हो जाते हैं और धीरे धीरे बेड हाइट को बढ़ाते हैं। अपर जोन में फाइन पार्टिकल रहता है जिधर टेम्परेचर ज़्यादा रहता है। ये नीचे 4 ड्रेन पॉइंट दिख रहे हैं, इसके थ्रू बेड हाइट को मेंटेन करना है। यदि सफिशिएंट जितना इनपुट आ रहा है उतना आउटपुट नहीं निकलेगा तो बेड हाइट इंक्रीज होती जाएगी। और बेड जैसे कि आईसीयू बेड है, जब तक ऑक्सीजन मिलेगा चलेगा, तो यही होता है। बेड हाइट बढ़ने से एयर नोजल पूरा ब्लॉक हो जाता है, ऊपर के पोर्शन में कंबस्शन एयर नहीं मिलता और कोल प्रॉपर नहीं जलता और फाइनली क्लिंकर फॉर्म होता है। फिर हमने स्टोन को कैसे कितना रिमूव करने से कितना इम्प्रूवमेंट मिलता है वो करने के लिए कोई एनालिसिस किए। सेम कोल का डाटा लिए जिसमें हमने बंकर खाली किया, 3000 GCV का कोल था और मैनुअली स्टोन निकाल दिए जितना था और फिर उसका बल्क डेंसिटी चीज किए तो हमने पाया कि 1.29 से 0.97 उसकी बल्क डेंसिटी इंप्रूव हुई। और सेम टाइम्स GCV भी 3000 से 3400 तक इंप्रूव हुआ। हमने फर्दर जो भी और कोल था उसका सैंपल लिया और फाइनली ये कंक्लूजन निकाला कि जो भी कोल है उसमें 20 से 26% स्टोन प्रेजेंट है। फिर हमने कुछ प्योर कोल के सैंपल का डाटा लिया और उसका बल्क डेंसिटी चेक किया तो हमारा ये कंक्लूजन था कि 0.84 से 0.98 तक प्योर कोल की बल्क डेंसिटी है जो हमारे NSPCL दुर्गापुर में अवेलेबल है। सो बॉयलर में कोई प्रॉब्लम नहीं है, प्रॉब्लम कोल में है क्योंकि उसकी बल्क डेंसिटी ज़्यादा है ड्यू टू स्टोन। विदाउट रिमूवल स्टोन वी कैन नॉट थिंक अबाउट रिलायबल ऑपरेशन। नेक्स्ट मिस्टर अरविंद डिटेल।
As explained, if we can remove stones effectively from the coal, we can reduce the bulk density of input coal to the boiler, and boiler reliably can be operated. And we have gone through few dry coal beneficiation technologies which is useful for resolving our issue, and this is one of the technology which is very much suitable to us. This is air table or air vibrating separator. This is almost like fluidizing bed only. When we give air through the bottom of the table, the lighter particles will float on top upper side and denser will be downward. With the help of vibrating motion, we can separate the stone and coal effectively. And this is one of the pictures which is under use in some of the coke manufacturing companies. We have a video. Yes. Yes. Coal is being fed from this hopper to this destoner machine. As we can see, the coal and stone mixture is getting fluidized in this chamber, and through vibrating motion, stone is getting separated effectively. With the help of this machine, we can separate these stones up to below 30 mm size also, and this works effectively for below 30 mm size. And efficiency of this stone separation is around 90 to 95%. This is being used already. Industry में use हो रही है, and this will solve our purpose. And one more advantage is that most of the coal that we receive, that around 76% of the coal that we receive is of 3300 GCV, and size is also below 30 mm, almost crushed coal आता है. And for this, ये process, ये equipment very much suitable भी है. And we have customized this equipment to suit our requirement and solve few more other problems also. When we feed coal and stone mixture to these multi-deck screens, these two are the multi-deck screens, in which we separate 3 sizes of coals at the same time. We will separate fines and above 30 mm coal also. The fines are also causing choking problem of coal feed lines. That can also be avoided. And if we feed a narrow range of size of coal to the individual destoner, efficiency of this separation will be very higher, up to 95% also. When we separate stones from the coal, we can reduce the bulk density of the coal below 1, and our boiler operation will be very much reliable. As explained earlier, we are facing 3 problems. We can resolve the fluidization issue by separating the stone and reducing the bulk density. And choking of coal feed lines can be managed by storing the coal under the sheds and separating the fines. Fines are getting separated in the stone separation only. And next, one thing that remains is heavy bed ash drain requirement if we go for low GCV coal. And one more constraint is bed ash handling. As per the design, coal feed rate for 100% BMC is 10 ton. But we have installed capacity around 16 ton coal feeding capacity is available in our boiler. We have already operated our boiler 16 ton coal feeder also. If we reduce the bulk density of the coal, we can go for a bit low GCV coal also. But ash content will increase. If we use our 16 ton capacity, against 14 ton a day requirement of bed ash handling requirement go up to 51 to 50 ton, which is not possible to manage manually. For that, we need to go for mechanized bed ash handling process. And at present, bed ash being handled manually, it is one way it has safety issues, and other way it is not reliable also. As when low GCV coal se jab heap ban jata hai, it becomes unmanageable to handle manually. And other issues that existing bed ash handling system mein ek bed ash cooler diya gaya hai, which will be through FD bed ash will be cooled from 900 degrees centigrade to conveyable temperature, and through this dense air it will be conveyed to existing fly ash silo, which is around 200 meters away from the boiler. But the bed ashes cores are up to 5 to 6 mm size also. If we try to convey the bed ash, and we have inquired in the industry also, the conveying lines get choked frequently, and bed ash handling will not be effective. And at the same time, it will affect the fly ash utilization, and choking release remove करने के लिए manual requirement भी रहेगा. And if we convey bed ash directly to the silo, we lose around 7 to 9 tons a day bed material, which is not cost effective for operation. To resolve that issue, we have to go for bed ash handling, mechanized bed ash handling. We are given 2 options here. One option is using the existing bed ash cooler system only, but not conveying this bed ash to the existing fly ash silo. Instead of that, if we install a silo just behind the boiler, and we can convey to closer distance. By this, we can avoid choking chances, and we can separate using screen that usable bed material and shells here only, and usable bed material can be recycled. But inherent problem in this bed ash cooler is that this is prone to more choking, and this also requires some manual intervention, and sometimes becomes unreliable. If we want to make it completely reliable, we can go for cooler conveyor instead of this existing bed ash cooling system. This is a bit costly, but it is more reliable and less maintenance prone. And this is one of the cooler conveyors installed in Durgapur only, in DPL, and it is working in operation since 2008. And hot bed ash will be fit to this belt conveyor. In the conveyor itself, it will be cooled and conveyed to the silo, and where we can separate in screens. By using screen, we can separate the bed material and reuse the bed material also. Coming to cost benefit analysis, installing the destoner plus bed ash handling system, option 1, cost of installation shall be 1.82 crores on account of saving in reduction in manpower and recycling the bed material. We can save 1.2 crores a year. So number of years of return will be 1.2 years. And if we go for the option 2, which is using cooling conveyor for bed ash handling system, it will be a bit costly, maybe 2 crores more we have to invest. And number of years of return will be 2.5 years. But by installing these 2 systems, we can resolve all these problems, and we can run our boiler reliably, sustainably, and in a safe way. Thank you.
Thank you, sir. Next paper is from NSPCL Bhilai on the very relevant and important topic in case of especially thermal power plant. We are witnessing increasing penetration of renewable energy in the grid. So need has arisen for flexibilization of thermal power plants. The Shri Amit Kumar and Shri Aditya Kanduri will present and show us how to deal with the increasing requirement of flexibilization. Shri Amit Kumar, who is working as Senior Manager Commercial at NSPCL Bhilai, and he has experience in operation, commissioning and commercial. And Shri Aditya Kanduri, he is working as in NSPCL Bhilai, and he has experience of C&M and as well as in operation. So I invite Amit Kumar and Kanduri to present their paper. पांचवा है सर जी यही है ना हाँ हाँ
Thank you, Dilip. A good evening to all of you. The topic of our presentation is increasing flexibility of thermal power plants. Myself, Amit Kumar. As we all know that global warming is the single largest threat to the earth, and in this global warming, thermal power plants are one of the leading contributors. So it is as we know that to mitigate the temperature and to maintain the temperature, the generation from thermal power plants need to be reduced, and the renewable energy all over the world, renewable energy is getting promoted. As we know that in this as we all know that India has also set a target of 500 gigawatt of RE power installation by 2030, and for this much of RE power integration to the grid, thermal power plants will have to play a crucial role. In this presentation, we will see what is flexibilization, why it is important, and how we are going to achieve this, and what is the mitigating effect of this flexibilization. The present installed capacity of India is 410 gigawatt. Out of this, 49.66% is being contributed by thermal, and 29.46% is through RE power. And this percentage of RE power is going to increase very fast. From this data taken from the POSOCO, it is very much evident that the maximum thermal power generation of thermal power plants and the maximum and minimum generation, this band is increasing year by year, and this curve, the slope is getting increased year by year, and in future this is going to steepen up. Need for flexibilization, as we all know that renewable energy are variable in nature. These are intermittent. This depends on the season, and so the balancing power need to be supplied by thermal power plant, and for the stable operation of the grid, grid thermal power plants will have to increase its flexibility. This is the famous duck curve, and from this data we have taken from all India demand on June 2022. This is the green curve. This is the solar generation. As we are seeing, this is picking up with the passage of day, and this is coming low with the at the evening hours. So the balancing generation is to be done by the thermal power plant, and the middle one, that is this line. This line is ramp down, and in the middle the thermal power plants are forced to run at the technical minimum, and this is the ramp up, and this presently we need 68 gigawatt of ramping down at the rate of 2.17 megawatt per minute, 217 megawatt per minute, and in the ramping up it is 100 gigawatt at the rate of 220 megawatt per minute. This figure is going to increase in future. And the flexibility parameters of any thermal power plant depends on three factors. Low technical minimum. Presently, CRC governed stations have been, our technical minimum is 55%. But CA has recently notified and made it to 40%. And it has given 1 year time. And the ramp rate is 1%, and this is going to be 3% per minute. This is we have shown by the this. This is the simply number of ramps the thermal power plants in western region have received till December. From this we see that the thermal power plants whose ECR is high, they have been asked to ramp up and ramp down more fast, like the case of Mauda. For minimizing the technical minimum up to 40%, the most important thing is we have to ensure the combustion optimization in the boiler, and we know that the combustion process depends on we have sorted out these factors on this combustion depends. The first one is balancing of coal flow across all pipes, and one thing is also that with for 50% of technical minimum, we can't run 4 mills. We have to go 2 or 3 mills. And for this, and out of this, we have studied the flow through PA, and for this PA flow, we have to review the PA flow curve. Normally, presently the air flow and the coal flow ratio is linear, but for reducing load below 55% and running the mills with 2 or 3 mills, we have to this curve is to be modified and below 50% loading, it minimum the PF flow should be there, and it should be around 60. It is to be set as 60%. And the temperature of the PF flow also plays a very crucial role in combustion. It should not be less, otherwise combustion will get hampered. PF, the temperature basically depends on 2 factors. One is VM and second one is moisture in the coal. And with 2 or 3 mills, we have to optimize the mill outlet temperature. Otherwise, the flame will not be stable. This is the too low airflow can keep the coal particles suspended above the pyrite zone. We have to optimize the PF flow. And it should be between 15 to 20% of the total air flow, because this is the reason with 2 or 3 mills the flame becomes stable as compared to 4 mills in low load operation. Coal fineness is also very important. Coal should be of the proper size. Only then the flame will be stable. And this is the curve and the pulverizer capacity with different parameters of the coal. And for increasing ramp rate, which is presently 1%, we have to first of all fine tuning the existing CMC logic, because CNI is going to play a very most important role for achieving 3% ramp. Because usually temperature excursion happens, and for this CNI logic and it is to be modified. Main steam temperature controller and reheater temperature controller is to be modified for maintaining the MS and HRS temperature. This is the condensate throttling system. This has been successfully tested at NTPC Dadri. This is very much effective in fast changing the load. And actually, this is basically used for primary frequency control. And this is the system of this is retrofitting and modification, and this has been done in many Chinese plants. Turbine HP stage bypass frequency control and power increase. This also we can employ for fast response. And for a fast startup, we have to deploy the automatic plant startup system. And many European thermal power plants are equipped with this system, and the results conducted in India is also very encouraging. It is evident that this is going to help, and it is very much efficient compared to manual startups. And we all know that this ramp up is going to negatively impact our thermal power plants, systems, boiler tubes and turbines, and how we can mitigate. This is going to be discussed by Aditya.
Thank you, sir. As we all know, very low load and flexible operation of thermal plants
it is very highly it needs a highly expertise. It also has several problems involved in it. Some of the reasons for the damages due to cycling and these low load operations are various components are subject to thermal and mechanical stress besides creep. These thermal power plants basically are not designed to withstand the high temperature fluctuations, which is called fatigue. Unequal heat distribution and temperature transients also add to this problem. Air fluctuations in the air fluctuations and which affect the furnace parameters, they greatly damage our operational parameters. So control valves and recirculation valves also does not operate smoothly at low load conditions. It is what is observed in our power plants. Unequal loadings of power plant PA fans and mills also cause very low load, also cause very serious problems in regular operations. And we also know, as we are going to 40% technical minimum, this problem is going to be highly, it is going to be more critical. Some of the undrained during startups and shutdowns, if we frequent, it may happen that we need to shut down or start our plants more frequently when the technical minimum is going down and to accommodate the renewable power. Then in case undrained condensate in the pipelines, thermal shocks and hammering, more frequent hammering causes damage to the our equipment. Whereas it must be remembered that there are several safety hazards involved in cycling and low load operations. For instance, furnace explosion is a very serious issue which can happen due to improper purging after unit tripping, choking up pipelines due to coal pipes, due to less air flow during low load operation, and when during the transients and ramp up when the airflow increases and this PF sudden ingress of this polar flare into the furnace causes the explosions. And further, as you all know that we are forced to use the biomass pellets which has got high volatile matter, which will add on to this issue. For this, oil gun should be always, regular monitoring of coal pipe temperatures and checking should be done. Oil gun should be checked frequently. And one more thing, when generally we do not run the soot blowers at very low loads. Now, only 50% of the time we are getting reduced loads, and 50% of the time we are running our units at full loads, and then soot blowing is done continuously. However, in the future, if we do not get the opportunity to raise the unit load to full load for continuously long period durations of time, then it may be possible that soot may be accumulated inside the boiler, and that will cause a furnace explosion in the during later stage when soot blowing is done. For that, sonic horns for soot blowing may be used, but the sonic horns, even though they are not very as efficient as the normal steam soot blowers, but they can somehow, to some extent, they can mitigate this issue. Also, mill explosion can also take place because of very low loading of mills and temperature escalations in the mills, and also using the biomass pellets in the future. For this, we have to go for 3 mill operations when the load gets reduced to 40% technical minimum. Here are some of the damages that can be possible damages to capital intensive items of the power plant. Generator windings, even as per current research, even if the windings are subjected to high temperatures more than 115 degrees for continuously, even for very long durations, there will not be any problem. But the temperature transients will definitely cause a problem, such as the initiation of micro cracks. For that, we need to, if we can control the winding temperature using the cold gas temperature valves, which is provided in NSPCL Bhilai, we can mitigate this problem. Grinding elements, when the load is, when the mills are operated very low loads, because of PF bed thickness, the mill decreases, which may result in the contact between bull ring segment and the rollers. And to mitigate this issue, we should try to run the 3 mill, go for 3 mill operation and try to run the mills at minimum 50% load. And there are several old joints in boiler, erection joints in boiler of economizers, superheaters and reheaters which are directly connected to the boiler structure during the erection. They are also subjected to severe stress because of the high gradients and due to fatigue. These generally, there are thousands of such joints inside a boiler, and it is not possible to replace everything in a single overhauling. That is why if we should plan in the advance and go for radiography and phase-wide manner of changing these joints should be done in order to mitigate the serious damage in the future. Furnace area disturbance already because of hot air and cold air mismatch, it will happen, and if we go for 3 mill operation, it will be we can mitigate the same to a large extent. And there are, when we come to boiler tube leakage, there are several reasons for boiler tube leakage, such as slag formation due to lack of soot blowing, temperature transients, ramping and ramping down, short-term overheating, and also oxygen pitting, corrosion due to oxygen pitting because of water chemistry. All these effects can be reduced up to some extent using sonic horns and regular soot blowing and monitoring the temperature excursion during the ramp up and down. And for this, C&I plays a very critical role in maintaining these excursions under limits. Similarly, it is quite possible that we go for quite quicker startup and regular start down, and maybe it is will be forced to shut down the units in the quarry, and when the boiler is being started, the economizer recirculation, there will be higher temperature, and it will be feed to the cold DM water. There will be temperature gradient difference, and that will cause a problem with economizer tubes. If you take the water from the deator pegging during startup, that will be we can reduce the problem. And deator pegging also reduces our oil consumption also. Similarly, PF fan, there will be a stalling problem if we do not maintain it properly. And in last 4 years, we can see that there are different tube leakages related to BTL in NSPCL Bhilai. There are, due to cycling operation, chemistry parameters also deviate, and cycle chemistry also has a serious impact, like corrosion due to oxygen, and silica also increases during when the drum pressure is comes down. And in this case, we have to make sure that the condensate polishing unit should be in service throughout when you are operating in such conditions. And we have to remember that thermal plants are going to stay in the future for a very long time to come into future. However, the importance will be in to the renewable power, and that will get the highest priority due to the highly ambitious targets of the Indian government. And thermal power plants are going to play a vital pivotal role in large scale integration of this renewable with the grid. And higher the priority given to renewable energy, the more stressful it will become for the thermal power plants to operate, and the condition will be more stringent. And lastly, C&I will play a very crucial role in this flexible operations. All necessary upgradations and logic changes in order, such as even smooth operation of valve unit, low load excursion, temperature excursion, maintenance temperature excursions, even in the cycling operation should be done. Thank you.
Thank you, sir. Now we come to the last presentation of this session. This is to be given by Shri Vikas Chandra Jain and Srimati Samriddhi Singh, who are working in Electrical Maintenance Department at NSPCL Rourkela. The topic of the presentation is 220 kV gas insulated substation at NSPCL Rourkela. Vikas and Samriddhi, please.
नहीं पॉइंटर चाहिए हाँ कुछ दिख रहा है कुछ तो दिख नहीं रहा है एलईडी स्क्रीन में काम नहीं करेगा कुछ स्टिक भी नहीं होगा चलो ठीक है Hello. Hello. Good afternoon. I am Samriddhi Singh and my colleague Shri Vikas Chandra Jain, both senior manager from Electrical Maintenance Department, are present here in front of you to give a presentation on gas insulated substation. This substation has been recently commissioned in 250 megawatt unit of NSPCL Rourkela. We'll be going ahead with the presentation and these are the key points. We'll be discussing about the GIS and its advantages, equipments of GIS. In detail, we'll be discussing about the gas monitoring system, challenges that are identified during the commissioning, maintenance procedures of GIS, spares and contracts, and the challenges ahead. First and foremost, what is GIS? The gas insulated substation is a high voltage substation. Now this substation is used normally for 33 kV and above, and here the major conducting portion, it is contained within a sealed environment and it contains SF6 gas as the dielectric medium. Now going to the advantages of GIS. The first and the foremost advantage is installation space reduction. To give you an idea, the normal conventional switchyard, the length of a base span is around 18 meters, but when it comes to GIS, the span is reduced to about 3 meters. So the space reduction for each bay is around 67%. The second advantage is increase in human safety, as live parts of the switchgear are contained in a ground metallic sheath. This is the internal structure of a GIS. Here, this is the conducting. Extremely sorry. Here, this is the conducting portion, the circle which you can see. The conductor passes through this portion, and there is an outside metal enclosure. Now, this metal enclosure is earthed using the multi-point earthing. As we can see from the graph, the safe voltage, that is the permissible touch voltage for any metal to metal contact, is about 65 volt for 3.2 seconds. Now, in GIS, the design for touch voltage during the 50 kiloampere fault is only 28.35 volt. Now, what is the biggest advantage of this? That the person who is working in GIS is almost free from any electrocution. So, the biggest advantage of GIS is the human safety. It has higher reliability than AIS, that is the air insulated switchyard. Now, what happens in air insulated switchyard is it is outside, so any weather condition, birds or pollution, contamination, it affects AIS. Unit outages can also take place because of external conditions. GIS, being in an enclosed building, it is protected from any outside conditions, so it is highly reliable. Then it is free from fire hazard. Why? Because it uses SF6 as a dielectric medium. Now this SF6 gas is highly thermally stable gas. It does not catch fire up to 500 degrees Celsius. So incidents of fire hazards are very minimum or almost nil in GIS. Lastly, it has lower noise level because each make and break operation is being carried out inside a closed and shield. So the noise level is very low. This is a small comparison between the gas insulated switchyard and the conventional air switchyard. The equipment cost of AIS are obviously lower because most of the equipments of GIS are imported. Second, we have the installation and site development cost. The GIS is lower because it is enclosed in a building. AIS bay preparation requires a large amount of capital and time also. Fire and electrocution hazard is almost nil in GIS. When it comes to environment, SF6 being the SF6 being the greenhouse gas, if leakage occurs, then GIS can be somewhat detrimental to the environment. Now this is the GIS we have in NSPCL Rourkela 250 megawatt unit. Its make is Hyosung Corporation, South Korea. Its rated short circuit current is 50 kiloamperes. We have 10 number of bays, 1 for GT, 1 for station transformer, 4 outgoing lines, 1 spare line, bus coupler and bus VTs. Here we have tried to show all the equipments. This we can see in detail. In NSPCL we have a 2-bus system. Both the buses are isolated by using the disconnector switch 89A and 89B. In this figure you can see these 3 poles and these 3 poles. These are for 2 buses. Then we have a earth switch ESA, a circuit breaker that is SF6 circuit breaker. It has excellent arc quenching capabilities. Then we have current transformer. Then ESB earth switch. Now this earth switch ESA and ESB, the top earth switch ESA and this earth switch ESB, they serve a special purpose. From here we can inject the primary current and voltage for testing purposes. So for testing of CT and circuit breaker, this ESA and ESB are used for testing. Now ESL, that is the earth switch that is used for static charge dissipation. That where you can see at the top, and finally we have a line disconnector that is 89C. Now there is a gas inside all this compartment and we have 2 types of spacers, gas tight spacer and gas through spacer. Gas can pass from one compartment to the other compartment in a gas through spacer through the holes, but in gas tight spacer the gas is confined in that chamber. Here we have the circuit breaker that is in the gas tight spacer, mean the SF6 gas of circuit breaker cannot go to the other chambers. But other chambers, they have the gas through spacers. We have equipment called gas relief device. In case any fault occurs, then the pressure increases drastically. During that time, the metal enclosure can rupture. To avoid that rupture, we have this gas relief device. It's like a puncture kind of device to release the pressure, and so there is no damage to the metallic enclosure. This is a gas monitoring device which continuously monitors the pressure of SF6. The rated pressure in circuit breaker is 0.71 megapascal and for the rest of the compartment is 0.55 megapascal. If it goes beyond a limit 0.69 or 0.52 there, a refill alarm will come. If it goes more below, then the breaker block operation will occur, means the breaker will neither trip nor it will close. And if it goes beyond that, then the zone trip will occur, what we call in simple terms as the bus bar protection will operate. This is the SLD which the operation person can see sitting in a control room. If all the SF6 gas pressure is healthy in all the complete 10 bays in each and every compartment, then all will appear as green. If the pressure goes low, the color changes, so the operation person can know immediately that okay, this is the area where the gas leakage has started occurring. Next, I would like to call Shri Vikas sir to tell us about the problem encountered during the commissioning and the maintenance procedures of GIS.
Thank you, Samriddhi, and good evening, sir. First of all, I am going to start with the major problem encountered and rectification work carried out during the commissioning of GIS. So, first problem was flashover is occurred during the power frequency HV test of the GIS. Basically, this test has to be conducted to ensure the dielectric strength of the complete GIS. This voltage has to be injected in following manners. First, the voltage has to be increased up to the 170 kV for 15 minutes, 245 kV for 3 minutes. These two for the conditioning of the GIS equipments. Finally, the voltage has to be increased up to the 380 kV for 1 minute, which is the acceptance criteria of the GIS equipment as per the IEC 62271. Once this test is completed, then the voltage has to be reduced up to the 170 kV till the partial discharge measurement of GIS is completed. Basically, this partial discharge measurement is to be carried out to identify the quality of the materials. So, we have created the section in the GIS, and this red marking is showing the test circuit section 1, where it is prepared by closing the circuit breaker and isolator, keeping the earth switches in the open conditions. When we have injected the voltage in this test section through Bay 203 SF6 to air bushing, a flashover is occurred at 170 kV. Since GIS is an enclosed structure, it was very difficult to identify the location of the fault. We have provided an aluminum foil which is conducting over the gas spacer, so that if any flashover is occurred, the discharge mark can be seen. So when we did the physical inspection of the GIS at that time, the flashover mark was observed on the bus extension module of the GIS. After degassing of this faulty gas compartment, the flashover mark was observed. After degassing of this bus extension module, we have dismantled this bus extension module, and what we found that a moisture absorber was left during the erection, due to which this flashover has occurred. Also, flashover mark was seen on the insulating spacer. So, we have carried out the fault rectification by replacing this insulating spacer, and this module is thoroughly cleaned, and again the re-erection of bus extension module was done. After the re-erection of bus extension module, SF6 gas is filled in this bus extension module by using DELO machine, which is used for the evacuation and purification of the SF6 gas. This SF6 gas is filled up to the rated pressure, and the leakage test has been carried out. Also, the purity of SF6 is checked by the SF6 analyzer kit. Once these steps are completed, the HV test is again conducted and it is passed for the complete GIS. Now the second major problem encountered is when we are checking the schemes, we found that bus joint tripping is not available from low SF6 gas joint trip. And the repercussion of it is that if low gas pressure chamber not isolated, then the major flashover will occur. Basically, as this is the SF6 gas module, so we have discussed the scheme with Hushong, BHEL, and also confirmed from other NTPC stations and SAIL that this scheme should be implemented. So the modification is carried out by defining the input and outputs in the 16 peripheral units, and logic is defined in the 2 central units of the bus bar relays. So by implementing this, now the bus bar tripping is available in case of low SF6 joint trip. Basically, it is required as the clearances between the conducting path and metallic structure is very less in case of GIS. Now the second point which I am going to cover is a maintenance procedure of GIS. Basically, as per the O&M module, the inspection criteria is divided in three parts. First one is a patrolling inspection, which has to be conducted on daily basis. Second one is orderly inspection, which has to be carried out during the maintenance and inspections without discharging the SF6 in the period of 5 years. Third one is a detail inspection, which has to be carried out after discharging the SF6 gas. So we have prepared a maintenance schedule and on daily basis we are checking the gas pressure in every gas compartments, visual checking of for any external damage of insulator and bushings. We also check spring charging mechanism counter and its indicators. A view glass is provided in disconnector switches and R switches that we are checking on daily basis. We are observing if any abnormal noise is persisting, and also the alarm oblique annunciation in the control panels is checked on the daily basis. In 5 years, various type of testing has to be carried out, like gas leakage test in every compartment. In case any internal fault occurs in the GIS, then there is the possibility of byproduct of SF6 gas has produced, so the purity test has to be conducted. We have to check the density switches. For the structure, we have to do the tightness of the bolts and painting if required is to be done. For the circuit breaker, timing test and contact resistance measurement has to be carried out. For disconnector, earth switch and fast acting earth switch, we have to carry out the manual operation check, timing test, etc. All interlocks are provided in the local control panels for the circuit breaker, isolator and earth switches. These P&I checks is to be carried out in this maintenance duration. Then the wiring of CT and IR test is also be conducted in this duration. For further presentation, I would like to call Samradhi Singh.
Finally, we require some spares to go ahead for the GIS maintenance. We have taken budgetary offer from the Hyosung, and here is the total cost of the spare, mandatory spare that we need to maintain. It is around 3 crores 21 lakhs, the major cost being the circuit breaker of about 98 lakhs, disconnectors or isolators 66 lakhs, earth switch 66 lakhs, and then CT of single phase costing 16 lakhs, PT 14 lakhs, SF6 gas about 11 lakhs, and other small spares costing around 20 lakhs. So this for this the budget has already been kept, scheme has been approved, and procurement action we are going to initiate. And then we need AMC contract for GIS. This reference we have taken from NTSCL PO. Budgetary offer for NSPCL is still awaited. Here the cost of 1 man day of a Korean service engineer is around 1,57,000. And the cost of one Korean service technician for 1 man day is around 1,15,000. One service engineer or Indian service engineer 77,000 for 1 day. Technician 22,000 for 1 day. Overtime charges are extra. So NSPCL offer is still awaited. This reference we have taken the NTSCL PO of 2021. And finally the challenges ahead. Since it is a new technology for NSPCL, so training for maintenance executives is required, and regular communication from NTPC needs to be established to know any updates. Second, spare and AMC from OEM is required. For that, the procurement action has already been initiated. Access to live parts of maintenance is very problematic. So we need to prepare checklist, SOPs and SMPs. So breakdowns are very minimum. Outages can be extremely long. So particle and moisture contamination needs to be avoided, because this is the major cause of breakdown. For that, rooms needs to be sealed and positive pressure needs to be maintained at any time. Finally, ending the presentation with the famous Bill Gates quote that power is not the knowledge kept, but the knowledge shared. Thank you NSPCL for giving opportunity so that we could share our knowledge, and I thank all my seniors for their continuous guidance and support. Thank you.
पेन नहीं, हाँ हाँ है पेंसिल. Thank you, sir. Thank you, ma'am. Now this concludes this session 2. Now I request session chairman Shri S.K. Ray sir to summarize this session. And one more thing, if any question is there from any of the participants, then he may hand over to Shri Faiz Ahmad. Sir, please.
I am having a question. I have not handed over that. It is from, a question is for Bhilai Dinox group. You have told that in the first unit you have taken 38 days in place of 35 days, and basic reason for the delay is the deviation in dimension of coal burner nozzle tip, which you have rectified by grinding. So why this deviation has taken place? We have given a drawing, we have a approved drawing, and with that, with respect to approved drawing, the L&T has supplied the material. Whether deviation was there, which we have not checked, or actually that installed burner tip is having different dimension and drawing is different. What is the reason? And if at all it can be addressed in your precautions to be taken, it will be helpful for other unit who is going to retrofit the Dinox system.
Sir, actually the drawings supplied by BHEL were supplied to L&T. Here as a conventional method we provide shields for the boiler tube, sir. These were not represented in the drawings, and as per regular maintenance practices, shields were covered, which were covering approximately 4 to 5 mm on both sides of the coal nozzle tips. So these were not anticipated by L&T, and we were also not aware of the thing. When all the panels were fitted, then we came to know the issue. Later on, L&T suggested with their engineering design, the coal nozzle tips can be grinded up to 5 mm.
So this thing you can put in your presentation wherever the old unit they are going for Dinox, they should take care of this.
Yes, sir.
Okay. The another question is from this is for Bokaro. Boiler number 9. What my understanding goes, this boiler was originally designed for BF gas and coal firing. Subsequently, you have added LD gas. Am I right?
Yes, sir.
Have you done it? Have you done engineering for it? When you change over the gas firing from blast furnace gas to LD gas, any engineering was done?
Hello. In 1 lakh normal meter cube of per hour of BF gas, we were mixing only 5,000 LD gas. And in that 1 lakh 5,000 gas, we were taking only 50,000 gas, and rest was going towards Russian boilers. So a very minuscule fraction of that was coming in our boiler for trial purposes.
Means engineering was not done?
No, sir.
Okay, you please take care. Whenever you go for any change in the boiler combustion fuel, you please refer it to your engineering section. What are the precautions has to be taken? Otherwise, they may land into such type of explosion and all. That is there. So, okay, but subsequently you have done it. So that is my suggestion in
yes,
future.
Sir.
Okay. Thank you.
Thanks.
Sir, you want to go there from here?
Hello. Thank you, Dilip ji, and good evening to all. At the outset, I thank the organizing team to give me this opportunity to chair this second session, which is really, I thought it might be difficult for this session after the post-lunch, having a such delicious lunch. It may be difficult for me as well as all the presenters to do the justice for that session. But I congratulate all the presenters. They have presented nicely all the 6 presentations and kept all the members live after having such a delicious lunch. As far as all the presentations are concerned, the first 2 presentations are this DNOx modification and biomass based pellet utilization. Both are the talk of the day, both are related to environment issues. As we are the power producers, being thermal power generators, we have the responsibility of taking the environmental issues into most importance. That should be our motto. So considering the regulations imposed by government, all the power generators, they are utilizing this DNOx, they are installing this DNOx in order to maintain the parameters of environment parameters, and successfully, as Kaushal Sahab already clarified the problem. He has asked the question already to the first presenter. That was my doubt also. But you learn from your experience only. So in first unit, we have learned from our experience, which have utilized in the second unit to get it rectified and do it in less time than the requisite time issued by this. And coming to this biomass pellet utilization also, that is purely again environmental issue. And in fact, in Bhilai also we have already pellet firing, this pilot, as a pilot project, we have already done this. And exactly as our Jindal friends, they have utilized this 5% blending. We have also utilized this 5% blending. I think our NSPCL team and all, they should be in touch. Both the units are same rating and all this thing. So they will be in cooperating with each other to for future any progress in this thing, because it's a mandate from government, and we have to utilize this pellet firing in future also. So I think we should cooperate with each other and do it in for a better. Doubts are there for availability and cost. As he has rightly pointed out, the cost is also very high now. And in fact, I was sitting, our director Sahab, he was very keen to ask this question, why the transportation cost is so high. I think he will clarify, my friend from Jindal, you will clarify this thing. And coming to other one challenges, this BF gas, Sir already Kaushal Sahab has clarified the question and all this thing, and reliability of sustainable operation of AFBC boiler. Coming to this point, I think we know we designed our boilers taking into some fuel parameters. But if you do not get that right fuel, might be, I think that might be the main cause. We are not getting the designed fuel, so that we might be facing this problem. If I am wrong, then maybe clarified. So we should aim for this thing. I will give you a small example. In Odisha, there was a this fertilizer plant. They installed on power fertilizer plant in Paradip. And for raw material, that was planned to be received from Nauru, somewhere in some island is there. From that, raw material was there, and that plant could not operate because of non-availability of raw material only. So we know as power plant professionals, everywhere we are facing with coal quality and all this thing, and specifically in this, the quality of coal is very high. JCB, as it was pointed out, if it is not received, so we are discussing with director साहब, अगर हम imported coal शायद use करते हो सकता है, our performance will be better maybe. Next thing. And this BF gas also, we are also thinking in, Sir was always advising us ki in PP2 you change all the gas, they have abundant gas, how can we do this thing? I think our team from Bhilai also, they may be in touch with Bokaro still, how we can replace total coal, because in PP2 we are facing a lot of coal problem. If you can increase our gas use ratio in our Bhilai, then it may be better for us. So I think Bhilai team, we should be in touch with Bokaro, which will be helpful for us. coming to other two study of this flexibility operation, that is the talk of the day, need of the day also, and इसमें कोई हमको relaxation नहीं है, and we know कि आज का दिन में हमारा total installed capacity in our country is 410 gigawatt, and as far as, if I am not wrong, it is predicted कि by 2030 our installed capacity will be around 800 gigawatt, and where we may have to add another 100 gigawatt of thermal power into this grid. So thermal power requirement will be there, जो हम सुबह डाउटफुल हो रहे थे कि हमारा 10 साल है या 20 साल है, but I think जब तक हमारा देश में कोल abundant है, जब तक कोल रहेगा, there will be no doubt that thermal power will be there, and with that we have to be there, and you know, this is a very particular problem for this flexibility in operation. We think thermal power, thermal plants should run at base load. There should not be any disturb there. There should not be any changes. इतना अलाउ नहीं करना चाहिए, उनको बेस लोड में चलाना चाहिए. बट हमारा लोड डिमांड ऐसा वेरिएबल है, तो in order to maintain grid discipline, we have to maintain the, as the law says, we have to be abide by this requirement, and in fact. It may be slightly detrimental for the life of the power plant, but we don't have any other go. We think maybe after some time, if our load requirement maybe stabilizes, then this thing may not be required in future also. We should expect as thermal power generators. And coming to last one, this gas insulated substation, it's a very actually though gas insulated installations बहुत पहले हमारा है, normally steel plant and everywhere it is there, but in thermal power plants, because we have abandoned land and all these things, we don't go for, and it costs also very high. I think our friends would have told how much in comparison to air insulated, how much cost it is, kitna time, how much it cost, and I am happy our director sir is very keen on this GIS. It is his past topic also. He has asked some questions, and in fact, since last 10 years I was not in power plant. I was involved in coal mining business, so it was a very learning experience for this today also. I am thankful to once again to our team to give me this opportunity, and as I should go with the question of our director sir for GIS team. He has asked whether any test conducted to measure dew point of the SF6 gas. If it is so, yes, किया था. We use dew point analyzers for SF6 breakers.
Yes, sir. It is done through the SF6 analyzer kit of Delu make. And for CB, the limit was less than 300 ppm, and for other gas compartment, it is less than 500 ppm. That I have to check, sir. Sir, we have checked actually, sir. It is. सर बिल्कुल सर, वो चेक किया था, वो मेरे को टेस्ट रिपोर्ट में चेक करना पड़ेगा. इट इज़ विद इन द लिमिट. यस सर, इट इज़ डन.
-60 to -5 as sir has advised, you should check the acceptable range is -60 to -5.
I think so. For normal compartment, it is a -10 degrees Celsius, -30 degrees Celsius, and for gas compartment, for as breaker, it is less than. Sir, we will check. Sir.
Another question he has asked also, whether online PD measurement is there, measuring device?
Sir, online PD measurement is not available. It is in the offline mode, and principal is ultra high frequency mode is there.
I think training need also.
Right from 220 kV to 132 kV, and the suppliers are GANS Hungary, CG Global and G. I request you have a dialogue with GM in charge electrical and Billai steel plant. I will arrange that and you please visit that GI substation, and they are having a beautiful case study because 2 years back they have suffered a major setback of a flashover in the 132 kV gas chamber. And regarding the spare requirement, you should have indented rather you should have get the budgetary quotation for at least one spare gas chamber. At least one chamber. वो भी आप ऐड कर लीजिए. Okay.
Sir, it is added 10% SS gas is added in this.
No, chamber. You must have a spare chamber.
Okay, sir.
With the complete bus, complete isolator and breakers, so that it will be easy for you to. I think you must contact Billai people, and I am requesting RSP BUH. कमल किशोर जी, आप थोड़ा सा शंकर जी से बात करके एक टीम भेज दीजिए, तो थोड़ा सा उनको एक आइडिया हो जाएगा. बात करके थैंक यू.
तो मेरा एक डाउट है, जब आप गैस निकाल तो सपोज देयर सम लीक और सम फॉल्ट इज ऑब्जर्व, सो इफ यू टेक आउट द गैस व्हाट यू यूज, हाउ टू नॉर्मल एयर इज यूज्ड और समथिंग एल्स यूज्ड फॉर मेंटेनिंग द कंडीशन इनसाइड?
Basically it is we are degassing through this DELO machine only, sir. Evacuation and evacuation kit only.
So you take out all the SF6 gas, but
yes,
you give, what you give inside? Is there any dry air you use or nothing else?
Sir, that has to be checked, consult with the OEM, sir. Actually, we don't have any idea.
Okay, thank you. Sir, का एक question for biomass pellet. Why freight is so high? Mike, please. Team is there.
Actually, the reason for the high freight cost is due to the, as you know, the bulk density of coal is very higher in compared to the pellet. Pellet having the bulk density of 0.600. If you can compare with the coal, just half of the coal. So in case of the transportation, if say suppose we are having the truck of 35 ton capacity, so this coal, if you are loading the coal, it will be gone 35 ton. But if you are loading this pellet, it won't. It just half of that. So due to the reason, the fuel cost of that truck is the same, the diesel is the same. So this is the one of the reason why the transportation cost, freight cost is higher. So this is very simple.
Thank you. Is there any question? Any more? No? No more questions? Acha, somebody is raising his hand.
Sir, one thing I would like to add, sir, there is one technology, torrefication of biomass pellets. सर इसमें क्या करते हैं कि स्टीम की प्रेजेंस में उसको मतलब उसका मॉइस्चर रिमूव करके उसको कोल टाइप की प्रॉपर्टी में कन्वर्ट हो जाता है, इसको टोरीफैक्शन बोलते हैं, और इसके द्वारा इसकी डेंसिटी काफ़ी बढ़ जाती है. तो ये जो ट्रांसपोर्टेशन कॉस्ट है सर, इससे कम हो जाएगी. और इसमें एक दूसरा मॉडल ये भी है कि जो प्लांट के आसपास 50 किलोमीटर का रेडियस है, इफ़ वी डेवलप द पेलेट्स, if we means collaborate with the farmers there, and within the 50 kilometer radius we developed a chain, economy and supply chain, and along with this torrefaction technology, तो इन दोनों चीज़ों से सर काफ़ी कॉस्ट कम हो सकती है इसका बायोमास पेलेट्स का. ये काफ़ी मतलब फार्मर्स की इनकम भी बढ़ सकती है और हम लोग अपना कार्बन क्रेडिट और कार्बन कोल का कंजम्पशन भी कम कर सकते हैं.
But thing is that wherever our plants are available nearby in 50 kilometer radius, that raw material may not be available to that extent.
सर इसमें मतलब ये है कि स्टडी करके और उसको फार्मर्स के साथ, अभी क्या है सर, जागरूकता की भी कमी है थोड़ा, फार्मर्स को भी उतना, क्योंकि क्या है सर, फार्मर्स के पास विंडो बहुत कम है. ही हैज़ टू क्लीन अप द लैंड एंड ही हैज़ टू गो फॉर द नेक्स्ट क्रॉप. अगर उसको मतलब समय लगेगा तो वो जलाना शुरू कर देता है या फिर ही डजेंट हैज़ दैट मच रिजर्व। स्मॉल फार्मर्स के पास में उतना रिजर्व नहीं है कि उसको कटिंग करेगा, उसको लोड करेगा, उसको भेजेगा पैलेटाइजेशन प्लांट में। तो ये पूरा एक मतलब एक कॉन्ट्रैक्ट टाइप का दे करके एनटीपीसी से प्री मतलब पहले ही स्टेज पे कॉन्ट्रैक्ट करके उन पेलेट्स को कलेक्ट करके फार्मर्स को एश्योरेंस दे करके कुछ मतलब पार्टनरशिप मॉडल टाइप का बनाने की इसमें ज़रूरत है सर। इसमें काफ़ी मतलब स्कोप है और काफ़ी स्टडी इसमें हो भी रही है सर इस तरह से। जैसे बायोमास बैंक बना के या फिर कुछ मतलब लोकल लेवल पे कोलैबोरेशन करके, जो मान लीजिए जैसे ओला टैक्सी है सर, उस तरह से यदि गांव के स्तर पे कुछ ट्रैक्टर या मतलब टैक्सी वगैरह जो मतलब स्पेयर ट्रैक्टर्स वगैरह हैं फार्मर्स के, उनको ऑड आवर्स में यूज़ करके ट्रांसपोर्टेशन के लिए, और लोकल में जो खाली पड़े प्लॉट्स हैं उनको बायोमास बैंक्स टाइप से बना करके, और एक मतलब जैसे अमूल का कोऑपरेटिव मॉडल है, इसी तरह का कुछ बायोमास का भी मतलब एक गांव के स्तर पे बायोमास प्रोडक्शन का एक कोऑपरेटिव मॉडल बना के बायोमास को मतलब पूरा एक इंफ्रास्ट्रक्चर डेवलप करने की ज़रूरत है सर, और इसमें बहुत पोटेंशियल है सर। थैंक यू सर।
ओके, थैंक यू। एनी क्वेश्चन? वन क्वेश्चन प्लीज, जल्दी बोलिए, बिकॉज टाइम इज प्रीशियस।
ये बायोमास पेलेट्स जो बात करें सर, इसका हम लोग भिलाई में भी वी हैव ऑर्डर्ड ऑलरेडी 200 टन्स ऑफ बायोमास पेलेट्स। तो हम टेंडरिंग कर रहे थे, वी हैव स्पोकन टू मेनी वेंडर्स, तो उसमें कई सारे वेंडर्स ऐसे बोल रहे हैं कि मतलब दे हैव नॉट कोटेड इन आवर इनिशियल टेंडर बिकॉज ऑफ द क्वांटिटी इज़ वेरी लेस। लेकिन हम जो 7 साल कॉन्ट्रैक्ट करने वाले हैं, दे आर विलिंग टू एस्टैब्लिश अ सेपरेट प्लांट नियर आवर रेडियस इफ दे आर गिवन द कॉन्ट्रैक्ट. So that will reduce the transportation cost to large extent, provided they get a long-term contract of around 7 years. So then we may expect the rate to come.
अभी एक्चुअली वही कॉन्फिडेंस लेवल नहीं आया सबका, इसलिए यह होता है अभी इनिशियली फेज में। मे बी इन टाइम टू कम इट विल स्टेबलाइज। अगर लोगों का
I know at least 3 or 4 vendors, they have, if they get the 7-year contract, then they are ready to establish a plant near our vicinity.
Okay. Okay, thank you very much. इधर ही ऊपर ले आएंगे।
Thank you, sir, for revisiting the whole session. Now I request session chairman Ray sir to kindly felicitate the participants of this session. Shri M.S. Karthik sir and Shri Srinivas Konga. Shri Amit Pandey and Shri Sandeep Patel. Shri P.K. Gupta and Shri Vikas Kumar. Shri Arvind and Shri Vinay Pathak. Shri Amit Kumar and Shri Aditya Kanduri. Shri Vikas Jain and Madam Asamriddhi Singh. Now I request CEO sir to felicitate the session chairman.
Thank you very much.
We will move to the last session of today's meet, and I request Shri Kameshwar Jha sir to preside this session. Jha sir has served NTPC for a long time. He has served in Kahalgaon in mechanical erection department, in project construction, thereafter mechanical erection at Bad, Farakka, and he was there in project management at CC Scope and project construction at Darliparli. He was BUH in HURL headquarters, and thereafter he is presently serving NSPCL Durgapur as a head of plant. In this session there will be total 5 number of papers. First paper will be from Bhilai Steel Plant. The topic is augmentation of reliability and augmentation of reliability and availability of CDCP boilers to enhance dry coke production of COB11 and electric power generation at back pressure turbo generator of Bhilai Steel Plant through innovative in-house modification. The paper will be presented by Shri Satyavir Kumar and Swaraj Zodi. Shri Satyavir Kumar is a mechanical engineer and he has more than 8 years of experience in DM plant and coke dry cooling plant of power and blowing station. Shri Swaraj Jodi is also a mechanical engineer. He is serving in BSP since 2014 and has more than 8 years of experience in DM plant turbo generators. Now I invite Shri Satyavir and Shri Swaraj for their paper.
आप सभी को मेरा नमस्कार। मैं स्वराज जोड़े और मेरे साथी सत्यवीर कुमार, हम स्टील अथॉरिटी ऑफ इंडिया भिलाई स्टील प्लांट के पावर एंड ब्लोइंग स्टेशन डिपार्टमेंट से आए हुए हैं। आज का हमारा जो टॉपिक है वो है कोक ओवन बैटरी 11 के ड्राई कोक प्रोडक्शन और बीपीटीजी के इलेक्ट्रिकल पावर जनरेशन का प्रोडक्शन का एनहांसमेंट विद द हेल्प ऑफ इनोवेटिव मॉडिफिकेशंस इन सीडीसीपी बॉयलर्स।
I am Satyavir Kumar. I did my BTech in Mechanical Engineering from Bhagalpur College of Engineering, Bhagalpur, and Certificate of Proficiency as a Boiler Operation Engineer from Government of Chhattisgarh. I am a certified manager. I joined SAIL BSV in 2014.
Hello, I am Swaraj Zode. I did my engineering in mechanical from Government Engineering College, Jabalpur, PG Diploma in Thermal Power Plant Engineering from NPTI Nagpur, and Masters in Advanced Production Specialization in Robotics from NITTR Bhopal. And my working experience also in the automobile industry. I joined SAIL in 2014, as already told that I have experience in DM plant, turbo generator, back pressure, turbo blower, and now in boilers.
जैसा कि मेरे कलीग स्वराज ने बताया, हम लोगों ने जो ड्राई कोक प्रोडक्शन बैटरी 11 और पावर जनरेशन बीपीटीजी में जो मॉडिफिकेशन किए हैं वो हम लोग बेसिकली WHRV वेस्ट हीट रिकवरी बॉयलर में किए हैं। भिलाई स्टील प्लांट में टोटल 11 बैटरी है। बैटरी 1 to 10 जो कि पुरानी बैटरी है उसमें जो कोक को ठंडा करने का टेक्नोलॉजी है वो वेट क्विंचिंग है। इस वेट क्विंचिंग प्रोसेस में हम लोग जो कोक वन बैटरी से हॉट कोक रिसीव करते हैं जिसका टेम्परेचर 1100 डिग्री सेल्सियस होता है, उस हॉट कोक को बकेट में रिसीव करके हम लोग क्विंचिंग टावर में ले जाते हैं। क्विंचिंग टावर में वाटर से उसको ठंडा करते हैं और उसके हीट को एटमॉस्फेयर में रिलीज कर देते हैं। जबकि जो ड्राई क्विंचिंग टेक्नोलॉजी है जो बैटरी 11 के साथ है, इस प्रोसेस में हम लोग इनर्ट गैसेस मेनली नाइट्रोजन जिसका कि कंपोजिशन रहता है नाइट्रोजन 70 to 75%, CO 8 to 10%, CO2 10 to 15%, हाइड्रोजन 2 to 4% और ऑक्सीजन 1% मैक्सिमम। इस कंपोजिशन के फ्लू गैस को जो हॉट कोक हम लोग रिसीव करते हैं उसको चैम्बर में चार्ज करते हैं और उस फ्लू गैस से उस हॉट कोक से हीट रिसीव करते हैं और उस फ्लू गैस को ले जाके बॉयलर में ठंडा करके वहाँ से स्टीम जनरेट करते हैं। उस स्टीम से हम लोग 4 मेगावाट इलेक्ट्रिसिटी जनरेशन के लिए बीपीटीजी को भेजते हैं। CDQ कोक ड्राई क्विंचिंग, जैसा कि मैं बताया कि दो टेक्नोलॉजी है, एक वेट क्विंचिंग है और एक ड्राई क्विंचिंग है। वेट क्विंचिंग टेक्नोलॉजी से जो कोक रिसीव होता है उस प्रोसेस में जो कोक का स्ट्रेंथ होता है वो कम होता है क्योंकि उसमें सडन कूलिंग करते हैं वाटर से, और ये ड्राई क्विंचिंग प्रोसेस में कोक का ग्रेजुअल कूलिंग होता है, इसमें कोक का स्ट्रेंथ अच्छा मिलता है। साथ ही मॉइस्चर कंटेंट जो वेट क्विंचिंग टेक्नोलॉजी है उसमें 3 to 4% होता है और ड्राई क्विंचिंग टेक्नोलॉजी में कोक में मॉइस्चर कंटेंट 0.1 to 0.2% होता है, जिससे ब्लास्ट फर्नेस में कोक रेट कम होता है, प्रोडक्टिविटी ब्लास्ट फर्नेस का बढ़ता है। साथ ही जो वेट क्विंचिंग टेक्नोलॉजी है उसको ठंडा करने के ड्यूरेशन में बहुत सारे टॉक्सिक गैसेस साइनाइड, सल्फाइड, फिनॉल जैसे कंपाउंड एटमॉस्फेयर में रिलीज होते हैं और ये ड्राई क्विंचिंग टेक्नोलॉजी है, एक कंप्लीट सर्किट में काम होता है। इस प्रोसेस में कोई हैजार्डस गैस एटमॉस्फेयर में रिलीज नहीं होता है। CDCP कोक ड्राई कूलिंग प्लांट, ये भिलाई स्टील प्लांट में 7 MT मॉडर्नाइजेशन एंड एक्सपेंशन प्रोडक्ट के अंतर्गत आया है। इस प्रोसेस में हम लोग के यहाँ बैटरी 11 आया है जिसमें टोटल 67 नंबर ऑफ ओवन्स हैं और इसमें 4 CDCP बॉयलर और करस्पॉन्डिंग CDCP चैम्बर है और एक 4 मेगावाट का इलेक्ट्रिसिटी जनरेशन के लिए BPTG आया है।
जैसा कि आप इस डायग्राम में देख रहे हैं, ये है बॉयलर चैम्बर का अरेंजमेंट। इसमें राइट साइड में आप बॉयलर देख रहे हैं, लेफ्ट साइड में चैम्बर देख रहे हैं। इस चैम्बर में टॉप साइड से हॉट कोक को चार्ज किया जाता है। ये हॉट कोक धीरे धीरे करके नीचे तक आता है और क्विंच कोक के रूप में बाहर निकल के आता है। इसमें मिल फैन जो आप देख रहे हैं ये फ्लू गैस को कंटिन्यूसली फोर्सफुली सर्कुलेट करता रहता है। इसमें जो ग्रीन कलर के जो आप एरोज देख रहे हैं वो फ्लू गैस का है। ये फ्लू गैस हीट लेकर बॉयलर में जाता है और इसी बॉयलर से स्टीम जनरेशन होता है। हम अपने CDCP बॉयलर के स्पेसिफिकेशंस की बात करते हैं। हमारे यहाँ कुल 4 बॉयलर हैं जिसमें थर्मेक्स के द्वारा बनाया हुआ बॉयलर है। हर एक बॉयलर की कैपेसिटी 25 टन पर आवर है, प्रेशर 66 kg है, टेम्परेचर 500 डिग्री के आसपास होता है। अब हम अपने प्रॉब्लम्स जो हमने इस पेपर के माध्यम से हम बताना चाह रहे हैं, कुल मिलाकर हमने 5 प्रॉब्लम्स को आइडेंटिफाई किया है अपने CDCP बॉयलर्स में। हम अपने पहली प्रॉब्लम की बात करते हैं, फ्रीक्वेंट ट्यूब फेलियर ड्यू टू थर्मल शॉक्स। मेनली इसमें जो फ्लू गैसेस होती हैं जो कि कूलिंग चैम्बर से एंटर करके CDCP बॉयलर्स में जाती हैं, उसके टेम्परेचर का सडन फ्लक्चुएशन होता है जिसकी वजह से ट्यूब फेलियर्स होती हैं। नॉर्मली देखा जाए तो टेम्परेचर का फ्लक्चुएशन 50 डिग्री सेल्सियस पर आवर का एडमिटेड है, परंतु ये जो आप देख रहे हैं इसमें 30 से 40 मिनट के अंदर में 200 से 300 डिग्री का टेम्परेचर फ्लक्चुएशन हो रहा था। इसका मेनली प्रॉब्लम ये था कि मिल फैंस जो थे वो सडनली स्टार्ट या स्टॉपेज या रीस्टार्ट किया जा रहे थे, जैसा कि आप इस थर्मल स्टेबिलिटी के टेबल में देख रहे हैं कि बॉयलर 1, 2, 3, 4 इनके टेम्परेचर वेरिएशंस हो रहे थे जो मोर देन 50 डिग्री सेल्सियस पर आवर था।
जैसा कि मेरे कलीग ने बताया कि जो फ्रीक्वेंट जो ज्वाइंट फेलियर होता है उसका मेन रीजन था वो फ्लक्चुएशन था फ्लो गैस का। इसके लिए हम लोगों ने अभी जो रनिंग बॉयलर रहता है उसका बॉयलर इनलेट फ्लो गैस टेम्परेचर को एवरी शिफ्ट में उसको एनालिसिस करते हैं और कंसर्न चैम्बर शिफ्ट इंचार्ज से डिस्कशन करके करेक्टिव एक्शन लेते हैं। और जो फ्लो गैस टेम्परेचर वेरिएशन का एक मेन रीजन था वो डाउन स्ट्रीम कन्वेयर बेल्ट का फ्रीक्वेंटली स्टॉपेज था। उसके लिए ब्लास्ट फर्नेस के शिफ्ट इंचार्ज से बात करके उसको भी हम लोग मिनिमाइज किए हैं। और फ्रीक्वेंट मिल फैन के स्टॉप और स्टॉपेज के लिए और रीस्टार्ट के लिए हम लोगों प्रॉपर प्लानिंग करके मिल फैन को स्टार्ट और स्टॉप करते हैं और इनलेट गाइड वेन से उसका टेम्परेचर फ्लक्चुएशन को मिनिमाइज करते हैं। अभी
अब हम अपनी सेकंड प्रॉब्लम की बात करते हैं, रिपीटेड फेलियर ऑफ द स्क्रीन ट्यूब्स। ये कंसर्न हमारा सितंबर 2021 तक रहा। इसमें मेनली कोक प्रोडक्शन और पावर जनरेशन का लॉस हुआ। ध्यान देने वाली बात यह है कि स्क्रीन ट्यूब के लीकेजेस की होने की वजह से जो लीक्ड वाटर था वो कोल्ड डस्ट से मिक्स हो जाता था और चोक फिन ट्यूब इकोनोमाइजर्स को चोक कर रहा था, जिसकी वजह से जो हमारा हीट ट्रांसफ़र था वो बैडली अफेक्ट हो रहा था। इसमें जो स्क्रीन ट्यूब्स का जो लीकेजेस हो रहे थे वो स्ट्रेसेस की वजह से हो रहे थे। इसमें मेनली दो रीजंस थे। पहला रीज़न जो था इनलेट डक्ट, जिसका वजन लगभग 16 मेट्रिक टन था, जो कि डायरेक्टली वेल्डेड था स्क्रीन ट्यूब से। दूसरा, जो एक्सपांशन बेलोस थे उनके आसपास की जो रिफ्रैक्टरी मटेरियल्स थे वो सॉलिडिफाई होकर इसको मूवमेंट नहीं दे रहे थे।
इसके सॉल्यूशन के लिए जैसे मेरे कलीग ने बताया कि जो बॉयलर इनलेट डक्ट जो कि चैम्बर और बॉयलर को कनेक्ट कर रहा था वो डायरेक्ट आके स्क्रीन ट्यूब्स पे वेल्डेड था। इस प्रॉब्लम के लिए अभी हम लोगों ने जो टॉप और बॉटम में स्क्रीन ट्यूब्स के ऊपर स्लीव इंसर्ट किए हैं और अभी बॉयलर इनलेट डक्ट को डायरेक्ट ट्यूब के ऊपर नहीं स्लीव के ऊपर वेल्डिंग करते हैं और इस प्रॉब्लम से सॉर्ट आउट किए हैं। साथ ही साथ हम लोगों का जो मोर लीकेज एरिया था वो वेल्डिंग ज्वाइंट था, जो कि वेल्डिंग ज्वाइंट डिजाइन में रिफैक्ट्री के अंदर इम्बेडेड रहता था। अभी हम लोगों ने स्क्रीन ट्यूब्स के लेंथ को इंक्रीज किया है और टॉप वेल्डिंग ज्वाइंट का जो कि रूफ ट्यूब से है उसको टॉप डक्ट के ऊपर और बॉटम का वेल्डिंग ज्वाइंट स्क्रीन ट्यूब्स का जो वाटर वॉल के साथ है उसको बॉटम डक्ट के नीचे लाया है और वेल्डिंग ज्वाइंट को रिफैक्ट्री से फ्री किए हैं। साथ ही जो बॉयलर इनलेट डक्ट था जिसका वेट 16 मेट्रिक टन था, उसके सपोर्ट के लिए कोई सपोर्टिंग अरेंजमेंट का व्यवस्था नहीं थी। उसके लिए हम लोगों ने इन हाउस रिसोर्स से स्प्रिंग हैंगर सपोर्ट फैब्रिकेट किया है और उसको प्रॉपर लोडिंग किए हैं बॉयलर इनलेट डक्ट को। साथ ही साथ एक्सपांसन ज्वाइंट का एक्सपांसन के लिए OEM से कंसल्ट करके लिए प्रॉपर एक्सपांसन गैप बनाए हैं और जो एक्सपांसन मटेरियल है एज पर OEM गाइडलाइन से उसको फिलअप किए हैं।
हमारे थर्ड प्रॉब्लम था इनएडिक्वेट रिफ्रैक्टरी हीटिंग सिस्टम। इसमें जो चैम्बर का कैपिटल रिपेयर होता था उसमें नया रिफ्रैक्टरी मटेरियल डाला जाता था जो कि 800 टन्स का होता था। इसमें ध्यान देने वाली बात यह है कि जो इसकी हीटिंग होती है वो एक नॉर्मल हीटिंग नहीं है। इसको हीट करने के लिए रिवर्स स्टीम प्रोसेस हम यूज़ करते हैं, जिसमें हमारा प्रोसेस स्टीम को लेकर हम बॉयलर ड्रम के अंदर लेके जाते हैं और वही उसका टेम्परेचर बढ़ाता है। इसमें जो मिल फैन का इनलेट है उसमें 130 डिग्री सेल्सियस के आसपास टेम्परेचर होना चाहिए, लेकिन ये टेम्परेचर अचीव नहीं हो रहा था, लगभग 94 डिग्री सेल्सियस के आसपास आ रहा था। इसको बढ़ाने के लिए हमने STG स्टीम टर्बो जनरेटर 4, उसमें हमने 25 मेगावाट का वो जनरेटर है, उसका हमने 5 मेगावाट जनरेशन कम किया और उसकी जो स्टीम थी, जो प्रोसेस स्टीम थी, उसको डाइवर्ट करके हमने अपनी तरफ लेके आए CDCP साइड, जिसकी वजह से हमारा टेम्परेचर तब भी 105 डिग्री सेल्सियस तक ही बढ़ रहा था। यह एक सिंपल प्योर प्रोडक्शन लॉस है और इसका मॉइस्चर कंटेंट होने की वजह से एक मेजर एक्सप्लोशन हो सकता था।
रियली ये हम लोग के लिए एक बहुत ही चैलेंजिंग जॉब था, क्योंकि हम लोग जो कैपिटल रिपेयर में रिफैक्ट्री में अप्रॉक्सीमेटली 800 टन्स का रिफैक्ट्री चेंज किए थे और उसका मॉइस्चर रिमूव करना एक टेक्निकल रिक्वायरमेंट है, नहीं तो अपना एक्सप्लोजन का चांसेस रहते हैं। इसके लिए हम लोगों ने साइट विजिट किया और साइट विजिट से इफेक्टिव हीटिंग के लिए हम लोगों ने जो मेरा रनिंग बॉयलर था और जिस बॉयलर का रिफैक्ट्री ड्राई आउट करना था, दोनों बॉयलर के सुपर हीटेड वेंट को कनेक्ट किए और हम लोगों ने रिवर्स स्टीम चार्ज किया और इस प्रोसेस से, जो कि हम लोग को नॉर्मल हीटिंग के लिए हम लोग 20 से 25 डेज के लिए प्लान किए थे, 8 to 10 डेज में रिवर्स हीटिंग से हम लोग का रिफैक्ट्री ड्राई आउट हो गया और जो डिजायर्ड टेम्परेचर था 130 मिल फैन इनलेट में, उसको भी हम लोग अचीव किए और इस प्रोसेस से जो हम लोग 5 मेगावाट रिड्यूस के STG में उस मेगावाट को नॉर्मलाइज किए और बॉयलर को 10 डेज पहले हम लोग एवेबिलिटी करा के बॉयलर का एवेबिलिटी इन्हांस किए।
हमारा फोर्थ प्रॉब्लम था हाई डाउन टाइम ऑफ द बॉयलर फीड पंप सक्शन स्ट्रेनर क्लीनिंग। जैसा कि आप सभी जानते हैं कि बॉयलर फीड पंप का सक्शन स्ट्रेनर क्लीन करना एक टीडियस जॉब है, जिसके लिए फ्लैंज ओपन करके उसके जैकिंग, उसका सक्शन पाइपलाइन का जैकिंग करना, उसको डिसमेंटल करना, उसका क्लीनिंग करना और दोबारा उसको फिटिंग करना, इसमें हमारा 1 घंटे से ऊपर समय लग रहा था। कुल मिलाकर हमारे पास में 3 बॉयलर फीड पंप्स हैं, जिसमें से यदि कोई भी बॉयलर फीड पंप का आउटेज आता है या फेलियर होता है, उस कंडीशन में हमारा प्रोडक्शन लॉस हो रहा था।
इस फोटो के माध्यम से हम लोग देख सकते हैं बिफोर मॉडिफिकेशन और ये आफ्टर मॉडिफिकेशन है। इस मॉडिफिकेशन में हम लोगों ने इन सिटू बॉयलर फीड पंप, इस मॉडिफिकेशन में हम लोगों ने बॉयलर फीड पंप का इन सिटू एक्सटर्नल क्लीनिंग का प्रोविजन किए हैं। इसमें हम लोगों ने एक एसओपी बनाए हैं और एक कंप्रेस्ड एयर लाइन डाले हैं। जब भी हम लोग को बॉयलर फीड पंप का एक्सटर्नल क्लीनिंग करना होता है तो हम लोग बॉयलर फीड पंप के सक्शन वाल्व को बंद करते हैं, साथ ही साथ कंप्रेस्ड एयर लाइन को और जो बॉयलर एक्सटेंडर का ड्रेन लाइन है उसको ओपन करते हैं। जो फॉरेन मटेरियल रहता है कंप्रेस्ड एयर से एजिटेट करके ड्रेन के थ्रू निकाल देते हैं और इस प्रोसेस से मेरा बॉयलर फीड पंप 10 to 15 मिनट्स में एक्सटर्नल क्लीनिंग करके रेडी हो जाता है और सेफ्टी एस्पेक्ट से भी बहुत ही हेल्दी है।
अब हम बात करते हैं फिफ्थ प्रॉब्लम की, फेलियर ऑफ वेल्डेड जॉइंट्स ऑफ CBD कंटिन्यूस ब्लोडाउन एंड इंटरमीडिएट ब्लोडाउन लाइंस। CDCP बॉयलर ड्रम जो है और उसकी जो पाइपिंग का जो डिज़ाइन किया गया है उसका एक्सपेंशन वर्टिकली अपवर्ड साइड है, जिसकी वजह से CBD और IBD पाइपलाइंस को किसी भी तरह का अपवर्ड एक्सपेंशन के लिए प्रोविज़न नहीं दिया गया था। इस कारण से जो वेल्डेड जॉइंट्स थे उनका रिपीटेड फेलियर हो रहा था और जो बॉयलर है उनका अनडिज़ायरेबल फोर्स आउटेज हो रहा था।
ये जो फ्रीक्वेंट IBD और CBD वेल्डिंग जॉइंट पे फेलियर हो रहा था, इसके प्रॉब्लम को हम लोगों ने एनालिसिस किया और इसमें हम लोगों ने कंपनसेटर बनाया यू बेंड टाइप का। कंपनसेटर हम लोगों ने CBD और IBD लाइन में इंस्टॉल किया। आफ्टर इंस्टॉलेशन हम लोगों ने पाया कि जो मेरा वेल्डिंग जॉइंट फ्रीक्वेंट फेलियर हो रहा था वो कम्प्लीटली एलिमिनेट हो गया।
अब हम अपने कंक्लूजन और रिजल्ट्स की बात करते हैं। हमारा इनोवेटिव, प्रॉम्प्ट और सस्टेनेबल इन हाउस इंटरवेंशंस और मॉडिफिकेशंस की वजह से हमारा जो कोक प्रोडक्शन है वो रिलायबल और कंटिन्यूस हो गया। साथ ही जो हमारा BPTG बैक प्रेशर टर्बो जनरेटर का जो पावर जनरेशन था वो वापस बढ़ गया और जो उसकी वजह से जो प्रोसेस स्टीम का जो कम हुआ था वो भी हमारा अब कंसिस्टेंट और नॉर्मल सप्लाई हो गया है। ये हमारे रेफरेंसेस हैं। थैंक यू।
Thank you, sir. Now, our next paper is from Tata Power on the topic O&M best practices adopted in Maithan Power Limited. The paper will be presented by Shri Ravi Jeti and Shri Ranjan Das. Ravi Jeti is Group Head Operations, Maithan Power Limited, and Shri Ranjan Das is Senior Control Desk Engineer Operations at Maithan Power. I invite to present their paper, sir.
Good evening, all the dignitaries and the participants in this forum. Myself Ravi Shankar Jeti, the Senior Manager Operation, and I have my colleague Ranjan Das, who is Manager in Operation. On behalf of Maithan Power Limited, I would like to thank NSPCL for giving this opportunity to share our journey towards the flexibilization and achieving some operation excellence through best O&M practices. So moving forward, I would like to brief about Maithan Power Limited. It is the first successful joint venture company between Tata Power and DVC, where Tata Power hold the 74% majority stake and DVC holding the 26%. And we are having the fully PPA, that is along with DVC, West Bengal State Electricity Board, TPTDL and Kerala. Our total installed capacity is 1050 megawatt, each unit of 525 megawatt. The first unit was commissioned in the year of 2011 and second unit in the year of 2012. Many are the achievements we have already done, but in this forum, I would like to proudly say that our unit is the first in the India to achieve 35.9% MTL operation in the journey of flexibilization. And we are the second one in demonstrating the 40% MTL operation after the NTPC Dadri. So in this presentation, we'll take you to the journey of our flexibilization and not only achieving the flexible operation, but also stabilize that operation and sustain that, and getting the confidence to operate the unit at 40% or below 40% is the more challenging area for us. So as from the very beginning in the many presentation, the power scenario challenges are demonstrated. So I don't like to deep down it. Just to overview that main challenges in this sector is to flexibilization the operation because of fast penetration of RE. So as RE is penetrating in a faster way, so thermal demand is getting back down generally in the peak off-peak hours. So in that case, we have to revise our MTL operation, that is minimum technical limit operation, which earlier used to be at 70%. At the same time, we have to reduce the load at a faster rate. So we need to ramp up the unit at a 1%. So for MPL, it stands around 150 megawatt per block. So 15 minutes, we have to reduce the load 150 megawatt. So in our case, we are from full load to MTL operation comes by 45 minutes, means in 3 blocks. At the same time, we have to take care of the grid security and integrity. So operational reliability at 40% is very much important, and also we have to take care of the equipment availability and reliability in the journey of flexibilization. In this presence of challenging environment, we are putting a strong footprint. In this bar graph, you can clearly see that in the year of FY18, where the central thermal average PLF stands at 72, here at MPL standards 81. And the subsequent year, we are always leading the chart. And we are even introduces the RRS as SCED because we are the ISGS plant. So we are very much bound to comply the CERC norms. And as you all are aware that in the coming days, CERC norms are going to be very strengthened. In 1924 CERC norms, it is asking for 1% ramp at least and 55% MTL operation for within the 1 year, which we have already achieved, and for the next 5 years we have to achieve 40% MTL operation. So for any big achievement, we need to be prepared well advanced stage. So we started our journey in the year of FY19, where our MTL used to be at 600 megawatt, and as we are fully PPA, so our schedule was depending on the beneficiary demands. So that time we were managed to our MTL at 600 megawatt, but change in regulation and inception of SCD and RRS force us to drop down the MTL to 55%. So FY20, we first time reduce our load to 55%, and thereafter our journey started for flexibilization on the lower side more. Just to add in this point, RRS and SCD is the two features which are introduced by CEA in the year of FY20, where irrespective of our beneficiary schedule, our load is governed by the NLDC side. So if my schedule is full, although grid security and considering the grid constraint, they can reduce our load or vice versa. On the second aspect, once we achieve the 55% load in the year of FY20, our next target was to achieve 1% ramp. Earlier our ramp was 0.5%, so we have to achieve double. That means 5.25 megawatt per minute, or rather say 78 megawatt per block. So we achieved that in the year of FY21, and subsequent year in the FY20, the new regulations comes in service where AGC implemented, and we are the first in the sector who has implemented 1% AGC even before the NTPC. So nowadays we are complying the 1% ramp of AGC. Just to make you aware that AGC is the system is automatic generation control, irrespective of load, depending on the frequency. This is the secondary control where the NLDC directly gives command to our unit to change the load. So we don't have any control for the load variation. We just tune the system such a way so that our system can manage these changes. So for any instant, if our load is 525 megawatt, NLDC has full right to reduce it by 140 megawatt within a time block. So that things are happening and we are managing it quite well. Now moving forward to the more flexibilization towards 40%. Although we have taken target in the FY23, but we have already completed, it's demonstrated on the FY22. But not only the demonstrating it, we have to sustain it and we have to stabilize it. So we are focusing on more on that. Our present scenario MTL is 55%, but as and when we are getting the opportunity to shut down the unit, we used to take this opportunity to run the unit at 40% to boost up the confidence of the desk engineers, as well as to collect the data at 40% operation, so that in future we should be ready for that. This is our AGC journey. The good part of this AGC that any change in megawatt of load, the CRC, or better say PGCL, gives us the 50% benefits for per megawatt. So this was the challenge. This was a challenge for us to achieve the load. But once we achieved the load, it converted an opportunity for us to earn more in DSM. Now, looking back to in the FY22, where we achieved the PLF 81%, which is the best since inception. Then we have achieved the low SOC 0.11, which is also best for since inception. Our PLF stands at 93%. Forced outage also reduced to 1.75%, and APC stands at 5.75%. Now this flexibilization journey, we have already completed it in the year of 2021, where our plant was the second one which was selected by CEA for demonstrating the 40% operation in collaboration with IGEF, Indo-German Energy Forum, and Siemens. Here the notable part is that when we go for a MTL operations less than 55%, the main constraints come from boiler side, that is flame stability. So we have to take care of the flame stability, and second part is drum level control. Other than that, there is some constraints of mainstream reheater temperature control, but that can be taken care easily rather than combustion. So combustion part, we have installed some variable orifice for the particular coal mill, where we can adjust the coal flow of the burners individually according to the furnace condition. So in case if we feel that combustion is not proper or distribution through the coal burners are not equal, we can online change the burner orifice positions to adjust the coal flow, and there is an online coal flow measurement for all the burners, which helps us to get better idea about the combustion, because combustion is the foremost part for the MTL operation. So we did it. Then we also adjusted the AC/DC, which also is a crucial part for better flame stability. And then also we go for a better coal, because here at Maithan our plant is designed for 4500 GCV, but we used to get at 3800 to 4200 GCV. So for this test we specially procured 44,000 GCV coal, so that flame stability can be maintained, because we are going for this at the first time. So in this journey we gradually reduce the load, and at 40% we go for 3 mill operations, where 1 mill was on fully our control for fuel part, and 1 BFP was taken out of service, single BFP was in service for the drum level control, and rest all loops were kept in auto. For CNI part, all the loops and all those things, we didn't have that data, because BHEL doesn't provide data below 60%. All the HBD diagrams and all the data are available for 60%. So we started collecting data prior to this operation. Whenever we start up or shut down the unit, we used to collect data from 40%, 30% operation, so that we can get a frame of the different parameters, so that which should be at that load. Second challenge we faced, that at 40% MTL operation, your extraction stream for the TDVFP become very lean. So many times it doesn't enough to drive the turbine. So for that we had a provision from CRH extraction, so that we commissioned, and successfully we drive the TDVFP on CRH extraction, and there is a swing changeover from CRH to extraction and vice versa during load changes. Here in this PPT, you can see that first top one is the load of 209 megawatt, which is 40% MTL for MPL, 1 unit. And the second load is 188, which is equivalent to 36% of MTL operation, which is first in India. Now moving forward, achieving this operation of 45% and going beyond the 35% needs to stabilize it. To stabilize it, we need some data, and from that data we have modelized some models where we are excellencing those parameters to achieve better efficiency and better performance at that load. So for that point of view, we are having different model based on AI/ML. We are basically involving artificial intelligence and machine learning to optimize our operation, because manual intervention is no more going to help us. So in this journey, my friend Ranjan Das will give you brief. Ranjan.
As far as flexibilization is a concern for today, there are various pros and cons is there for that, and mainly the cons are the change in heat rate, change in APC. The heat rate is increasing side, the APC is on the increasing side after we getting load after 55%. The main KPI we shall check in daily operation parameter. In every plant we check this parameter, that emission, force outage, heat rate, SOC, availability, startup consumption and auxiliary power consumption. This is the performance KPI. This is maintained in every power plant. So we for heat rate improvement, first we have to know what is the loss component from the heat rate. So if we don't know what is the loss component, then how we target it. So we made a real-time model for heat rate, where you can see that what is the deviation from the main steam temperature, what is the deviation from the HRS temperature, what is the deviation from vacuum. We check, the disk operator can check in real-time basis, and they can take action according to that. We implicate this model in the DCS system, and in the DCS system we made a FMEA as based on FMEA, this failure mode effect analysis, through which for what reason the vacuum is deteriorating. There is a several action, there is several points is there. So the operator check what is the deviating parameters. Next, we install Sonic Soot Blur, as already shared in the earlier presentation, that Sonic Soot Blur as the Sonic Soot Blur for the APH soot blower. This is done by compressed air system. We reduce auxiliary steam requirement for these soot blowers, and we go for tire wise soot blowing. For the BHEL, they provide the soot blowing operation as we can do as a blind. We can go in every tire, in every shift. Now we are checking the DT, the differential temperature in the platent zone, in the economizer zone, or in the reheater zone. Where the DT is low, then there is a chance of the outlet temperature is high. Then according to that, we changes our soot blowing system, and we do the soot blowing according to that. Recently we are changing our cooling tower fields, which are giving the improvement in the vacuum system. We have done condenser tube cleaning with outage. Further, we in-house we check the mill operation. As coal is not our control, so coal we have to check what are the parameter, how the flue gas temperature is changing in different coal situation. Our specific coal consumption is varying from 0.55 to 0.7. So in different situation, in different mill combination, the superheater temperature or heater temperature or the flue gas temperature is changing. So we check that if we use the gap mill operation, then it helps to reduce the reheater metal temperature. Then we implement a bias system for reheater metal temperature control. As in 2018 or 17 to 18, that we faced many forced outage due to reheater metal excursion. So we change in the logic in the burner till control, where burner till not only check that the reheater steam temperature, it also will check the metal temperature in transient operation. Next, we are preparing the Python-based model for different load condition, because the load is continuously changing due to AGC. So we are tracking the steam temperature, the main steam temperature, heater steam temperature, or vacuum in different load conditions. A toolkit is prepared on the historical data. So this toolkit is used to select what should be the mill combination, because when the coal parameter changes, then there should be the requirement of the change in the mill combination. So what in the last 2 years historical data, we are selecting at what temperature, at what mill combination, or what SADC condition, we got the best reheater temperature or reheater superheater temperature or metal temperature. We initially started within the Excel, but now we are going for a digital analytics program, because our company is now working as a 3D framework that's for digitalization program and for this decarbonization program. So digital analytics, some of the engineers are trained in the digital analytics program, and they are preparing this model where the mill combination will be given through this model, which will show which can be selected by the operator in the real-time basis for best reheater temperature, best superheater temperatures. That's why by this we can optimize the combustion optimization. For APC also going higher in 6.11. You can see that on the year of FY21, that time our PLF were low, around 69%. After that time, we take several steps for APC savings. We found that our CEP having some pressure margin, because we don't have CPU in our system. So we destage our CEP, all CEPs, and we reduced CEP's current from 153 amps to 120 amps for 4 CEPs.
Then for the MTL situation and the higher load situation, we optimize the coal mill operations. Coal mill, before we run maximum number of mills, because we found several coal pipe choking issue in different situation, but as we are running in continuous load changing situation, so that's why we found that in lower load sometimes higher mills, number of mills are running condition. So we go for minimum number of mills running in MTL conditions. We optimize our compressor power reduction. We reduced our PA header pressure from 780 to 750. We optimize our excess air O2. Hot oil makeup system usually we got from hot oil makeup, we got from the CST, condensed storage tank. There is a pump is there, so now we are taking this hot oil system for hot oil makeup as from gravity, not running the pumps. We interconnected our both unit HFO pumps, and now a single HFO pump is running. 4-way makeup also we taking from a gravity line, not starting the 4-way makeup pumps. Our plant lighting system all converted to LEDs, and air velocity system is very much power optimization potential is there in air velocity system. So the optimization through the optimization of number of blowouts. This is the predictive model that we are preparing, and this model gives us the different benchmark, different equipments benchmark parameters on APC. We take the data for all 6.6 kV equipments, and we analyze the last 3 years data, and we take a predictive model where this value we show, this will compare with the real-time parameter, and this will show the benchmark value. This is showing here the heat. This is a heat map for ID fan. Here we ID fan we compare all the data, analyze all the data with all boiler parameters like APS DP, flue gas DP of economizer section, flue gas DP of reheater section, and ID fan inlet pressure or excess O2. So we check what are the deviations, what are the correlation between ID fan current and what other parameter, other variables. So now we are checking the running real-time ID fan currents, FD fan currents, and this model show what is the previous benchmark parameter, and it will show what is the deviation, and according to that, this will show what is the prescriptive part. What is the deviation if it is APS DP or if it is higher excess O2, it will show. So the operator accordingly act on that. And this is the APC tracker we have prepared on the daily basis. We check the major contributor for APC. That is which are the variable parameters: the ID, FD, PA, MIL, CEP. This is the variable equipments in the normal power plant. So we check the equipment consumption from the benchmark value, and we check the all MIL power consumption, MIL specific energy consumption, and accordingly we act on that. For specifics, oil consumption and startup time optimization, this is the challenging part because in the initial stage our specific oil consumption is 0.39. Now we drop down to 0.1 ml per kilowatt hour. This HPT charging before startup of optimization for optimized coal optimization. This we will optimize before, as per conventional method. Normally we charge HPT after synchronization. After 200 megawatt we charge HPTers because we take extraction steam from turbine and extraction steam from CRH for HPT. But now we are taking HPT before synchronization and after opening the mainstream stop valve because it will help to increase the feed water temperature. We are charging both HPT 6A and 6B that the steam come from the CRH, and it will help to reduce the oil consumption from 49 to 44 kL, around 5 kL in every startup. This initiative we will take up from the German tower type boiler. For annual overhauling purpose, normally we are replacing our reheater coils, which are earlier is a T91. Now we are replacing with this is 345 because we face several BTL due to reheater sections. And now when we are changing the coils, when changing the economizer coils or reheater coils, that time the steam dumping is required for clean the coils. So earlier we normally, as this is power plant is a closed cycle, so the steam is in the earlier stage, the steam is going to the condenser, then the condenser extraction pump extract the water from the condenser and then goes to the boiler. Now we are taking makeup directly on the feed water cycle, directly in the dehydrator cycle, and we dump the water coming from the boiler after CEP. So the makeup oil consumption is reduced, the SOC also reduced, and it improved the steam quality also. Further, we are steam blowing the new coils outside the boiler before the boiler light up. It will also helps the improve the steam quality for faster and faster clearance of steam introduction in turbine. For cold startup, we are taking as per design. Normally, cold startup has been done with only oils in service, but now we are taking lower elevations mill to reduce the specific oil consumption. And early HP charging also I have already discussed. For startup and SOC reduction, we also introduce mill before and after synchronization early with checking the proper steam flow to fuel flow ratio, and the dehydrator and scap charging is a normal procedure. We are same way maintaining, and charging the HP heater before unit synchronization. This boiler startup curve we have been incorporated in the DCS, where while startup we are checking, this is the curve given by the BHL, the OEM. So we are checking during light up if how much we are deviating from the actual startup curve. So this will help during the startup, and this is the boiler startup optimization oil. For oil optimization, we have prepared this chart. Here it shows the timing for the every steps during the startup. When we take the HFO gun, when we take the HVLP bypass, when I take the PFN, and what time we open the stop valve. So this will help to check that the benchmark value. For forced outage, actually for the year from FY to 18 to 19, our heater metal temperature on the higher BTL from the heater metal temperature on the higher side. So to minimize that, we installed several number of thermocouples in the CRH and HRH areas to maintain the temperature from the DCS. We limit our metal temperature limit from 590x. Heater oxidation limit is 631. So before we maintain around 630 metal temperature, but after when I check that there is oxidation in the heater, then we limit the metal temperature is 590. And according to, we work on that during daily operations. We already said that we heater metal temperature, burner tilt. We have prepared a model for burner tilt control, and gap mill operation also introduced. A dashboard also prepared for different coal mill combination to reduce the heater metal temperature. This is an add-on model we have prepared with the Ariva company. We prepared this add-on model. This is an advanced center for diagnostic and reliability enhancement. We use this model. This software is there, for Prism software. We use this model to check warning against any changes in the every equipments. For BTL, we check
the early boiler tube leakage by checking the SLD position. SLD, if greater than 2%, SLD is the acoustic steam leakage detector. If moisture in the flue gas is increased, if pressure shifting, furnace pressure is shift, if ID fan current is increased. So by these techniques we check boiler tube leakage very early, and this reduce the secondary damage of the boiler. In-house, we have implemented a ABT system. As already shared that we have prepared for the new DSM regulations. So different regulations coming from last 3 to 4 years. We participate in RIS, we participate in SCD, and now AGC is coming. So we normally prepare this model, ABT monitoring system, and we maintain our DSM through this model. So as flexibility is the concern, we think many retrofitting can improve this flexibility for varying ramp up and ramp down. So we are consulting with different plants and different companies like Siemens for controlling the tuning the controller. So we have several strategies that we are taking several digital tools for performance enhancement. As Jindal said that we are also introduce our implemented our logics in the mill section for biomass co-firing, and next 3 to 4 months we are somehow procuring the biomass pellets, and FGD also in the erection and commissioning stage. We thought that in 2024 we are starting the FGD, and we 2% ramp rate we have to demonstrate. Thank you.
Thank you, sir, for giving presentation on interplay between CRC regulation, at the same time maintaining the efficiency parameters of power station. Chemistry plays a very important role in power plant operation, and our next paper is related to this on the topic chemical cleaning and its safety aspects. It will be delivered by Dr. Ashish Garg and A. Srinivas Rao, who are working in chemistry department at NSPCL Bhilai. I invite them for their presentation.
पीछे से ले लो.
A very good evening, sir. Myself, Dr. Ashish Garg, and my colleague Srinivas Rao, RAT, both Deputy Manager from NSPCL Bhilai, are going to discuss about chemical cleaning and its safety aspects. Boiler 3 chemical cleaning in PP2 and condenser chemical cleaning in PP3 has been completed in 2022. Chemical cleaning removes deposit from inside of the tubes, which reduces tube failure and improves the efficiency of the system. But at the same time, chemicals and their reactions are associated with the hazards, and these hazards may lead to the incidents. To avoid such incidents, safety in chemical cleaning is very challenging. Utmost care has to be taken in each and every step of chemical cleaning, not only for the system but also the manpower involved in these activities. First, I will discuss about boiler chemical cleaning and its safety aspects. At PP2 and SPCL Bhilai, the installed capacity is 74 megawatt. Steam is being supplied to Bhilai steel plant from PP2. That's why the DM water maker consumption is very high, that is 140 meter cube per hour. Due to frequent tube leakage in boiler 3, the boiler tube sample has been sent to NTPC Netra for deposit analysis. In this report, the deposit quantity in hot side, that is 29.1 to 191.2 milligram per centimeter, while in the cold side, that is 16.7 to 74.2 milligram per centimeter square, while the limit is less than 40. Hence, NTPC Netra recommended chemical cleaning of boiler 3. For this, a contract has been awarded to Messrs. RA Chem Private Limited. The cost is 21.9 lakhs. All the chemicals, site fabrication, cleaning process and sample analysis were in the scope of the contractor under the supervision of NSPCL, and this activity has been performed from 24 August to 4 September 2022. These chemicals have been used in the acid cleaning, hydrochloric acid, corrosion inhibitor, thiourea, ammonium bifluoride in the acid pickling process. After the receiving of these chemicals, the efficiency of the corrosion inhibitor has to be ensured to protect the base metal. For this, a sample coupon of same metallurgy has been dipped in 0.3% acid inhibitor and 5% HCl at 70 degrees centigrade for 6 hours, and the corrosion rate found 0.0196 milligram per centimeter square per hour, while the limit is less than 0.1. Hence, the efficiency of this corrosion inhibitor is satisfactory. For the chemical cleaning process preparation, site has been fabricated as per the schematic diagram. All connections have been checked with water to ensure no leakage. Power supply from different MCCs was ensured. A temporary lab was set up near site, and sample lines were checked for the collecting of samples. A pressure gauge has been installed in the superheater back filling line, and the temperature meter installed in the boiler system filling line and the return line. This is the flow diagram of chemical cleaning process. Before the superheater filling, the superheater was plugged, and then the superheater backfilled with a solution containing hydrogen and ammonia, and the pressure raised to 2 to 3 kg per centimeter square. After the superheater backfilling, the butterball tube samples has been suspended in the boiler drum to check the efficiency of the cleaning. Then the boiler system has been water washed till the turbidity reaches to the less than 10 NTU. And in the acid pickling process, the acid recirculation was limited to maximum 6 hours, or till the iron and copper concentration reaches to the constant value. Then the system has been water washed for 1 hour, then the citric acid rinsing done for 2 hours, then in the DM water rinsing done for the boiler system till the iron concentration reaches to the less than 25 ppm. And in the neutralization process, the boiler system has been neutralized with the soda ash 0.5% and recirculator for 6 hours, and the first stage passivation, a solution containing hydrogen and ammonia recirculated for 20 hours. After the first stage passivation, the boiler drum and the water valve tube sample inspected, and all the temporary connections were removed, and the boiler system has been restored for the regular operation. Then in the second stage passivation, the solution containing hydrogen and ammonia filled in the boiler drum, and the 40 to 45 kg pressure has been maintained for the 24 hours. Care has to be taken that after the acid pickling process till the DM water is before neutralization, the boiler system has to be drained under nitrogen capping to avoid the atmospheric oxidation, and the effluents generated in this process has been suitably neutralized before disposing of. These are the critical parameters. In the acid pickling, the iron concentration is 6360 ppm and the copper concentration is 2096 ppm. In this entire chemical cleaning process, we have faced majorly 3 challenges. First is the mismatch of nitrogen gas cylinder. As I have said, after the acid pickling process, the system has to be drained under nitrogen capping. But at that time, the pressure regulator was not matched with the nitrogen cylinder, and to meet this requirement, a pressure regulator has been borrowed from the chemistry PP3, which is 5 km far away. And second is the dust from fly ash silo and movement of ash bulger. As we all know that in PP2 there is a space constant. Fly ash silo is near to the boiler 3, and the site fabricator for chemical cleaning in the vicinity of the ash silo. During checking of temporary connections with water, fly ash dust was there. This fly ash may get into the boiler system and it is harmful for the manpower involved in the activities. To prevent this risk, ash bulker movement was restricted entire the chemical cleaning process. Third is the non-availability of chemical dosing tank for second stage specification. After the first stage specification, all temporary connections were removed, and in the second stage specification, we have to dose ammonia and hydrogen in the boiler drum. And chemical dosing in boiler drum can be done only by the HP pumps. क्योंकि हमने सारे प्रिपरेशन वो टेम्पररी कनेक्शन हटा लिए हैं, तो उसमें डोजिंग करने के लिए सिर्फ HP डोजिंग पंप्स हमारे पास होंगे. But in the PP2, there is only one phosphate dosing tank for all the 3 boilers. To dose hydrogen and ammonia in boiler 3, a temporary SDP drum was arranged without affecting the phosphate dosing in boiler 1 and boiler 2. This is the picture of the water valve tube samples coupon inside the drum. These are the pictures of acid pickling process. Now inspection and discussion. Before the acid chemical cleaning, a red color of hematite layer can be seen in the boiler drum and the water valve tube samples. And after the chemical cleaning, an intact magnetite layer of black color can be seen in the boiler drum and the water valve tube samples. Estimation of deposit material disposed through the chemical cleaning. As the iron concentration is 6360 ppm and copper concentration is 2096 ppm, hence the quantity disposed is 727 kg and the 210 kg of copper oxide. In this chemical cleaning process, we have majorly maintained 3 types of safety. First is for safety for chemical storage, second for manpower, and third for the process or the system. Safety in chemical storage. All chemicals were stored in a well-ventilated place. Chemicals stored as per chemical compatibility chart. These chemicals were inspected for quality and quantity. Chemicals cleaning started after ensuring all the chemicals available at the site. Safety for manpower. Chemical cleaning area has been barricaded. Unauthorized entry was restricted. 2 numbers of safety shower and eye washer were installed at the site, and they have been checked twice in a day. Safety instructions were displayed in local language at the site. Emergency contact number and ambulance deployed at the site for entire the cleaning process. Safety pep talk has been given prior to the chemical cleaning and on daily basis. We have ensured use of acid-proof PPEs. Fire extinguishers were made available at site. As we know that when acid reacts with heating metal, hydrogen gas liberates, and this hydrogen gas is very flammable, and it may cause explosion with the mixture of air in contact with spark. An incident in 2003 in UK has been happened of explosion due to liberated hydrogen gas. To avoid such incidents, cutting, welding, smoking or any other activity which may cause spark were strictly prohibited, and before boiler drum inspection, it was well ventilated. Safety for the system. Efficiency of corrosion inhibitor has been ensured. During acid pickling process, acid inhibitor recirculated for 1 hour before acid dosing. After addition of acid inhibitor, further steam injection in system is not allowed. To maintain the temperature, the recirculation tank, return line and filling line were insulated. HCl concentration was limited to maximum 7%. HCl recirculation was limited to maximum 6 hours. In every step from acid pickling to till the neutralization process, the boiler system has been drained under the nitrogen capping. By ensuring all these safety measures, boiler 3 chemical cleaning was successfully completed. Now I like to call Mr. Srinivasa Auredi for further proceedings.
Thank you, Ashish. Good evening, sir. Coming to chemical cleaning of condenser tubes, Unit 2 PP3, NSPCL Bhilai, and its safety aspect. The activity is done in November 2022. Coming to technical details of condenser, number of passes to cooling water flow through the condenser 34,500 meter cube per hour. Material of construction is all ferrous, and delta T across the condenser is 8.5 degrees centigrade. The background of chemical cleaning is Unit 2 overhauling in the year 2020. During overhauling of Unit 2, when condenser water box is opened for inspection, hard scale deposit was observed in the condenser tubes, and immediately an internal committee was formed with the members of MTP, Operation, TMD and Chemistry to study the scale issue. After studying the scale issue, the committee recommended for chemical cleaning in the next available opportunity. Based on the recommendation, we have moved for chemical cleaning. All the process chemicals like inhibited sulfamic acid, hydrogen, soda ash were procured by NSPCL, and site fabrication work and other services given to Messrs. Chemical Clean Services. Here 0.5 average thickness of the scale is taken as 0.5 mm for the calculation of quantity required for chemical cleaning. And inhibitor efficiency was checked at site when we have received sulfamic acid. This is a process flow diagram of chemical cleaning process of condenser. Initially, temporary circuit was fabricated at site, and this circuit was tested for leak by filling and recirculating fresh water, and after that descaling step was done. After that, draining and water flushing. Here the draining of acid effluent was done in neutralization pit near DM plant. After that, neutralization of the system. After that, final water washing and given to further proceedings. These are the pictures that shows the fabrication work done near the site. This is solution tank, tank internals, wall arrangement, vent and internal lines and temperature gauges, sample points. Coming to descaling process, initially the temperature of the solution was raised to 55 to 65 degrees by passing the steam, and after that inhibited sulfamic acid was introduced in the system, and 3 modes of the recirculation, that is top to top, bottom to top and top to bottom, was ensured to get the maximum exposure of the scale to the acid solution, and sufficient venting is ensured because CO2 gas will be liberated during the chemical cleaning process. If it is not vented out properly, this may damage the system, and acid concentration is maintained in inlet and outlet lines. A temporary laboratory was set up near the condenser. Levels of pH, iron, total hardness and acid concentrations in the inlet and outlet of condenser were monitored as per frequency, that is every half an hour, and when hardness and acid concentration levels reached stable values, the recirculation was stopped and acid effluent was drained. And acid, as I said, acid effluent was drained to neutralization pit, and it was neutralized with hydrogen lime and disposed further. And system was neutralized by the circulation of sodium carbonate solution. And this is the pictures through during the chemical cleaning. You can see the sludge coming from condenser tubes. This is the data, the chronological data that we have followed the process from time to time. You can see here for pass A we have followed the sequence, and for pass B we have followed the sequence. From chemical analysis data from pass A, the total hardness level maximum that we have achieved is 39,700 ppm, and for pass B 44,900 ppm. According to calculations, the quantity of scale removed comes to 4.37 tons. From pass A, from pass B 4.94 tons of scale that was removed. These are the condition of the condenser tubes before and after chemical cleaning. Pass A inlet, pass A outlet, and pass B inlet, pass B outlet. And these are some of the challenges that we have faced during the chemical cleaning. Initially steam flow was taken from unit 1 gland steam header drain lane. So required steam flow we could not achieve. Immediately after steam connection taken from unit 1 condenser starting ejector. However, the switching of the steam connection process got delayed. Distance of the NPIT from unit 2 condenser is around 600 meters, and the draining was done under gravity. So it has also taken little bit longer time. And agitator system in the recirculation tank, as agency didn't provide any agitator system in the recirculation tank, and we are adding solid chemicals to the solution tank. So we had to do agitate system manually using metal pipes. This increases risk of exposure with a hard solution. And coming to safety aspects, we can divide into system and process safety and personal safety. Under process safety, we have to ensure availability of all resources before starting up the process. And inhibitor efficiency checking was must to protect the base metal from corrosion of the descaling agent. Venting to be ensured to save the system from CO2 gas that is being released. And usage of calibrated instruments must. And complete neutralization of the system is also to be ensured before stopping the recirculation. And coming to personal safety, training was given to all persons who are involved in the handling of the chemicals and fabrication work, and safety shower fabricated near the site itself, MSDS displayed at site, and medical facility kept ready at site, and adherence to safety regulations like usage of PPE strictly implemented at site. And these are the pictures that shows our good practices. An MSDS displayed at site. This is the safety shower we have fabricated at site. And these are safety pep talk pictures. And this is the barricading of acid effluent disposal line. This is barricaded to save commuters from any acid exposure. This is the award winning for best safety practices. And coming to conclusion, boiler chemical cleaning in PP2 and condenser chemical cleaning in PP3 successfully completed without any incident. Since then, there is no leakage in boiler 3 PP2, and vacuum of the condenser was improved from 0.110 KSC to 0.088 KSC. And finally, chemical cleaning is not just a process, rather it is a program which requires inventory, cost, safety and interdepartmental coordination and time-bound actions as per site requirement. Based on our observations, we recommend that recommendations and observations by expert group shall be followed in given time to avoid any further damage of the system. Quality and quantity of the chemical shall be ensured before starting of the process, because once cleaning process started, it can't be stopped after starting without proper neutralization. Inhibitor efficiency must be ensured to safeguard the base metal. These are the references that we have used during cleaning. And finally, thank you for giving us nice opportunities.
Thank you, Ashish and Srinivas. Our next paper is also related to chemistry. The paper is from NSPCL Durgapur on the topic case study of regeneration failure of strong acid cation resins and improvement in OBR. The paper will be presented by Shri Parag Jharia, who has served in NTPC Farakka, Korba, and presently he is serving in NSPCL Durgapur as Manager Chemistry, and Kumar Anand, who is Assistant Manager Chemistry at NSPCL Durgapur.
Good evening, everyone. And thank you for giving us the opportunity to present our work in front of all of you. And with the permission of the chair, I can present. Okay. So this is the topic of our presentation: a case study of regeneration failure of strong acid cation resin and improvement in OBR. So this is the overview of our dual plant, and we have two streams of 35 meter cube per hour DM water production capacity, and the main topic is OBR improvement. So first we need to understand what is OBR. OBR is the output between two regenerations. Suppose we have one vessel of resin, and we regenerate it and take some production. It gets exhausted after giving some output, and that gap between the two regeneration is called its OBR, output between two regenerations. So the expected life of a resin is nearly up to 10 years, and after this period the resin gets deteriorated over time, and its output gets decreased. And in this presentation we are talking about this vessel SAC-A, a strong acid cation resin, and this presentation is a work of total 1 year, but we kept it very simple because there is a huge amount of data, so we kept only relevant slides. So earlier what is happening is, when we are regenerating this resin, we are not getting proper output. As you look in this data, जैसे जैसे हम रीजनरेशन कर रहे हैं, बट वी आर नॉट गेटिंग sufficient output. So this is the trend what we get in the past. जैसे कि आप देखेंगे, in this period of time we didn't get any output, and with our mechanical team we discussed this problem we are facing, and after getting so many inputs, ideas and maintenance activities, we finally set our target to improve our OBR from 280 meter cube to 600 meter cube from this resin.
Good evening, sir. After discussing with mechanical team, and after we have set our target, this was the target. 280 meter cube was the average OBR of cation exchanger bed Agra, and we have set the target more than 600 meter cube. And we thought about the two types of problems: chemistry related problems and mechanical related problems. First, we checked the raw water and makeup water quality, and it was found okay. There was no any change in makeup water. And after that, we sent the resins to Netra, and based on the results, the water retention capacity of cation exchanger and cation exchanger Agra and Bombay, both beds have gone up to the level of 60%. And in that case, we have to replace the resin. This was the action taken. Rubber lining and overhauling was done for cation exchanger bed Agra, and damaged strainers were replaced. Same resins was used in the vessels and taken in the service. However, we didn't get any improvement in the OBR. Therefore, we decided to replace the resin with fresh resin.
Sir, as I said, this is the work of 1 year. हम लोगों ने इतना जल्दी शुरू किया, and we decided to replace the resin. That is not the case. हमने बहुत सारा काम किया, उसके बाद ही अल्टीमेटली इसको रिप्लेस करने का डिसीजन लिया.
During the replacement, sir, four or five strainers was found damaged, and it was rectified by the mechanical team. And however, we are observing the frequent regeneration failure, and after that we have consulted with OEM, the Ion Exchange India Limited, to find out whether there are any problems in the resin, quality of resin. But they suggested that there were no any problems in the resins, and they told us that there were any problems inside the vessels or vessels related accessories or parts. So we observed the service inlet valve, there was adjusting problem, and because of that the acid feeding during acid injection, the regeneration was not getting proper, and we replaced the valve with the help of mechanical team. Inlet flushing line was also checked, but there was no, it was found okay. And after the replacement of the injection line valve, the flow from acid drain line was okay. Before that, the flow was very improper. Sometimes it was coming very fastly, sometimes it was coming very less. We checked the power water line and injector of acid metering tank during acid feeding, and both are found okay. However, the regeneration was not, the OBR was not satisfactory, sir. Then it was observed that the air vent line, the flow from air vent line was very less. And vent line was found choked with rubber bulging. After few months of time, the rubber was found bulged in condition and it was choking the vent line. And it was then rectified by the turbine maintenance department. After that, the normal regeneration process of cation resin was followed with 5% of HCl solution, and then it was the method was not working because the acid 5% of acid solution which we have fed into the system, it was not coming in properly in contact with the whole bed of resins.
So, actually, we have one very experienced person in our DM plant, and I want to put his name in front of you, Mr. G.C. Konar. He has a vast experience in DM plant. So, he suggested that first we dose 0.2 metric ton of 5% HCl and keep it for some time. Then we will flush the inlet line. We will repeat this step twice and then go for a normal regeneration operation. So, by his experience, now we get more than 600 meter cube of OBR from that vessel. आया नहीं है सर, उसको बुलाना था. So, vessel का performance बहुत ज़्यादा improve हुआ सर, and as you can see that it is going above 1000 meter cube in one go, and this is the comparison. Before we have done 54 regenerations and we got OBR of 27,162 meter cube, but after that modification system improvement with 31 regeneration we got 33,380 meter cube of total production. So finally we achieved our target. OBR has increased, acid consumption reduced, and chemical cost according to that is reduced.
This is the reliability and cost control, sir. After improving the OBR of cation exchanger, the production of DM water has increased drastically and acid consumption has been reduced to 4 metric ton, and it was the acid consumption before was 7 metric ton. We have saved 3 metric ton per month of hydrochloric acid, and in rupees we can say 1,80,000 rupees we have saved per year. If we count the cost of acid during that time, it was 5,000 per metric ton. Now the current rate is 3,500 rupees. In that case also we can achieve more than 1,25,000.
Sir, and we will recover our resin cost within 5 years.
This is our learning, sir. These are our references.
Thank you, sir.
एक लाइन कहना चाहूँगा सर, मिटा दे अपनी हस्ती अगर तू मर्तबा चाहे, कि दाना खाक में मिलकर गुले गुलजार होता है. Thank you very much, sir. Any questions?
Thank you, sir. Now we will come to the last presentation of this O&M meet. This is from NSPCL Durgapur. The topic is wire to wireless Ethernet, a wireless system for remote equipment monitoring and control. The presentation will be delivered by Shri B. Dev and Shri Shantanu Singh, who are working in C&I department of NSPCL Durgapur. Shri Dev and Shri Shantanu.
Good evening. The topic for our 8th O&M meet this year is wire to wireless Ethernet, wireless system for remote equipment monitoring and control. Our team comprises of Shantanu Singh and I'm Budhaditya Dev. So the basic, to start off, we start off with the introduction, then we define the problem statement, the solution which includes the components and the implementation and the cost perspective, the results demonstration, the cost estimation if we implement it across the plan, advantages and future applications. So the brief overview. In this project we have used two Wi-Fi enabled programmable microcontrollers, ESP8266 and ESP01. We have set up a server client communication between them. Our aim is to provide a remote monitoring and also to control equipments. We have implemented this in our hydrogen dryer and GSC-VF. So what are the current limitations if we use a traditional method? If we use a traditional method, it's quite limited. Its accessibility is limited. Moreover, it's rigid. If we want to use a traditional cable, so it's difficult to modify or expand. Moreover, the cost perspective, it's quite cumbersome and expensive to install, and it's quite time consuming also. Moreover, from the maintenance point of view, it's quite vulnerable to damage and wear and tear. So what are the solutions that we are providing out here? We have developed three modules. One is on the right hand side is the client module. Just below that we have the server module, which also comprises a current sensor, which shows the on-off status, and on the left hand side we have the server module for controlling an equipment. This is the basic interface that we have developed. The first, on the left hand side we have a interface which shows the on-off status. It is basically developed in Excel Visual Basic. Just below that we have the Wi-Fi equipment control interface. On the right hand side we have equipment control monitor. We can use this monitor to analyze any data.
So जो हार्डवेयर हमने बनाया है उसको हमने अराउंड 2 माइक्रो कंट्रोलर्स बनाया है, दैट इज़ ESP8266 एंड ESP01. इस स्लाइड में हम उनका स्पेसिफिकेशन देखेंगे. ये दोनों कंट्रोलर्स वाइडली यूज़ होते हैं IT एप्लीकेशंस के लिए, क्योंकि ये बहुत स्मॉल साइज़ में हैं और बहुत कम पावर में काम करते हैं. दैट इज़ अराउंड 3.3 वोल्ट्स. इन दोनों कंट्रोलर्स के जो नंबर ऑफ पिन्स हैं वो 17 और 2 है. नंबर ऑफ पिन्स दैट इज़ जनरल पर्पस इनपुट आउटपुट पिन्स. ये पिन्स को यूज़ करके हम प्रोग्रामिंग के ज़रिए इससे जो भी काम है वो करवा सकते हैं. तो नेक्स्ट पार्ट इज़ इम्प्लीमेंटेशन. इसमें हम हार्डवेयर और सॉफ्टवेयर पार्ट देखेंगे कि हमने इसको कैसे इम्प्लीमेंट किया है. तो जो हम पहले देखे थे कि ये सर्वर और क्लाइंट कम्युनिकेशन पे बेस्ड है, तो इसमें एक मॉड्यूल को सर्वर की तरह डिज़ाइन किया गया है, दूसरा क्लाइंट की तरह डिज़ाइन किया है. इनके बीच में कम्युनिकेशन हो रहा है इन्फॉर्मेशन का और कंट्रोल सिग्नल्स का. जो पहला पार्ट है वो सर्वर का है. सर्वर पार्ट में हमने ESP8266 का यूज़ किया है. इसमें 17 नंबर ऑफ GPIO पिन्स हैं और इसका प्रोग्रामिंग यूजिंग Arduino IDE की किया गया है. सर्वर मॉड्यूल थ्रू इंटरफेस एडिशनल हार्डवेयर दैट इज़ करंट सेंसर्स एंड रिले मॉड्यूल्स, ये इक्विपमेंट के पैरामीटर्स को सेंस करता है और क्लाइंट को कम्युनिकेट करता है हमारे HMI पे डिस्प्ले करने के लिए उसके पैरामीटर्स को. और सिमिलरली क्लाइंट मॉड्यूल इज सिंपली टेकिंग ऑल द इंफॉर्मेशन फ्रॉम द सर्वर मॉड्यूल और डिस्प्लेइंग इट और द इंटरफेस. सो दिस इज़ द हार्डवेयर फॉर ऑन ऑफ स्टेटस. इस हार्डवेयर में हमने 3 पार्ट इम्प्लीमेंट किया है. पहला है करंट सेंसर. इट्स सिंपली ए करंट एम्पलीफाइंग सर्किट विच इज़ इंटरफेस विद एन एंटीना. तो ये जब भी हम किसी इक्विपमेंट के प्रॉक्सिमिटी में रखते हैं, ये उसका ऑन ऑफ स्टेटस सेंस करता है और कंट्रोलर के थ्रू उसको कन्वे करता है हमारे क्लाइंट मॉड्यूल को उसका स्टेटस. और नेक्स्ट पार्ट इज़ फॉर रिमोट ऑपरेशन। तो चूँकि हमें किसी इक्विपमेंट को कंट्रोल करना है, इसमें एडिशनल एक रिले मॉड्यूल को इंटरफेस किया गया है विथ ESP8266। ये upon receiving control signal from our HMI, that is the command for on off, ये रिले को एक्चुएट करेगा फ्रॉम NO to NC कॉन्सेप्ट, जो कि हमारे इक्विपमेंट के पावर मॉड्यूल में जाएगा और जिससे इक्विपमेंट को हम कंट्रोल करेंगे। नेक्स्ट पार्ट इज़ द सॉफ्टवेयर पार्ट। तो these two फ्लो चार्ट शोज द हाउ सॉफ्टवेयर वर्क्स। जनरली इसमें क्या है कि स्टार्टिंग में हम हार्डवेयर सेटअप करते हैं, दैट इज़ जो ग्राफिकल पिन्स हैं, हमारे जो जनरल इनपुट आउटपुट पिन्स है, उसको डिफाइन करना है कि किस तरीके से काम करेंगे। उसके बाद हम डिसाइड करेंगे कि ये वाईफाई जो कनेक्टिविटी है उसको किस मोड में रखना है, स्टेशन मोड या एक्सेस पॉइंट मोड। उसके बाद ये कनेक्शन को सिक्योर करेगा और लूप में आ जाएगा। लूप में आने से जो हमारा क्लाइंट मॉड्यूल है वो सेंसर से सारा इन्फॉर्मेशन गैदर करेगा और सर्वर को कम्युनिकेट करेगा। और फॉर कंट्रोल पार्ट, सर्वर से कंट्रोल कमांड जाएगा क्लाइंट को इक्विपमेंट को कंट्रोल करने के लिए। तो इसका हार्डवेयर कॉस्ट क्या है? जो हमारा सर्वर मॉड्यूल मॉनिटरिंग के लिए है, इसका कॉस्ट जो माइक्रो कंट्रोल कॉस्ट है वो 350 आएगा। पावर सप्लाई अराउंड 100 रुपीज़ और करंट सेंसर जो हमने बनाया है उसका कॉस्ट 50 है। तो इट इज़ वेरी लो कॉस्ट एंड इट इज़ ओनली 500 रुपीज़। फॉर कंट्रोल पार्ट जिसमें एडिशनल रिले मॉड्यूल है, इसका कॉस्ट अराउंड 150 रुपीज़ एडिशनल है, तो उसका टोटल कॉस्ट अराउंड 600 रुपीज़ आ रहा है। और क्लाइंट मॉड्यूल जिसमें सिर्फ और सिर्फ पावर मॉड्यूल है और कंट्रोलर है, इसका कॉस्ट अराउंड 350 आएगा। रिजल्ट्स एंड डेमोन्स्ट्रेशन।
So first of all, we have implemented this in a Unit 1 GSCVF of our CPP2. So the client module is in the proximity of the equipment, and when it senses now this the equipment is on, so it senses and it transfers the signal to the server module, which is in the unit control room, and the HMI is also in the unit control room, and the mimic shows that the equipment is in on condition. Similarly, when it switches off, the client senses it, and the mimic toggles and it shows in the control room. Similarly, we have implemented this to detect whether the compressor in our hydrogen dryer is on or off. So similarly, we have placed the client module in the proximity of the hydrogen dryer, and so as soon as it switches on, the status is conveyed in the HMI in control room. We have also designed a data log sheet so that we can analyze the time stamping when the compressor switches on and off. We have a demonstration for this. So in this case, the device senses it, and it's in switched on condition. So as soon as if you switch it off, it senses the current. Current sensor. So as soon as it switches off, the mimic changes, and we can understand. This is part of our monitoring section. Similarly, we have a demonstration for where we have controlled equipment. In this case, we have used a lighting panel in our control room. This is the basic. This is the basic module that the blue one is the relay. We have used NC contact for this. So and we have connected this is a basic connection, and this is the HMI that we have used. We can operate it from this mobile device. We have designed this, And as soon as you switch on from this light panel will switch on. It has been switched on from the mobile device. Similarly, if we switch it off, the relay toggles and the light is switched off. So similarly, we can control and switch on any device which is in a remote location.
फुल स्क्रीन पे लाना है। अगर हम अपने इस जो अभी तक हमने देखा वो एक सर्वर और क्लाइंट के बीच में कम्युनिकेशन हो रहा था जिसका रेंज अराउंड 70 मीटर्स है। तो अगर हम इसको थ्रू आउट प्लांट इम्प्लीमेंट करना चाहते हैं तो इस टाइप का नेटवर्क हमें क्रिएट करना पड़ेगा, क्योंकि सर्वर और क्लाइंट के बीच में ओनली 70 मीटर्स का रेंज कवर होता है। एडिशनल नोड का यूज़ करके हम इसको थ्रू आउट प्लांट इम्प्लीमेंट कर सकते हैं। अगर हम इसका कॉस्ट एस्टिमेशन देखें कि कैसे कितना कॉस्ट आएगा, अगर तो एक नोड का जो रेंज है वो अराउंड 0.015 स्क्वायर किलोमीटर्स है। अगर हम 0.25 स्क्वायर किलोमीटर रेंज एरिया को कवर करना चाहते हैं, टोटल नंबर ऑफ 70 नोड्स का रिक्वायरमेंट होगा। पर नोड कॉस्ट अराउंड 350 रुपीज़ है। तो टोटल नेटवर्क क्रिएट करने में हमारा 6500 रुपीज़ लग रहा है। क्योंकि अगर हम ESP8266 यूज़ करेंगे जिसमें 7 GPIO पिन्स हैं, अगर पर 2 पिन अगर रिजर्व करते हैं एक इक्विपमेंट के लिए, जिसमें एक पिन होगा स्टेटस के लिए और दूसरा कंट्रोल के लिए, टोटल नंबर ऑफ 8 इक्विपमेंट्स हम कंट्रोल कर सकते हैं यूजिंग 1 क्लाइंट। और क्लाइंट कॉस्ट पर इक्विपमेंट जो आएगा अराउंड 75 रुपीज़ ही आएगा। अगर हम उस एरिया में 50 इक्विपमेंट्स को कंट्रोल करना चाहते हैं, टोटल कॉस्ट 3750 रुपीज़ आएगा। अगर हम ब्रॉडली देखें तो 0.25 स्क्वायर किलोमीटर रेंज में अगर 50 इक्विपमेंट्स को हम कंट्रोल करना चाहते हैं, उसका स्टेटस मॉनिटर करना चाहते हैं, तो टोटल कॉस्ट हमारा 10,250 रुपीज़ आएगा।
तो बेसिक जो एडवांटेजेस है हमारे, नंबर 1 इन हाउस है, तो एज वी कैन इन्फर फ्रॉम द प्रीवियस स्लाइड्स इट क्वाइट कॉस्ट इफेक्टिव। मोर ओवर डिप्लॉयमेंट काफ़ी इजी है, क्वाइट कॉम्प्लिकेटेड वायरिंग नहीं है, तो इजी इंस्टॉलेशन होगा। थर्ड इज रिमोट एक्सेसिबिलिटी। फ्रॉम रिमोट लोकेशन वी कैन एक्सेस द इक्विपमेंट्स एज वी हैव सीन फ्रॉम यूजिंग मोबाइल डिवाइसेस ऑल्सो वी कैन यूज इट। रियल टाइम मॉनिटरिंग है और मोर फ्लेक्सिबल है, ईजी मॉडिफिकेशन कर सकते हैं। सो फ्यूचर में हम लोग एक्सपांड करना चाहते हैं BOP इक्विपमेंट्स सच एज FOPH DM प्लांट एरिया के इक्विपमेंट्स और भी कोई क्रिटिकल इक्विपमेंट्स है, वी कैन extend this there. Thank you, sir. Thank you.
Thank you, sir. Now this concludes all the presentations of today's O&M meet. I will now request Jha sir to kindly summarize the session 3.
Good evening. Now we are at the end of the O&M meet presentation part. All the papers presented in the last session were extremely useful and directly applicable for power plant professionals. This innovative modification for enhancement of this dry coal extraction part, that is very practical approach. They had specified 5 problems and 5 corresponding solutions. Actually, we also can use, think of cleaning BFP strainers, CEP strainers by compressed air, thereby reducing the time of cleaning, which they are implementing. We can use it in our power plants also. This presentation of Maithon power plant, Maithon power station was fantastic. I mean, the research behind it, 6-7 years continuous data and its evaluation was wonderful. And we can implement many part of this, their findings, their practices in our power plant. Of course, our plants are old. We have our own limitations, but still many things can be learned and utilized in our plants. Incidentally, we have some questions for that team by Amit Pandeyji of JPL. Maithon Power people are here? Sir, there is a question. What about NOx, oxygen O2 percentage, auxiliary air damper and fuel air damper opening at 40% load? Mike.
As I said in the presentation that before going to the 40% MTL operation, we have carried out different tests related to coal flow measurement, SADC operations. So during SADC operations, we have carried out at full load at 60%, and when we go for 40% MTL operation, that time also we modulate the SADC. As per the BHL curve, there is up to 60%, but we extrapolate the curve, and according to the flame stability, we have control it on manual. And as far as SOx and NOx control is concerned, this fuel air damper control is also helps to control the NOx, and the mil D, which having the variable orifice for controlling the fuel, that is also helping to NOx control.
Thank you. There is one more question for you. Deviation of drum level, mainstream HRS temperature during 40% to 100% load ramp up and down, load ramp up and ramp down.
Yeah, for drum level control, there was a fluctuation, but we have introduced some manual bias system, which helps us to mitigate the fluctuation, keeping the drum level on auto. So in auto, system is taking care of the drum level, but still the deviation which are generated in a transient moment, that are taken care by manual bias, which is operator based control. And as far as mainstream and reheater temperature are concerned, mainstream temperature was within the limit, that is in 10%, but reheater temperature, there was a variation. So we are working on that. In the presentation, we have already demonstrated that reheater temperature for control, we are having the burner tilt, which logic we are modifying as per the metal temperature, as well as taking care of the reheater steam temperature.
Thank you.
Thank you, sir.
And one last question. Reheater flow and to avoid high MTM of reheater tube while taking heater in service. Well, पंडित जी क्वेश्चन पर
Sorry, Jha sir, for the inconvenience for understanding the writing. Sorry. Actually, the question was that how you taking care of the reheater flow, right? While charging your heater during light up, because during light up we are having the very smaller quantity of the flow inside the reheater. So it might be it might cause of the scarcity of the flow through the reheater, and it might in turn result in the failure of the tube. So how you are measuring that flow, whether if you are, and what sort of the measurement you have done to know what capacity of the steam flow is there inside the feeder?
See, for HP heater charging, we are introducing very small quantity of steam to gain the feed water temperature to mitigate the SOC. And here we don't have any direct reheater flow calculation, but from HP bypass flow we can extrapolate that how much flow is going through the reheater. And for heater, there is a chance that if we raise the feed water temperature higher than the saturation temperature at the economizer inlet, there is a chances of steaming. So to avoid that, we have incorporated online saturation temperature monitoring in the DCS. So based on the pressure and temperature, it is indicating that how much temperature margin we have that we can gain in the feed water to avoid economizer damage.
Thank you. Thank you, sir.
Thank you, sir.
The race 3 presentation about chemical cleaning, safety aspects, then resin saving in resin improvement, and this wire to wireless. All these 5 presentations were wonderful and very useful. I thank all the participants for their nice presentation and for your patience hearing. Thank you.
Thank you, sir, for summarizing the whole session in so nice words. Now I request Jha sir to kindly felicitate the participants of this session by presenting them shawl. I request Shri Ravi Jeti and Shri Ranjan Das from Tata Power to come on dais. Shri Satyavir Kumar and Shri Swara Zodi from BSP SAIL. Dr. Ashish Garg and Srinivas Rao, NSPCL Bhilai. Shri Kumar Anand and Shri Parag Jharia from Durgapur. Shri B. Dev and Shri Shantanu Singh from NSPCL Durgapur. Now I request CEO sir to come on dais and kindly felicitate the session chairman, Jha sir.
क्या चीज साहब को पहना देना है या आपको ठंड लग रही है
Thank you, sir. Now we have come to the conclusion of this today's ceremony. I will request CEO sir to give us feedback and further course of improvement so that we can further improve during our next program. Sir.
Thank you. A very long day of deliberations and interactions. In today's world, it's basically collaboration and knowledge sharing which matters. It's because of this idea, we at NTPC as well as NSPCL normally organize this kind of meet to share our knowledge, to enhance our capabilities, and to look into the unexplored areas where someone else is putting their ideas into actions. So I think to that end, this type of knowledge sharing and get together kind of thing is very important. And I am very much thankful to each of you for coming over here and sharing your knowledge. I am particularly indebted to Durgapur team for putting a hard work, very hard work, for making this a grand success. And I am thankful to our director, Sri P.K. Sarkar Sahab, for being with us for a long time and hearing us and giving us enough encouragement for this event. I think all the papers, some papers, I should be truthful to all of you. Some of the papers are excellent. We have some takeaway from some of the papers. Some of the papers are at par, I will say. And some of the papers, the organizer, that is our corporate team, should have screened much more before putting into this forum. But keeping in mind that last 3 years, we are not organizing this kind of meet. So starting is important, and sharing of ideas is important. So most probably on that front, our team, corporate team is somewhat lenient in selecting papers, and I think the quality of the papers will improve in future and next time. So with this, I congratulate all of you. I thank all of you coming over here and sharing your knowledge. And in future to come, NSPCL will organize this type of meet, I think every year, and I will expect a lot of participation from all of you. Thank you.
Thank you, sir. We are beholden to you for your kind and encouraging words. Now, this concludes this O&M meet. So there are some announcements to be made. Dikshit sir.
We are starting after half an hour. Cultural program will be started here, and all are requested to be present here, and dinner already arranged for everybody's. So we'll start at 8:15. Okay, we'll start our 8:15 cultural program is there. Everybody are invited to attend this program. Thank you. बोल दिया already. And followed by dinner also. We have already declared the followed by dinner also is there. Okay, thank you.
अननेसेसरी बहुत सारे PC22 करके एक फोल्डर क्रिएट है
मुझे इसमें कुछ काम का है वो मैं कॉपी कर लेता हूँ प्रेजेंटेशन और वो वीडियोस ठीक है
प्रेजेंटेशन सेम है वीडियोस जो है
यही तो ना
हाँ
इसमें यही सब
यही है ये एक है और ये एक है दो वीडियोस लीजिए
दो वीडियो ये भी है
हाँ वो एक है नहीं दोनों एक ही है एक पिक्चर है ये दोनों वीडियो लीजिए और एक वीडियो आप ले सकते हैं जो है